Welcome back, everyone. Before we dive into Redux, I want to take a quick second to talk about Redux Toolkit. Now, as you go through the Redux documentation or in your own Googling, you may come across the fact that the Redux documentation says that the suggested way that you work with Redux is to use their library, Redux Toolkit. Now, Redux Toolkit, right here it says, is the official opinionated batteries included toolset for efficient Redux development. The key thing here is that it's opinionated, meaning that Redux Toolkit as a package is designed by the Redux team to make it easier for you to write Redux. The reason why it's easier is because there's a bunch of quality of life improvements that people have realized over the years that Redux has been around. Redux has been around for quite a long time, and as a result, many companies using Redux have complained about certain things, which we will explore extensively in the next few lessons. We're going to use just React Redux. You can use React Redux and Redux Toolkit together, but you can also use just React Redux when it comes to working with Redux inside of our React application. What Redux Toolkit does is that it makes it much easier to write Redux code. But here's the thing, because it's easier, it's also easier to not fully understand how Redux really works with the bare bones. This is why, for me, when teaching this course, I want to work with just React Redux, even though it has a steeper learning curve. The reason for this is because you need to understand how Redux truly works and understand the data flow. Because despite the fact that it has the steep learning curve, it's very important to me that you 100% understand everything that's happening inside of Redux. The moment you understand how it works, then you can learn Redux Toolkit much easier. Because again, Redux Toolkit is designed to make it easier to write Redux code, but it doesn't change any of the core concepts inside of Redux. All Redux Toolkit is really doing is it's making it easier for us to actually work with the parts inside of Redux and write the code there. Right now, this might sound like a lot of mumbo jumbo, but once we start working with it, you'll understand what I'm talking about. Now, I'm going to cover Redux Toolkit much later in the course. Once we've worked extensively with Redux and we understand all the parts of Redux, then I think is a good time to work with Redux Toolkit, because you'll understand what it is that Redux Toolkit is improving upon and why it's easier. But you cannot skip the process of going through that difficulty of learning basic Redux. At least in my opinion, you shouldn't. The other thing too is that a lot of companies have not opted to use Redux Toolkit yet, whether it be because they don't want to introduce a new library into their existingly really large and extensive Redux applications. Another reason might be they disagree with some of the opinionated natures that Redux Toolkit has taken. So as a result, it's very likely that you might work at a company that doesn't choose to use Redux Toolkit. And as a result, you need to understand then how to write Redux without Redux Toolkit. So that's what I'm going to do. I'm going to teach you React Redux by itself without Redux Toolkit. And then later on the course, we'll cover using Redux Toolkit to convert our application from using just Redux to Redux Toolkit, which it will be much more clear what it is exactly that Redux Toolkit is doing that makes it easier for us to work with. But again, it's important to me that you understand how it is that Redux works without Redux Toolkit, because then it's much easier for you to absorb all of the complexity of Redux and also why it's so useful. So that's just a quick aside that I have about Redux Toolkit. Don't worry, we'll cover it later in the course once we understand Redux. So I'll see you in the next lesson. Welcome back, everyone. In this video, we're going to break down Context API versus Redux at a very high level. I know we haven't actually written any code for Redux, but at least we've worked with reducers and Context API, so here we should be able to find some kind of knowledgeable ground when it comes to the theoretical parts of Context API versus Redux. And it's important to understand these theoretical differences when we start coding out Redux, so we at least can understand where Redux sits inside of this whole ecosystem much more clearly. I want to note that there's really only two main differences inside when it comes to Redux versus Context API, and it has to do with the accessibility as well as the flow of data. So accessibility here is the accessibility of the data, and that's what we are going to start with. So let's imagine we have our application here. I've stripped it down a little bit so that it's a little more clear. And what we have is just the app at the top level, and then we have our shop preview on the left and the cart on the right. Now, the key thing I want you to remember here is that the shop is on the left and the cart is on the right. We have 3 different contexts right now also wrapping around the entire application: cart context, categories context, and user context. These 3 contexts are wrapped around the entire application because any component can access the values in these contexts. But in reality, this doesn't actually have to be the case with context. Context is kind of just like a component. You can actually wrap it around smaller portions of the application, and only that part has access to that context. For example, with the categories context, only the shop page really needs access to what's inside the categories context. As far as the components in the shop are concerned, they're the only ones that actually call the use context hook to reach into that context and pull out the values. The components on the right side, which is our cart, might actually receive those products somehow through the product cards, but in reality, it doesn't actually itself reach into the categories context, so it does not actually need to be wrapped by the categories context. If you are a child of categories context, you will have access to the context. If you are a sibling of the categories context or a parent of the categories context, then you do not have access to that context. Now let's take a quick look inside of our application to understand how that works. So here we are inside of our index.js. As we know, we have this categories provider, and this categories provider is what allows us to reach inside the application to get the different products that we have. The only parts of the application that are reliant on the categories context, we can take a quick look. Everywhere where we call use context, we must pass it this categories context. So here we see that inside of our different components, we're only using it in 2 places, the categories preview and the categories component. If we remember, both of these are only components that live inside of the shop page, both the categories preview and the category. What we can do is we can actually take this categories provider and just wrap it around the shop component, like so, as a parent. In fact, actually, let's wrap the entire routes object inside of categories provider. The only thing we haven't done is we have not actually imported it in. So let's do that as well. Let's import in our categories provider. So we need to go up into our context folder, our categories context, and then we save this. And inside of our index, we can remove this. Well, we'll comment it out for now because we want to put it back. So now when we save this and we look inside of our shop component, what we should notice is that in theory, our code should still work. So here, let's go to our application. Let's go to our shop. Look at that. We still have access to this context. We can still add our components and add items inside of our go to checkout. So nothing is broken here. But one thing that I want you to notice is that if I try and access this categories context from outside of these 2 routes, meaning that let's imagine that we're trying to access it from, let's say, a different component. Let's say our cart, for example. We know that our cart lives outside of this shop component. It's a sibling. So here, what I can do is I'm going to say, okay, give me the categories context as well. And I want to pull this from categories context. There it is. And I'm going to say const categories map, which we know is something that we get, equals use context. And then I call categories context. And then what we're going to do is we're just going to console.log categories map. If we save this and we go back to our application, when we open up our cart dropdown, we see that we do log an empty object. But what you'll notice is that we see all of our other products. This means that our categories context has updated, and therefore there's a categories map object. However, why is it that our cart dropdown is still an empty object? Well, the reason for this is because categories context has an initial value, which is this. But what happens is that this object never updates. The hooking into all of the actual updates that happens from the provider getting the value and then this component updating lives tangential to what the cart dropdown has access to. So while it's true that we may be able to derive the default value, the initial value of the categories context, we cannot access any updated values from that provider. So this is how we've managed to now segment the accessibility of this actual context value from our provider inside of the categories context by wrapping it around the shop component. So this is one way. We can keep this code if we want. If you want to do this and you want to make sure that only the appropriate portions of your application have access to these respective providers, you can definitely do that. For me, though, I do believe that at some point as this application scales, we're probably going to want to have access to these categories in other places of the application, but it's very easy for you to move your code around and figure out where you don't want access. So I'm just going to revert everything that we've done here back to what we had. I'm just getting rid of all these providers. And there we go. So that's really about accessibility. With context, we are able to wrap the appropriate portions of our application and isolate the accessibility to only the children of where it is that we have wrapped our providers. Now, the difference between context and Redux is that Redux will always wrap the entire application. With this, just like how we have currently set up inside of our contexts, you have the same access to the Redux store, which is where all of our state is stored from the entire application. So it may not look different from context, but the thing is that you opt out of the choice. With Redux, your application will always have access. This is by design because it's called global state management. Global implying all of the different internal components of your application have access to the Redux store. Now, the Redux store itself is what handles the actual data, which we're going to talk about in the next video. But this is one of the key things I want to highlight to you about the differences between context and Redux. And along the way, we also learned about something new with context that we can do. There are times where you only want to wrap parts of your application inside of context and not the entire thing. So now that we're armed with this knowledge, let's talk about data flow. Welcome back, everyone. In the last video, we discussed accessibility of data based on Context API and Redux. In this video, we are going to reinforce that, but primarily also discuss the flow of data and how the structure of our code changes. Even the high-level concepts change a little bit, which we'll cover inside of this video. So let's start with context. Context we can mainly see as being separated into two portions. We have UI components, and then we have context with reducers. These context reducers are, of course, the components that wrap the corresponding UI components. So imagine if we had three different components in our app, component 1, component 2, and component 3. And then we had two different contexts, context A and context B. Let's say that context A wraps around component 1 and component 2, as we saw in our last video. Let's say context B wraps around component 3. Now let's say respectively, each of these contexts also have their own reducer, which they're using for state management. So this is what we wrote in the last few videos where we used the use reducer hook. Here, the flow of data for context A is we're going to have a dispatch that fires actions into reducer A, because use reducer, as we know, gives us a dispatch unique to that reducer. So we might pass that dispatch directly to components 1 and 2, or we might create action generator functions as we did inside of our context and then pass that down. Remember, that was our set current user, or that was our set is open. Those are all dispatch action based creators. So component 1 and component 2, of course, will then in turn potentially dispatch actions that update reducer A. Reducer A's state then will have some values which get consumed by component 1 and component 2. So this is the flow of data. The components drive actions into the reducers then drive their corresponding values to their components. This is going to be the same flow with context B. You're going to have component 3 dispatching actions to reducer B using reducer B's unique dispatch. And then reducer B, of course, is going to pass those values to component 3, which is what context B wraps around. So this is pretty much the flow of data that we've seen with our contexts. Now let's talk about Redux. With Redux, we still have UI components. So let's imagine that we still have the same 3 components, but now we also have this Redux store. And the Redux store structure is going to have 3 separate reducers. These are still functions that return objects, and those objects just carry the state of that reducer. So nothing here has changed. Everything you know about reducers is exactly the same. The difference, though, is that we have 3 different reducers. For example, you can have more, you can have less, it doesn't matter. But the idea is that you have A, B, and C reducer. These reducers all combine together into something known as the root reducer. The root reducer takes each of these and combines them into one giant reducer. From this reducer, we will then pass state into component 1, component 2, and component 3. You pass the entire state object. You don't just pass reducer A's value or reducer B's value. You pass the entire state object through to component 1, component 2, and component 3. And then similarly, what will happen is that these components, of course, are going to dispatch actions, but it's one dispatch method. Remember, with context, each use reducer gives you a new dispatch that goes specifically to the respective use reducer hook. Here with Redux, we have one dispatch action. Essentially, you're going to dispatch actions using the one dispatch, and all of these reducers are all going to receive those actions. But what happens is that we have to determine in the corresponding reducer what to update. So these actions may update reducer A, may update reducer B, or update reducer C. In fact, the same action can update all 3 reducers if these 3 reducers choose to update based on that action. But this is the different flow of Redux. So the main thing to understand is that there is a much more singular store. So as a result, there's a singular dispatch. And then it's up to our individual reducers, A, B, and C, to determine if they want to update their state appropriately. So in the next video, what we're going to do is we're going to take all of these concepts and we're going to focus on working with them in the code base. So join me in the next video where we will take all of these high-level concepts and push them into Redux code. I'll see you in the next video. Welcome back, everyone. In this video, we are going to talk about how we can bring Redux into our application and how we actually convert these concepts that we learned about Redux into our code base and the patterns that will emerge. In order for us to use the Redux library inside of React, we need to install 2 libraries, and then I'm going to install an additional one that will help us understand the flow of these actions inside of our data. So the first library that I want to add is the Redux library. So this allows us to interact with the reducers that produce the root reducer, which produce the store. Then there is React Redux, which gives us all the React bindings so that we can dispatch and pull these store values off of Redux. And then there's Redux Logger, which is a great little tool that helps us understand how actions are firing and what's happening with our state. So you don't really need Redux Logger. That's the additional one that I mentioned. I always like to install it because I like to see what's happening with my store, and I'm very used to using that service. But once we have these 3 libraries, what we want to think about inside of our application is what Redux replaces. So as I mentioned, most of the time, you do not want to use Context API and Redux at the same time. The reason is because what our user context stores can be stored by Redux, and it's confusing to think about where all of your information and state is being stored. The reason for this is because in Redux, there's this concept of a single source of truth, which means that all of your state should be stored in one place. Generally speaking, this is your Redux store. So if you have user data stored in a context as well as Redux, then that gets really confusing as to what goes where. And you have to manage more dependencies of where your state lives. So what we want to do is we want to replace this user context completely with Redux. Now, in this video, what we're going to do is set up the basic Redux into our application, which does involve quite a few steps. And one of the known things about Redux is the boilerplate code that we have to write in order to get this code working. But it is an unfortunate side effect of this. I do want you to follow along because it is very key that we set it up this way, and I'll discuss why we're doing it this way as we go. But I do want to pre-warn you that there will be a lot of steps that we're going through, so please bear with me while we do this. The first thing that we want to do is we want to set up a store folder. This store folder is going to contain all of our Redux code. Inside of our store folder, we need to create a file, which is our store.js. This store is what I mentioned earlier as this almost combined place where all of our Redux happens. So where our state lives, but also where we receive actions and we dispatch them into our reducers to update the state. You need this store file because inside is where we're going to generate the store object that we will use inside of our React application. In order to do this, we actually need to import in 3 different methods from Redux, the core Redux library. We want to import compose, we want to import create store, and we want to import apply middleware. I'll talk about these 3 as we go through this. What we also want to import in is logger from Redux logger. And again, I'm going to explain these concepts once we start getting to this portion. Every store, in order for it to work, needs reducers, as I mentioned. These reducers are what allow us to actually form the state object. So what we know is that we need something called a root reducer, if you remember. I mentioned that a root reducer is the combination of all of our reducers. It's kind of like one big reducer, if you want to think about your state being composed of multiple reducers. But we know that we need this in order for our store to have any kind of state value. Now, in order for us to build our root reducer, we are going to create a new file for this reducer, just so that we can separate out this concept. I'm going to call it rootreducer.js. Inside of here, I need to bring in a combine reducers method from Redux. And combine reducers is just a method that allows us to create a final big reducer that we can use inside of our store by combining smaller reducers together. And it's really just something that looks like an object. And to do that, what I'm going to say is that export const root reducer, so this is essentially the root reducer that we're creating, is equal to combine reducers. And then what we're going to pass into this parameter of combine reducer is an object where the keys and the values are going to be the name of the reducer slice and then the actual reducer function itself. So here it's a lot of boilerplate, as I mentioned, but each of these steps is crucial to understanding how it all fits together. I'm going to go over this all again as we build out our store. Don't worry. Right now, we just have to set up some things in order for this to work. So as I mentioned, we need a reducer, and we're replacing our user context. So what I want to create is a user folder inside of this user store, and inside I'm making a user.reducer.js file. This user reducer is going to literally be our reducer. So what we can do is we can actually take a lot of this reducer code that we have used inside of our context. All of this is actually the exact same. So this is one of the huge benefits we get from having already learned how reducers work inside of our codebase. Because with this, I can pretty much now just start using our reducer, but we have to make a couple tweaks according to how the Redux structure is different. So the first thing is that by default, because we no longer have the hook use reducer, if you remember, what happened here was that we passed initial state to use reducer. So the reducer knew that the first state is going to be this initial state value. Because we don't have that hook anymore, we need to give state inside of the function a default value, which will be initial state. So if nothing gets passed, then use the initial state. And the only time where state is not getting passed is when it runs for the first time. Because when your reducer initializes, of course, there's no state value. So giving it this initial state will allow us to know what the state value is. The other thing that's different is that all of our reducers react to every single action. As I mentioned with the user context, this previous user context used use reducer, and this use reducer returns you a dispatch. This dispatch, when called, will only fire actions to the associated use reducer that we got this from. So what did we get our use reducer from? User reducer. So any action you dispatch from this dispatch function you get back is going to dispatch the action only to this reducer. The same is going to be true for the cart context. As we know here, when we created our use reducer from our cart reducer, this dispatch will only dispatch to the cart reducer. It won't dispatch to the user reducer. This is where it's different because every single reducer receives every single action inside of Redux. So as a result, by default, whenever we don't respond to an action, because it's very possible, we might get actions where the type has nothing to do with our user reducer. It only has to do with our cart. If that happens, all of our cases, of course, are not going to switch. So then by default, we need to return back the current state. Only by returning current state does our code know, oh, okay, this part of my reducer did not change. Because as I mentioned, state is an object. Everything in React is referenced by memory. So because state is an object and it's the exact same previous object in memory, this reducer does not need to update. And this is going to be important when it comes to our re-renders, which again, you've probably heard me talk about numerous times. We're going to understand that once we start working with this reducer. So I'm going to export this out so that we can import in this user reducer into our root reducer. So I'm going to say import user reducer from user.reducer. And then using user reducer, I'm going to say, okay, inside of congruent reducers, we're passing an object. I want the key to be equal to user, and I want the value to be the user reducer. And now our actual final state shape is going to be this object where it's got user and then the actual state of the user reducer. So as we add more to our root reducer, this is how it'll grow. Now, just to go over what we learned as far as the differences in reducers go. Our reducers in Redux receive every single action that gets dispatched ever. And also we need to, as a result, return the default state. That is one thing you need to remember when migrating your existing reducers over from context into Redux. But also this is one thing to know about Redux reducers and how reducers work in the Redux flow of data as a whole. Key thing, actions pass to every single reducer. So that means that every single reducer by default needs to return the previous state if none of the cases match to the type. So that's what we need to know about reducers inside of Redux, as well as composing our root reducer. In the next video, let's continue building out our store. Welcome back, everyone. In the last video, we learned about the differences in reducers inside of Redux versus context. We also learned about how to create our root reducer. In this video now, we're going to take this root reducer and we are going to bring it into our store.js. So first, what we're going to do is just import root reducer from our root reducer file. And now what we want to do is we want to finish building out this store object. So in order to do this, what we need to do is we need to understand what fundamentally creates a store. So I want to say export const store is equal to calling this create store method. So when we create a store, this store takes 3 arguments. The first one is really actually the only one that is necessary, and that is the root reducer. So it's really simple. You need a root reducer in order to generate the store. It's that simple. All of these reducers, as we know, are pure functions. They're functions that receive a state and an action, and in turn, they return you back some object that represents the values in the state. This store is just in order to facilitate the movement and passing of actions through these reducers. So all a store really needs is just the root reducer in order to be created. But in order for this to be useful, we also want to pass it this logger. And this logger is essentially something that allows us to see what the state looks like before an action is dispatched, what the action is, and then how the state in turn looks after the action. So it's very good in order to help us see that. In order to do that, we actually need to create this thing called middlewares. Middlewares are kind of like little library helpers that run before an action hits the reducer. So whenever you dispatch an action, before that action hits the reducers, it hits the middleware first. So here, what's going to happen is our middlewares is just going to be including our logger. The only thing, though, is that in order for our middlewares to be passed into create store, we actually have to pass it as the third argument. The second argument is if you want to add any additional default states here. This is added so that we can actually make it easier to test, but we'll talk about that much later. For now, I just want you to pass undefined because it's an optional second parameter. The only other thing as well is that in order for these middlewares to actually work, we have to call apply middleware. So what we can do here is we can say, hey, these middlewares are actually something like enhancers. So in order for this to work, you have to generate it using compose. So I want to say composed enhancers is equal to calling compose with apply middleware and then passing middlewares in. Spreading it actually as the argument. So what this will do is it'll pass every single middleware that we have if we had more. You can imagine if we had middleware 2 or middleware 3, like all these different potential middlewares that are helpful for us, which we'll learn later on. This will allow us to spread it into this apply middleware argument as subsequent arguments. Compose is a functional programming concept. It's essentially a way for us to pass multiple functions left to right. We don't really need it in a lot of the code rewrite, but as far as this composition pattern is concerned for Redux, this is something that we need to have. We'll discuss this more again later in the course. Right now, I just want to focus on creating the store. So right now, these are just the steps that we have to go through in order to actually create what the store wants for us. So we're going to take these compose enhancers and pass them as this third argument. Because there's different types of enhancers we can have. Middleware is just the primary one. So here, essentially what we're doing is we're passing them through as this composed enhancers third argument. It enhances our store. The middlewares enhance our store. They catch actions before they hit our reducers and they log out the state. That's an enhancement, which is why we have this step. So now that we've generated this store, what we need to do is we need to add this into our application. In order to do that, if you think about it, we know that Redux is available throughout the entire application. This means that chances are there is some type of provider that actually wraps the application, because that's the only way we know that we can have this kind of access throughout the application. We learned this with context. We create our own provider and we wrap the application. Anyone that's a child inside has access. And it turns out that Redux has always been using Context API under the hood, even before Context API was popularized. So Redux has always been using providers in order to give us this functionality. So it's very similar. We import in a provider from React Redux, which is their own provider instance, very similar to the one that we created. And we want to wrap the application inside of this provider. Once we've wrapped this provider, the next thing that we need to do is we need to pass in the store. So this provider is expecting a store argument, which will be the store that we created. So we want to import in store from our store folder and then our store file. And the store object is just what we're going to pass in. So going back to our store.js, this object is what we're passing to our provider. And now, technically speaking, we have our reducer set up. The only thing is that we actually have not hooked anything up to this reducer. So how do we do that? Well, this of course is where we need to actually figure out how to, 1, dispatch actions, and then 2, get the values out of our store into our application. And this involves the steps of using actions and dispatch. So we'll talk about that in the next video. In this video, there was just a lot of configuration and setup, a lot of which is not necessarily super sensical because we're just learning all this setup for now. But if you follow along and once we get to the actual full flow, all of these pieces will start to make more sense. So in the next video, let's discuss actually interacting with the store now that we have this set up. I'll see you in the next video. Welcome back, everyone. So in the last video, we generated our store, and we're also now passing it into this provider that we use to wrap our application. This provider, of course, we get from React Redux, which behaves just like the providers that we have used so far. Speaking of providers, what we need to do is we need to now figure out how to replace our user provider utilizing the reducer that now lives inside of our root reducer in Redux. So it's going to be very similar. We know that there's a dispatch, and we know that we need to get the current user object. It's just that now, instead of coming from use reducer, it comes from 2 different hooks inside of React Redux. First and foremost, we are no longer using a user provider, which means we need to get this value somehow from our actual application in another way. The main thing is that currently inside of our user provider, we actually fire off this use effect, which subscribes to our on-auth state change listener. Depending on this is how we actually update using effects to get this actual value we need. So how do we do this? Well, we actually want to move this into our app.js, because prior, when you think about the index.js, the first thing that mounts is actually the user provider. So the moment the user provider mounts, it fires off the effect. We no longer are relying on this provider anymore. In fact, we might as well just remove it so that we can be very clear that this is no longer something that we're using. What we're going to do is we are instead going to rely on the part of our application that mounts first, that cares about the user. In fact, the entire application, we need to make sure that we have our user. It's a very top level thing that matters. So what we're going to do is we're going to paste in that use effect code that we had from our user context. We also need to make sure we bring in all these dependencies that we need. So we know that we need use effect. We also know that we need all of these different libraries. So actually, let me just copy this over because chances are we're going to need a lot of it. So I'm just going to copy this over. I'm going to move this down to where we have our own internal imports. And then I just want to make sure whether or not these are actually pointing to the correct thing. So here I believe that we need to reduce this relative route because essentially we're at the root folder and now we're pointing to the correct files. So we need access also to this set current user value that we had before inside of our user context. This is the last thing that seemingly has not been imported. So let me also get rid of this use reducer and this create context. So what is set current user? Inside of user context, set current user is this action creator function that we made that dispatches an action inside of our provider. So now we still want this action creator, but because this is getting called in app.js, we don't want to localize this selector inside of app.js. Instead, we want it to be potentially available to anyone that wants to set current user. Even though we only use it inside of app.js, that doesn't mean that will always be the case. So this is where we're going to make a new file inside of our store user folder called user.action.js. And what this action is going to be is pretty much the exact same thing as this action creator right here. So let's actually copy this over like so. Its set current user is a function. It receives the user, and what it will do is instead of dispatching here, it's just going to create and return us back the action object. So the action object is generated using our create action helper function. So let's first import that in. The other thing is we need our user action types. So this user action types is living currently in our user reducer. So what I like to do is move this up into its own file again, called user.types.js. And here, this will be an export. By doing this now, it's at the root folder level of this user because inside is where it's primarily getting called. So I want this to be shared between all of the files in this folder. And it's very clear what lives inside this, which is everything related to our types. Because sometimes as you add more actions and you add more code to your reducer, this grows to a point where it becomes really hard to read. So we might as well do a lot of this separation. These are just scalable techniques that we've learned throughout the years of building scalable React applications using Redux. So this is it. We also need to export out this action creator, and now set current user is pretty much the exact same as you see. It's just now reduxified. So it's just a function that retrieves a user object, and then what it will do is it will create and return back a object where the type is this user action string, and then the value is the user for payload. So now that we have this, let's go back to our app.js so that we can bring this in for set current user call. So here, I also want to get rid of this create action because the action is getting generated inside of our action creator now. So first, what I'm going to do is I'm going to import in this set current user from our store folder, our user folder, and then our user action creator. Now, here's another thing. As we know, our user set current user is no longer dispatching. This is now just creating an object for us, which is our action object. We actually still need to dispatch this. In order to do that, we need to bring in dispatch from useDispatch hook. Now, this useDispatch hook is what we get back from React Redux. As I mentioned, React Redux is the library that gives us React bindings, which are hooks really, that allow us to interact with the Redux store. So we can say, hey, const dispatch is going to be the method we get back from the useDispatch hook. And this dispatch works exactly the same way as our user context dispatch. But as I mentioned, this dispatch dispatches actions to the root reducer, which in turn passes the action to every single reducer function. So here there's only one dispatch from React Redux. There's only ever one instance of it. In fact, if you hover over this warning here, you'll see that there's a missing dependency for dispatch. The thing is that dispatch here, coming from useDispatch, never updates. It's always going to be the same reference. So here, really, dispatch will never change. You don't have to pass it if you don't want to, but if you want the lint error to go away, you can pass it as well. The reason why this complains is because React does not know that this dependency that it's getting from a hook, this dispatch, doesn't change. We know this because we know that the way that React Redux works is that it only generates one dispatch for us and it will never change that reference. But because the hook doesn't know, it's going to complain and send you a warning because we are using this dispatch inside. This is just one of those things. It varies honestly from team to team whether or not they add or not because this kind of is misguided in some way. This implies that this effect will rerun every single time that this dispatch changes. But in reality, this dispatch is not going to change. You can see where this confusion might lie. So it's really up to you. Personally, I like to get rid of it because I know for sure anyways, this effect is only running on initialization in order to set up this listener anyways. So we can just set it up like this. Some of these warnings, you really do need to use your own judgment. Unfortunately, the linting is a little aggressive and this is a very contentious topic, but that's another conversation. For now, what we have is set up our code. So let's go back to our application and see what happens. Here we see these new logs. These logs are what I was talking about. Essentially, this is what tells us the previous state and the current state. So let me just refresh so we can see it live. So we see one action fire. This action fires when our code initializes, and then we see that this is our initial state, current user equals null. We remember this inside of our new user reducer, where state is the default state, the initial state. Then what happens is that because our auth listener, we're already signed in for our application. Our auth listener is aware, oh, let me get that user. And then what happens is our code triggers. So it fires that new action that we dispatched, the set current user. And what happens here, you'll see that there's the type set current user, but there's also this payload. So here, all of this is working. And then in the next state, of course, our user reducer is going to respond, and it's going to update current user with that new user object that we got as the payload. So this is really handy because every time an action fires, you see what was the previous state, what's the next state of the entire Redux state. Right now, we only have one reducer, so you only see the one value. But as this scales, you will see all of your state. So again, you have one centralized state rather than multiple contexts that have different reducers. Here, it's all in one location now. And this is the Redux flow. So now that we understand how to create and dispatch actions, in the next video, what we are going to do is learn how to actually pull these values off of state and then use them in our application. I'll see you in the next video. Welcome back, everyone. In this video, we are going to learn about getting the values inside of Redux into our components. So how do we do this? Well, there's actually another hook that we need in order to extract data out of Redux. And this is called the useSelector hook. So useSelector is a hook that allows us to interact from a component with the Redux store. What is a selector, though? So first, in order for us to make use of this useSelector, let's just get rid of what we currently have in context. useSelector is a hook that you pass a selector function. And a selector function is something that essentially extracts off the values that you want from the whole entire Redux store. So the state, as I mentioned, is one big object. The object, of course, is composed of all the smaller reducers, but in the end, it's really just an object that has these key values on them. So we actually receive inside of our selector function, whenever you call useSelector, the entire state object. So when you want specifically the user reducer, you're going to have to say state.user. And then from the user state, we're going to want further the current user property, like so. And then we just need to cast this to some variable, which I'm going to call current user. And now current user being referenced here will be this current user object inside of the Redux store. If we come back to our application, we now see we indeed have the current user being rendered. And of course, that selector will go into our Redux state. It will go, okay, I have this whole state object. I'm going to go and get the user reducer. And then inside the user reducer slice, I want the current user value, which is this object here. So if you refresh, what you'll see is that initially we saw the sign in and then we saw the sign out. So this is because that Redux updated. If I hit sign out now, notice that this still worked. And the reason why it works is because our selector updates whenever the state object changes. And here is exactly what we see. Set current user set the payload of null to this user value. Current user is being referenced using the useSelector hook right here. So whenever this state object changes by reference due to Redux, as I mentioned, every time whenever we update any of our reducer values, we always return a brand new state object with the changed values. When that happens, the selector will rerun current user updates and then React will re-render this component. So this is how you can now select values off of Redux and then put them into your components. So one thing to note is that a lot of these selectors are just functions that take state and then return you back the value that is deeply nested that you want. These might actually be reused though. we might want to reuse the current user selector. So what I want to do is I want to set up a file inside of our store called user.selector.js. And this will contain selection-based selectors. So I'm going to call it select to know that this is a selector function. And I'm going to say select current user is just the same function that we had. It selects off the state. It gets a state.user.current user. And now we just import this into our navigation component. Let's go up to our store folder, into our user selector. And now we can just pass this in where we had our originally hard-coded selector function. And now if we save this, and we go back, and we refresh, here we see that we are with an empty current user value. But if we sign in, there we go. We see that we're still pulling the correct value from our new reducer value. So this is selectors. We've pretty much now learned all of the basic bits and pieces of working with Redux. What I want you to do is I want you to think a little bit about all these parts that you've learned. Because a lot of this is more confusing due to all of the boilerplate that we had to set up. We created 4 different new files: actions, reducers, selectors, and types. And in order to utilize it inside of our React component, we had to build out a store object. We had to build out a root reducer. There's just a lot of moving pieces. So despite the fact there are so many pieces, it is something that will definitely come to you with practice. Because as you practice, you'll realize why each of these pieces are necessary. And what I want you to do is actually think about how we generated and set up these selectors. So now that we have all these bits and pieces, before you proceed, I really want you to make sure that you understand all of these moving parts that went into this Redux migration for just the user context. In the next video, we are going to reiterate on this and convert another context over to Redux. I'll see you in the next video. Welcome back, everyone. In the last video, we learned about how we could migrate our user context code into Redux. In this video, we're going to do the same thing with our categories context. And along the way, we're going to learn a couple nuances about how the flow of data in Redux might change the way that we actually think about the logic in how we store our state. So with our categories context, we just want to migrate exactly what we see over into Redux first. So to begin with, we know we need to make a couple files in our store folder. So I'm going to make a new one called categories. And inside of this categories, we will need, of course, a category reducer.js. I also need a category.action.js. We also know we need a category.types.js. And finally, we know we need a category.selector.js. So I'm just setting up these files because we know we're going to need them later. So let's start coding out our reducer. What we know we need is we know we need the initial state. So categories, initial state, which is going to be an object, and inside it will contain our categories map. So nothing different here from what we have in our context as the value. And then, of course, as we know, we need our categories reducer, which will be equal to a function that receives the state, which by default is equal to categories initial state. And then we get an action. Off the action, we want to destructure off the type and the payload, which will be equal to the action. And we also want to make sure that our action, if no action is passed and for some reason our reducer runs, by default we pass an empty object just so that there's something to call. And then we write our stitch statement on our type. So a lot of this, again, is just going to be very basic boilerplate code that you write with every reducer. It's also good to get this practice when you're typing this out so you remember every single step. And we probably will want to set categories map once we get it from wherever we get it from. So we'll figure out what the types are after. We know that we want to return something with our default state. And we also know that we want to update the categories map with our payload. So structurally, this makes perfect sense. We haven't even written our action creator yet, but we pretty much know that this is what it's going to be. And then, of course, by default, we return the state. So now that we have our reducer, we can, of course, figure out if we need to tweak this later. But we got to take this reducer and we want to put it into our root reducer. So we want to import our categories reducer from categories, category reducer, and then add it to categories on the root reducer. So now that we have our categories reducer, what we want to do is we want to create an action that will update this category, just like we did with our user action. So I'm going to copy over create action from this user action file so that I can paste it in without having to do it myself. And I know that what I need to do is create a set categories map action. And this is going to get a categories map. And then what I'm going to return is call create action with that type that our reducer is expecting. So here, I can take this string and I'm going to make the new category type for this. So I want to say const categories action type is equal to an object where set categories map points to categories map the string. If I want it to be a little bit more explicit, I can even say that this is a category / set categories map. This way, when I look at this, I know that the first term tells me which section of my store this is governed by. So similarly, I can do the same thing with user types as well. I can say user / set current user. Just in case you ever come across a time where you have these action type names that kind of seem similar to your other reducers, you can imagine that at an app at scale where you might have 50 reducers, this might get a little bit more clear in order for us to set this up. But now that we have our category action types, we need to make sure that we export this out so that we can import it into the appropriate places. So importing our action types from category types, and we'll need the same thing inside of our action. And then here, for the create action, I'm creating set categories map and passing the categories map. And of course, we can't forget to export this out as our action creator. So we have our action creator, we have our reducer, we've connected our reducer. Oh, I also need to remember to actually update the value in the reducer. There we go. So we have our reducer and we have it inside of our root reducer. So now there's nothing actually stopping us from starting to migrate the application. At this point, you have a categories reducer and you also have your category action that will set your reducer with the new categories map payload. So now that we've set up our reducers, I want to challenge you to figure out if you can actually manually now replace the categories context with what we have here. I'm going to give you a hint. What you're going to want to do with this categories context is you need to find a new place for this code. After you're done with figuring out where this code is going to go and what you need to replace accordingly, you're probably going to also need to make sure that you can extract this data from your state. And to do that, you're going to want to use some selectors. So that is my challenge to you. I want you to figure that out. And what you can do, in fact, if you figure it out, is you can even delete the categories context. Here, we've actually done everything we need to with moving the user context over. So in fact, if we look for our user provider, we only have it referenced inside of our user context. And if we look for user context, we also see it's only referenced in the user context file. So nothing is stopping us from deleting this user context.jsx. And that's because we fully migrated. So that's my challenge to you. I've helped you set up a lot of our initial boilerplate for the reducer. Now my challenge to you is to figure out if you can actually leverage this in code and try it yourself. In the next video, we will tackle this together. Welcome back, everyone. In the last video, I challenged you to set up the category selector and migrate the category context code to the appropriate place where we're fetching our categories map. So what I want to do is I want to walk through this with you when it comes to thinking about where we want to put this fetching, especially this API external fetching code inside of your code base. So some of you might have moved this into your app.js, likely where we had previously our subscription to the auth state change listener. Technically speaking, there's nothing wrong with doing this, but if you think about it, the app component does not actually need this categories map data. The first component that actually needs this categories map is actually our shop page. Inside of our shop page, we have categories preview and category. Both of these components, the category preview needs categories map, and the category component needs the category map. So their nearest ancestor is the shop component. And the shop page component can actually be the one that fetches the code from our categories context, which is to fetch the Firebase API, get down all those documents, create the categories map. So we can actually copy over and paste in that use effect that we had before. We'll of course have to tweak some of these so that they work in the context of Redux instead of in the context of our context API. Forgive my use of the word context here. In order to do that, we need to start bringing in the appropriate methods. So first, let's bring in our use effect hook from React. Let's also bring in our get categories documents from our Firebase utils. Let's go up to our utils file, Firebase utils. And then we also need our newly created set categories map action creator. So let's bring in set categories map, going up to our store folder, categories, and then categories action. So this, of course, is an action creator, which means we still need our dispatch, which comes from React Redux. And then it's just a matter of using this hook to get the dispatch and then wrapping it and calling it on set categories map. So there we go. Now, of course, at this point, we do still have access to our categories context. So this category component and the shop component are still hooked up to that. But if you look inside of this state object, we do see that we do have the appropriate categories reducer with the correct categories map. So now what we need to do is start using it. The first thing I want to do is I want to remove references to this categories context inside of index.js. So here, what we can do is just delete the categories provider. And the nice thing about this is once you remove it, your code will stop working because you no longer have access to the context. But what you need to do now is figure out where in your code you're still calling categories context. So clearly here inside of our preview component, as well as inside of our categories component. So first, let's start removing any references to this context because we're no longer using use context. Instead, what we're doing is we're using our selector, which we have not made. So inside of our categories selector, let's create a const select categories map, which is equal to a function that gets state. And then from the state, we pull off categories map, like so. Let's make sure to export this. Import this now into our categories preview component, going up to our store folder, categories, category selector. And then from React, we no longer need use context, but instead we need use selector from React Redux. And we'll just say, okay, I want to get categories map by calling use selector with select categories map. There we go. So here, now this categories preview should be properly selecting categories map. So what we can do is we can go to the shop page and we see that we indeed have our data. But going any deeper, we notice that we have nothing. So this is exactly as expected. We have not migrated over the category component. So let's do that now as well. I'm just going to copy this because I know this is pretty much a one-to-one change of what we need from the category component. So instead of this, I'm going to put this in. I need use selector. From React Redux. And of course, I also need select categories map from our store folder, our categories folder, our category selector. Let's save this. And now let's go back. And there we go. Our code is now properly migrated over to using category context. And we can now delete the categories context.jsx. And as we see, nothing in our application breaks because everything is now properly migrated to Redux. So I know there is just a lot of this kind of redundancy that we're going through where we're writing selectors, we're writing reducers, we're writing our action creators, we're bringing in the use dispatch, the use selector hooks. But this is all very important because so much of this is indeed boilerplate and setup. But the main benefit that we get, of course, is going to be still the unidirectional data flow, single source of truth for all of our data. And here now, as you practice and the more you code this, you will naturally just be able to infer all of the steps that you need and you'll understand why they're necessary. You need actions to actually create updates in the reducers. You need selectors to pull that data down. And then you have to set it all up inside of the appropriate store object. So all of this is just a cyclical flow that you have to get familiar with. But now that we've set this up, there's a couple things that I want to talk about. And that has to do with some of the more optimizations we can make to this setup that we have, now that we have two different reducers, which we'll discuss in the next video. So join me in the next video, and let's talk about optimizing this code. Welcome back, everyone. In the last video, we migrated over the context from categories into a reducer in Redux. In this video, I want to talk about one of the new patterns that emerges because we are now working in Redux, and where I want to focus our attention to is when we call our get categories and documents method. Typically, when we worked with our usual flow of data, we put our transformation logic inside of our utility helper in Firebase. The reason why we did this is because whenever we made the fetch statement, we knew that chances are we probably want to extrapolate this data in a format that we'll use, which was the categories map. In this video, though, I want to highlight one of the patterns that emerges with Redux, which is where you essentially pull your data, but you pull it in its most basic form. And what you do is you store that basic form of the data. So in this case, you pull just the docs as an array. And then when you store it in your reducer, essentially what you'll do is you will extrapolate the logic that transforms it into a category map into a selector. The reason for this is because our reducer, as I mentioned, should always store the most basic format. Essentially, it is the data that you get from your API. Then with a selector, what you do is you transform that data into the final shape that you want it to be. And the reason you want to do this is because you can have multiple different selectors that perform different transformations on the base format of the data you have. So imagine if we just had the array of the different collections. From here, maybe you want to select just one, or maybe you want to select multiple, or maybe you want to create a category map. Whatever option you want to pursue, by doing it this way, you're now able to extrapolate out this data into a much more targeted manner. Because now the selectors is where the logic lives, and the selector is that thing that transforms what the logic and base data you have into the final desired output. So this is a very important thing. Your selectors is where you do your transformation business logic. So what we're going to do is we're going to migrate our code over so that we follow this pattern. And the first thing that we need to do is we need to simplify the Firebase utils method that actually gave us our category map before. So here what I'm going to do is instead of generating the category map as we've done up until this point, I just want to comment this out for now so that we keep a reference to it. What I'm going to instead do is say, okay, instead I just want to return query snapshot.docs.map, because essentially we need to map out all of these documents in order for us to get the data. So what I'm going to say is doc snapshot should return doc snapshot.data like this. And now this get categories and documents will give us back the categories as an array. So before we start modifying any of our code, let's just make sure all of this is working. So inside of our shop component where we make this fetch, this is now a categories array. And before I dispatch anything, I want to console.log the categories array just to make sure that this method is now working. So let's go back here. And what happens is we refresh. We see, there we go. We get the array of our categories that we've got stored on Firebase. So now what we need to do is store this inside of our reducer, this new categories array. So what we'll do is we will tweak our category reducer in order for it to reflect accordingly. So here, what I'm going to do is instead of calling set categories map, I'm just going to say set categories. And then I need to update, of course, the actual reducer, but also the action. Because the action is now going to call set categories. And instead of passing a categories map, we're just going to pass a categories array. Now here you can be very explicit about this being categories array, like so. But either way, we're just updating this naming convention. And the name of the variable, the actual logic of the function, exact same. Nothing's changed. Inside of a reducer, of course, we want to update set categories like so. And then instead of categories map being an object, categories will now be an array. And then here we'll just update this like so. So up until this point, just a lot of renaming, nothing really that different. But where this gets interesting is that instead now, select categories map is going to be something that selects state.categories.categories, and then we have to transform this array into our final categories map. So here, what I want to do is I want to take that logic that we had commented out, because this is probably where we're going to do that exact transformation that we had before. And that code lived inside of our Firebase utils. And it's really just this code right here. So I'm just going to copy this, get rid of this last comment that we don't need, go back into our category selector and just paste this in. So essentially what we're saying is, hey, give me the categories and reduce over it. Now, instead of a snapshot, we're going to get the actual category object. And then we no longer need to fetch off of the data because it's already the data. So we get the title, we get the items, we accumulate over, lowercase the title, set it to the items array. And now if we save this, What'll be interesting is that select categories map is something we're still using throughout the application. So this actually won't need to update wherever we're calling it, because now the selector still will work. Before it was just pulling off the value, now it's transforming the value. But what we want to do here is we want to just make sure that we're updating with the right call. So instead of set categories map, now we're calling set categories. Like so. And then categories array gets passed to set categories. And now if we save this and we go back to our application, let's just refresh to make sure that that error was not our error. But here we see, we call set categories. Categories get stored as this array. And then all of our components are still working because our select categories map code is still working because that selector is now transforming it into the categories map, which we can pull. So that's it. This is one very, very common pattern that you have to understand when it comes to using Redux and reducers. You can even extrapolate this when you call use reducer in your context, but it's a lot more clear when you actually write out the separated file structure that comes with Redux. The selector file is where this reducer specific transformation business logic is going to live. So one of the things that you may be thinking about now is that, well, Yihua, if every time we call our selector, essentially what we're doing is we are rerunning this reduce function. Is it not going to be the case that every time we make different calls, we are actually going to be re-rendering this reduce, which may actually prove to be significantly less performant? Well, this is actually one of those trade-offs that we're going to talk about in the next video. There's a couple things that emerge from this pattern. The main thing I want you to realize, though, is the logic of the pattern and the clarity that it brings, as well as the separation of the business logic. Whether or not this format is a little bit less performant than the previous one is a different question. We're going down this path because we need to learn this pattern, and we have to learn about why there are indeed certain bottlenecks that come. So that's what we'll cover in the next video. Welcome back, everyone. In the last video, we migrated over our selector code from our reducer so that we were able to convert our categories array that we store inside of Redux into the categories map that we use in order to access our categories quickly and efficiently. In this video, though, I'm going to highlight a lot of the new nuances that come with this pattern that we need to think about at every single stage of utilizing all of the tools that we've seen so far with React Redux, as well as Redux in general. So to begin with, if you have been console logging your component throughout this process, you may notice some really weird behavior that is happening inside of your components. And I will aim to demystify all of this alongside getting a deeper understanding of how these hooks work and how you need to think about architecting some of your application. So to start, I want to look at this category component. As we know, the category component takes the category name from the URL parameter, and then it pulls off the categories map from our new selector that will transform the categories array. And then what it does is it runs an effect that will update the products inside that this category uses, which will be an array, depending on when the category itself changes in the URL parameter or when the categories map updates. So there's a couple things I want to do. The first is that I want to console log render/re-rendering component. Now this is important because we need to know when our functional component is being re-rendered. In fact, I'm even going to be more explicit and say category. Render/re-rendering category component. So we know. Then inside, I also want a console.log effect fired calling set products. And what I'm also going to do from here is I want to go into the selector and I'm going to transform this. Make sure that we return back. And inside, I'm going to add another console log. And this is going to say selector fired. Now I'm going to save this code. And when I go into the application, there will be a bunch of new logs and there will be a bunch of orders, and it's going to be flip-flopping between Redux triggered re-renders, our own internal category triggered re-renders. There's going to be a lot, and I'm going to walk through it. And please bear in mind that there are going to be a couple jumps we need to make in order to understand all the pieces. So even if not everything makes sense at once, follow along, and in the end, it will all make sense. So the first thing we need to do, let's go to our application. I want to go to hats, and I'm going to refresh. What we see here is a bunch of different calls fire. First, what we see is selector fired. Actually, what I'm going to do is I'm actually going to move this up above the selector, because the selector right now is firing above the console log. And the reason for that is because, of course, use selector. Whenever the code runs top to bottom, when it hits the selector, it's going to call the selector. And we'll see this in action now if I refresh again. We see at first render re-rendering. So this is our initial component getting mounted onto the page. It's rendering. And what it will do is it'll walk through our code, hit the line where it's saying use selector, and then our selector fires. Then what happens is that our use effect will run, because our use effect, of course, is listening for category change, which is in the URL parameter, but it's also looking for category map changes. Now, both of these, of course, are initializing for the first time, so our effect will run regardless. So set products get called. When set products gets called, what you'll notice is once again, this selector fires and then the re-render happens here. Now you might be wondering, Yihua, why is this happening? Shouldn't the re-render happen before the selector fires? You would be correct. The reason this is happening is not actually what you think. This actually has to do with the way that this logger is confusing us. This Redux logger code, the way that it works is that in order for it to show you the next state, it actually needs to update the reducer first. And when the reducer updates, it's actually re-rendering our component. And there's a lot to unpack here that I need to do in order for us to understand this. The key thing I want you to notice is that even though this logger right here is occurring below the re-render and the selector fire, this is actually supposed to be somewhere before this block happens. And I'm going to explain why this is happening because it's a rather nuanced issue. First of all, why is in the first place set current user re-rendering this component? The reason for this is because the root reducer, as I mentioned, whenever root reducer updates any of these reducer values, the entire store object is going to be a new store object. So just like how our reducer, we spread through the existing state. If you think about our category reducer, we spread through the state and then we update the corresponding property. You can kind of see the root reducer doing the same thing for just the reducer that's updating. And then the other ones just retain their old state objects. So while with the set current user, the user reducer is a new object, categories reducer returns the old state object. So the categories reducer object is the same one in memory. The user reducer one is a new one. However, every single time this combine reducers store object is always a new one whenever any of these reducers update. So this is why, despite the fact that current user is the value that's getting set inside the user reducer, our category components selector function is still getting rerun. And the reason for this is because use selector as a hook is literally hooked into the Redux store. And whenever an action comes in, this will refire. So now, what I want you to take away is just that fact alone, that whenever any action fires, and as long as a reducer updates, it does not matter which part of the reducer you're listening into, every single component that has a use selector will rerun. Now, whether or not this triggers a re-render is going to be up to how we code out our structure. So this is going to be the first thing we're going to tackle. We're just going to tackle this topic first before we dive into anything else regarding all of these different logs, because I want to clarify and demystify this section. So that's what we'll do in the next video. We are going to talk about our selectors and how to prevent them from retriggering through better understanding of how these selectors work, as well as learning about how we can modify our own middleware so that we avoid this problem where this gets a little confusing, but also more importantly, so that we at least understand why this is happening. So I'll see you in the next video. Now, first things first, I want to take us back to this diagram which showcased our UI components and our Redux store. As a quick refresher, we have components on the left, we have our reducers on the right that combine into a root reducer. Actions get dispatched from our left side components, which then subsequently will update a corresponding reducer, and that reducer will combine into the root reducer state, which then gets passed to our components for them to select off of. Where does middleware fit inside this flow? Well, the first thing I need to do is make a little room. So I'm going to remove one of our components just to give us some space, and then I'm going to adjust it so that there's a little space in the top. Right there is actually where middleware sits in this flow. Actions still get dispatched from components, but before they ever make it to the reducers, they all have to pass through the middleware first. So here, let's imagine that we had our Redux logger as our only middleware. You can have multiple, but we just want to look at the one that we have, Redux logger. What happens is that, let's say you have this green circle that represents an action. This action gets dispatched from component 2 into wherever our store lives. This store, of course, now contains the Redux logger middleware, and this Redux logger receives the action. And just like any middleware, it's going to go through a sequence of steps. The first thing that it's going to do is it's going to perform some action with the action, or some logic with the action. In this particular case, it's going to log that action in that format that we saw. Then what it's going to do is it's going to call next. And what next does is next will explicitly take this action and pass it down to the remaining flow, whether it's more middleware or into the subsequent reducers, which they'll receive the action, update accordingly, and then the root reducer updates. So that is the flow that we are familiar with. Once the action enters into the reducers, we know what happens. The root reducer gets updated depending on the value returned by each individual reducer. So as I mentioned, we did this with Redux logger, which is just one middleware. But what if we had two middleware? The flow becomes the same. You have some action that dispatches from component 2. Middleware 1 receives it. It does something with it. And then what it does is it calls next once it's done. Now, it might call next when it's finished with the action, or it might do something else after next gets called. But we'll go into that a little later. The key thing you need to know about next is that the action now gets passed on, meaning that whatever comes after next is going to receive that action now. Until next gets called from this middleware, that action is not getting passed further. But now that we called next inside of middleware 1, middleware 2 receives the action, it does whatever it needs with it, it'll call next, and then this gets passed on, and as we know, the flow with the rest of our reducers, etc., etc. So now that we understand how middleware fits inside of the flow of our Redux logic, let's go back to our application and figure out why it is that our Redux logger is logging seemingly a little behind the actual updates coming from our reducers. Now here we are inside of our store.js. Inside of our store.js is where we generate our middlewares and then we add them to the store. And I'm going to show you how easy it is to write your own middleware. So first things first, I'm going to console out logger so that we can make our own logger middleware. The format of a middleware always follows the same signature. It's going to be 3 functions that return from one another. Now, if that sounds confusing, it'll make sense once I write it out. But in order for us to understand this, we need to understand the concept of currying. Now, pure and simple, currying a function is essentially a function that returns you back another function. The reason you do this is because maybe function A receives some variable A. What happens is that the return function here might use A inside of it. But what it does is it depends on maybe 2 additional properties that you pass to it as new parameters for this function. So what happens here is that if we have some curry func is equal to this, now I can say, hey, I want a new function that says with A is equal to me calling Crwn-Clothing, and then I pass it some value here for this placement of A. Let's say it was the number 3. Now, inside, what I get back for with A is going to be equal to some function where it still receives B and C. So you still can invoke this function by passing it parameters B and C. But now this value 3 is where the A was inside of the function definition. So let's say we did something with it. Let's say we added B and then we minused C, for example. What'll happen now is that I can say with A and then passing it 2 and 4. And now what happens is that when I call this, what's happening under the hood is it's going to take this calculation where 3 was passed in when this Crwn-Clothing was called. So now A is equal to 3. And then because 2 and 4 are added, well, it's going to add 2 and then subtract 4. So through this, you're able to create this function creator that is actually very dynamic. We can use Crwn-Clothing to make a bunch of different functions. This should, say with 3. I can make another one with 10, which is equal to Crwn-Clothing passing the 10 value. And now again, I can say with 10, and then I can pass it different values. It's really just a function generator, and it allows us to create reusable function. And in our particular case, with middleware, we're creating reusable middleware functions. Now, these are chained create functions. So what happens is that the first function receives the store object. This in turn returns another function that receives the next method, as we saw, the thing that allows us to pass on the action. Then the next function this returns receives the action. And then finally, inside of here is where we write our middleware signature. So this is where we write the code that we want our middleware to do. Now, let's think about what we want this middleware to do. Because all we want to do is very clearly just simply log out the appropriate action so we see what's happening. We're just duplicating this logger that we had before. So first what I'm going to do is I'm going to say, okay, I just want to make sure that if there's no action type, it doesn't come from us sometimes. Sometimes you might receive an action that we may not need to receive. This is oftentimes possible when you're working with things like Redux-Thunk and whatever. We're just accounting for that. If you're unfamiliar with Redux-Thunk, I'll explain it in a later video when we cover Redux-Thunk. For now, just understand there are times with external additional middleware that you pass, you may receive actions that don't have types on them. If that happens, don't worry. We'll just say, hey, I'm assuming this is not for me. I'm just going to pass this along. So we call next.action. We're done. We return from this middleware. Nothing happens afterwards. But if there is an action type on it, then we want to console log it. So first what I'm going to say is console log the type. And this is going to also show action type. And I also want to console log the payload. So we see what we're logging. And again, action.payload. Now here, what I want to do is I want to console log the current state. So I'm going to say current state. And here I'm just going to put store.getState. GetState will give us back the value of the state right now. At this point, this looks like the first half of the logger, which is where it shows us the action and it shows us the previous state. But what it needs to show us is the next state. So how do you derive the next state? Well, it turns out the only way that the logger can actually get this is from the store object. But how does the store actually get us the new state? Well, it will only get us the new state if it's updated once it's run through all of the reducers with the action. And this is where we need to say, hey, I want to call next on the action. I want to pass the action along now. And what I'm waiting for is when that action finally hits the reducers and updates, because all of this is happening synchronously. The moment this next call happens, action gets passed on, subsequent middleware will all run, reducers will all run, and then only when that is complete will any code after this next fire. So here, if now we say console.log next state, like so, and here, if we recall store.getState, this is where we now see what the new state will be. And this is what we want to pass into our middlewares. So let's go back to our application and see this in action. So now when I refresh, what you will see is that we have a different order. We have our original category component rendering for the first time. Our selector, of course, fires. And then you notice that the effect fires. But look what happens now. The effect fire called setProducts, but we're not actually updating anything. Our setCurrentUser action now dispatches because, again, our auth listener is hooked up. The user object comes in, and we see inside of our new logger middleware, which is inside of store.js that we just wrote, we see that we get our user setCurrentState and we get the payload. We get the current state. And now what you notice is that our selector fired and our re-render is triggering on this component. The reason why we see this from our category component firing is again because right after this log, this next happens. And as I mentioned, this is synchronous. So this action is now being passed to all the next subsequent middleware and all of the reducers. Only when all this update does finally our next state console log that happens on line 17 after this happen. But remember, the moment reducers run, all of our use selector methods are getting called. So before we ever hit this line, this next call is updating our reducers, which is updating our store object, which in turn is calling useSelector on all of our components. Even though the user is the one that's updating, as I mentioned, this useSelector is still going to run anywhere, regardless of what you're trying to select off of. Now, that is why before with the logger, you were seeing it fire that log after all of our component code had updated from the reducers being updated. Now, the reason why here it's a lot more clear and broken up is because we're not grouping those logs together. Redux Logger is taking the entirety of all these individual logs that we're making and then bundling into one log. Whereas as you notice, we're literally logging every single step so that we can synchronously see what's happening. Redux Logger doesn't do that. So this is one of those things you just got to know about debugging with Redux Logger, is that you got to think about the actions and when they fire, and then if you see the Redux Logger, sometimes it may be in conflict with when inside of your functional components and then with your useSelect hook, maybe there is some weirdness in the timing. Now, of course, you can just really easily write your own logger middleware as we've done, but we also get one from Redux Logger if you're comfortable with it. It's a very, very popular middleware, so that's why I'm showing it to you as well. But I also wanted to demystify middleware so that you really see it's really not that complicated. You just have something that wants to generate side effects with actions before it hits your reducers. And you can do that inside of this middleware. And again, all it is just a sequence of create functions. And there we go. Now we see what we get with this logger middleware. We understand why this is happening. We can just keep this for now while we continue debugging the remainder of this pattern that we're emerging from using selectors inside of our components. So hopefully this clarifies middlewares and loggers for you. In the next video, we'll talk about how we can optimize some of our re-rendering that's happening in our category component. I'll see you in the next video. Welcome back, everyone. Let's go through continuing to chat through what we're seeing with our console logs now that we have a clear, accurate example and knowledge of what's happening. So again, we hit our initial render for our category component. Our selector fired gets called because we're calling useSelector for the first time. The effect fires calling setProducts. And here you might wonder, Yihua, why is it that our effect fired calling setProducts, but then we didn't re-render? Well, the reason why is because our initial state for products is categories map at category. Categories map, by default, gives us an empty object if the array is empty, because select categories reduces over categories. The default value for categories is actually an empty array, if you remember, inside of our category reducer. So if you reduce over an empty array, you get an empty object. If you call any value on an empty object, what you're going to get back is undefined. So our initial state, of course, is going to be undefined. Similarly, with this set products, we're setting it to undefined. So if you set a previous value of undefined to a new value of undefined, well, remember, React is smart enough that when you're calling setState and you're trying to set it to a value that it using equality, strict equality, determines is true, it will not trigger a re-render. Why would it do so? It's realized that what you're trying to set is something that it already has. That means that it doesn't need to re-render this component. There's no re-rendering that needs to happen. So this is why you might see the effect fire, but again, we're not going to re-render because setProducts is not actually re-rendering the component. So moving on from here, we then wait and see, oh, at this point, actually, the synchronous nature of our code has ended. Our auth listener is actually what's triggering, because from our auth listener, we are getting from Firebase, oh, you have an active session. This active session then triggers an action to dispatch setCurrentUser with the payload of the user. From here, what happens is that current state, of course, once again logs inside of our logger. We call next, and then our reducers update. Our reducers update re-triggering our selectors. But notice here that our selector is causing this component to re-render, despite the fact that we know that only the user object is what has updated from the reducer. The categories reducer has not changed because our categories reducer does not respond to setCurrentUser. So here is where useSelector, we have to take a little bit of a deep dive into it. useSelector, as I mentioned, runs every time that the state object has updated in the root reducer. However, it only re-renders this component if the return of the selector function you pass to it is different. So here you might be wondering, well, Yihua, I don't understand. Our selector should be always returning the same value, right? Because the original categories array hasn't changed. It's an empty array. This is where it has to do with the way that we composed our logic. Our logic here with reduce, what I want you to realize is that reduce is always returning back a new object. The reason why is because after running reduce, what our code says is that I want to build up the accumulator, which is starting with an empty object, and then you return that back. Every time, though, we're using a net new object here. So this is where you need to think a little bit about your code composition. Now, one of the trade-offs we made when we created this selecting of our categories map to abstract the logic into an selector rather than do it so that we store the categories map when we fetch it from Firebase, is that every time the selector runs, we will be rerunning this logic. Now, as I mentioned, as a result of this logic, we're always getting back a new object, which means that our useSelector will never be able to properly cache that value, pass the equality check, and therefore not cause any unnecessary re-renders. Would it not be great if instead we only ran this selector if the categories object change that we get back from our reducer, meaning that the only time we should run this logic to derive a new categories map is if our category reducer returned a new object, and that should only happen if the action corresponds to something in our reducer that triggers that change. Well, this is actually where we want to leverage a new library. It's a very popular library called Reselect inside of the Redux ecosystem that specifically addresses this exact topic. And that's what we're going to learn in the next video. So join me and we'll figure out how to tackle this and learn all about Reselect. I'll see you in the next video. Welcome back, everyone. In this video, let's learn about the Reselect library. So first, we need to add the Reselect library into our application. While this is fetching, what I'm also going to do is I am going to restart the server because once this is installed, we need to make sure that our server has the latest libraries. This is most likely the most common time when you want to restart your development server is when you know you have new libraries. So I'm just going to rerun yarn start here, and then I'm going to go back to my application, and I'm going to explain to you how Reselect works. Now, the basis of reselect is that it creates for us this concept of a memoized selector. So let's talk about what a memoized selector is. Memoization is the process in which you cache the previous value of something so that if the input has not changed, then you just return back the same output. This works when you have a pure function. For example, if we had some function called add, which takes some value a and b, and it returns you a plus b, we know that because this function is pure, if we call add of 3 and 6, this gives us back a value of 9. If you call add 3 and 6, does this mean that you need to run a plus b every single time? No, of course not. You know that if you receive the same input, because the function is pure, you should always get back the same output. So why waste the extra resources to recalculate something that you already have calculated before? Memoization is that extra step inside that does that for you. So create selector does that with selectors. It memoizes them, assuming that as long as the inputs have not changed, then your output should always be the same. Now, how do we extend that into selectors? The way it works is that we have to create what are known as input selectors and output selectors. Input selectors are selectors that give us the parameters that we need in order to determine what our output should be. If that sounds confusing, I know it absolutely is. Let's write some examples so we get an idea of what we're doing. First, what I'm going to do is I'm going to create an initial selector that gives us back just that slice of the reducer that we need, which is the category reducer. So here I'm going to say select category reducer is equal to some function that receives the state. It's a selector function. It gets the entire Redux state. And then from this, we just want the categories slice of the Redux store. Next, what we're going to do is we're going to use this inside of a memoized selector. So in order to create a memoized selector, we need to first declare what it is. So this is select categories. Select categories gives us back the categories array that lives on the category slice of our Redux state. So here, in order to select this, we have to say, hey, I want to use the create selector method. This method creates a memoized selector and it takes 2 arguments. The first is an array of input selectors, and the second is going to be the output selector. The input selector is going to be what do I want as part of the parameters that I'm going to use to produce what the selector should return back. So what are the slices that I want from Redux so that I can use them to produce something new outside? Here, I want to get the categories slice, because off of the categories slice, which we will receive as the argument inside of the output array. So whatever this is, whatever the output of this will be the argument that is in the same place inside of the output array. So if, for example, we had another selector, let's say it was select current user, this output is going to now be the second argument of our output selector. But we only need, of course, the 1 for this. So now we're going to take categories and we're going to say, okay, you know what? Actually, let me rename this category reducer so that it's more clear. Or category slice. I like that more. I want to take category slice and I want to get off the categories value. Now, this selector is a memoized selector. The only time where this will run is if this category slice object that we get back from this selector is different. Because if this input value of categories is different, only then does reselect determine, oh, we need to rerun this method. If this categories value is always the same, again with the strict equality triple equals, then I know that the previously cached computative value is going to be enough because these functions are pure. So as long as this categories object is always the same in memory, which it will be as long as categories reducer has not updated, then that means now suddenly this value will always be the same one. Now this becomes extremely powerful when you think about what we were trying to do with our categories map. Because we didn't want to run this reduce if categories had never changed. So in order for us to memoize this, all we need to say is that, hey, I'm going to create a selector here. And this selector is going to receive select categories. Here you can notice they're composable. If we pass this structured selector in as the input, it will in turn memoize here already and then memoize here again. So now we know that we're getting the categories, which is the categories array. With this categories array, I want to, of course, reduce over it. So I'm going to copy this over. And now I can get rid of this code. Fix this typing here. And now I've created a memoized selector for this mapping that I've made. What's happening here is that we're saying, hey, as long as the categories array does not change, do not rerun this method. Of course, you want to reduce once, but after that, as long as it has not changed, don't even bother rerunning it. Just give me back the previously calculated value. And because the previously calculated value was the previous return of reduce, which is an object in memory, what you'll notice is that useSelector now works. That triple equals is going to see, hey, that previously cached value is actually the same value, the same categories map now. Unless the categories array value is different, then what will always happen is we'll just get back the previously generated object. In fact, to prove it to you, I'm just going to add an additional console log here so that we can see what happens when we relook at our flow. I'm going to say selector fired so we know that we're firing our selector. If I go back to the application, I want to clear this out. I don't want to talk about the initial mounting step yet. I just want to show you what happens if you remember. Previous to what happened is that we would sign out. This triggers set current user. Set current user updates our Redux store. And of course, because our Redux store is re-rendering, our selectors get called from the use selector hook of React Redux. This in turn will do the equality check and see if there's anything. Before, we were noticing that our components were getting re-rendered because we were not being able to properly do the check due to the reduce call. But now if we sign out, what do we see? We see set current user gets called. We see that our payload gets called. We see that our current state is getting updated, but this is all within our logger. We're not actually even seeing this component getting triggered. Now, why is it that our selector didn't even fire? This is because we didn't even make it this far into this select categories map. This select categories call here didn't even run. It just returned what was already cached, which is an output. And the reason for this is because, of course, once again, this is all memoized. If we even go up here and we say, hey, is this even getting called? So I'm actually going to be more specific. Selector 1 here, this is selector 2. If I save this and I come back here and I refresh, let's re-trigger our flow, sign in, clear out. If I hit sign out, still, you notice, I'm still not even getting our selectors. The reason, once again, is because this is also a memoized selector. This selector is actually the only one getting run. And this one is in itself what is being cached at this input level. So now if I move this console log up here, set this one to selector 2, and then this one to selector 3. If I save, let's reset up our application, clear this out, refresh. Let's sign out. Now we see selector 1 fired. That's as far as it got. So inside of our category component, when current user got updated and our user selector updated, of course, all use selectors are getting fired. Select categories map, as far as it went, was it determined, hey, what's the current value of categories? Now, categories is output from our category reducer. This object, of course, has not updated. Only the user reducer has updated. Therefore, it doesn't even determine the need to fire this logic. let alone this logic. It's just going to take what was returned from the last calculation of this entire composed chain, which was the previously calculated reduced down categories map. And it just returns that as the value. And that value, of course, is the same value that the useSelector had previously. Therefore, this category component does not re-render. Now, if that is confusing, I understand. We learned a lot today. But really, this is one of the most powerful aspects and why the Redux ecosystem is so fleshed out. Because React is constantly going through this re-render battle. All of these elements, all of these steps that we're taking are just all of the ways that we scale out a Redux application. Every single step that we're doing here is a different way that all of the different tool makers and this Redux ecosystem has developed because of this separation of the logic. We want to make sure that in our selectors, we have all of our business logic. But at the same time, we want to make sure that we're not messing with any of React's own re-render cycles. So there's all of these tools that were really thought out and very careful and intentional about how this all works together. But hopefully here now, through this flow, you saw what we were doing. We now have memoized selectors, which are very intelligent in being able to determine, hey, if nothing's changed, just don't even bother re-rendering. So let me get rid of all of those console logs, because now we have a working example of our memoized selectors. There we go. So hopefully you learned a lot through this process of migrating away from the categories context into category reducer. There was a shifting of the logic, the architecture, and a lot of these additional pieces that we learned in order to fully flesh out our understanding of how all of these different pieces in Redux play together and how we can optimize it. So if this was challenging and confusing, redo this yourself. Because only through that process and just console log every step of the way in order for you to really understand what's happening in these interactions. I know it's really, really challenging. Redux has a very notorious reputation, as I've mentioned, for having a very steep learning curve for this exact reason. There's so much boilerplate to set up. There's all of these additional libraries in the ecosystem that help us to understand what's happening. But the benefit, of course, is the unidirectional data flow that we get with this type of architecture. So now that we've done this, my challenge to you is to migrate over the remaining context to Redux. And that context, of course, is the cart context. So do that, and then in the next video, we'll do it together, and I'll see you in the next video. Welcome back, everyone. Now, before we continue with our cart context, let's just make sure we've cleaned up everything up till this point so far. In the last video, we added a few console logs that I want you to remove as well. If you have, then that's great. If not, please do that now. And inside of your context, if you have not deleted your user context and your category context, please delete those as well. So with our cart context, there are a lot of little micro functions, utility functions, as well as a lot of the separation of logic that we did so far. There are a couple things that we need to think about when it comes to how we migrate this code over into Redux. It's everything we've already learned, but there are just a few more steps. One key thing is that so far we've been storing our cart count and cart total actually on the reducer itself. So here, what we've learned so far is that with these selectors, we can actually extrapolate out that data, and we can also make it relatively performant as long as we make sure to memoize them using reselect. So that's what we're going to do. Beyond that, a couple other things we want to do is just make sure that we capture all of the logic in the right places when coding this out. So to begin, what we're going to do is let's go into our store and let's set up and scaffold all of the things we need in order to get this Redux up and running. So I'm going to make the cart folder. I'm going to make the action.js. I'm going to make, of course, the reducer.js. I'm going to make the selector.js, and I'm going to make the types.js. All the things that we need. And then what we'll do is we will slowly migrate over into each of these files. the different things that we've already created. For example, we know that we already have the reducer and the initial state. We, of course, have to tweak some of these in order for this to work and fit our current model. So cart initial state. And then the next thing we need to do, of course, we need to set our state equal to cart initial state and our action equal to a empty object if no action is passed. Then by default, we just also return the state. The next thing we need is cart action types. So here, let's go to our cart context. Let's grab our cart action types, point them into our cart types. And let's also add cart slash in front of each of these strings, because now every single reducer gets every single action. So we want to be very clear and explicit about which one should be receiving it. And then what we need now is we need to actually create and move in the types. So we're going to import in our cart action types, export out this reducer, and put this reducer inside of our root reducer. There we go. So here we have our cart reducer. We just attach it to cart like so. And now for our first sanity check, let's just make sure our reducer is actually inside of our application. So here, when we initialized, what we see is our next state object. And on the next state, we see on cart, we indeed have all of our initial values. So there we go. We've set up our reducer. Now we need to think about the hard parts, which is the actions as well as the selectors. So as I mentioned, our selectors should be what actually extrapolates out the logic that we had before, that we were doing when we were pushing the values into our reducer in context. Because now instead of doing it before it goes into context, we're no longer storing cart count and cart total. We want to extract that into selectors. So to do that, what we need to do is just make sure that based on the cart items, we want to move this over. So let's copy this into our selectors first. Let's also make sure to import in our create selector from reselect. As far as the selector logic goes, the key thing that we know that we need to extract off is the cart items. So currently though, we are storing cart total as cart quantity. So what we can do is we can get rid of these values. And we need to make sure as well that when we set, all we're setting now is just cart items. So we can just pass it as the payload, which will be our cart items. I think I'm realizing that when we look at our cart context, I did not make a new setter function that uses reducer. Instead, we're still using useState. So this is an oversight on my part, but this is a very quick, simple setter that if you wanted to set, you can make it yourself. Maybe some of you have noticed that I missed that, but no worries. We'll do it now inside of our cart reducer. So all we need to do is just switch the case. I believe, in fact, we even have a set is cart open. Yes, we do. It's just an oversight on my part. We just need is cart open to point to the payload, which will pass as a Boolean. So for us, let's create the actions that will do this. Here inside, we want to import in our cart types. And then what we'll do is we'll export const set is cart open, which will receive a Boolean. And we also need to import in create action, because what we'll do is we'll create an action with the cart action types set is cart open and pass the Boolean as the value for the payload. Now for the remaining actions, this is going to be a little different. When you think about the cart context, the way we had it before is we had these helper functions that we exposed. And what they did is they would update the reducer, but we would also generate what the new cart items would be here and do this as these functions. This you can kind of see as your action creators. All you need to do with the action is the action needs to figure out what to update inside of our final reducer. So what we'll do is we will make sure that our cart actions are the ones that do so. In order to do this, we will probably need all of these different helper functions that we've created. So I'm going to copy these over first, move these at the bottom, and each of them rely on some utility function that helps us actually derive the new cart items. So I'm going to copy these over as well. And there should be one more for clear cart down here. Actually, we should have moved this right here for more clarity. But no worries. We have it now. And now it's just a matter of modifying these new action creators so that they actually do what we need it to do. So what I want you to do is I want you to try and take a stab at this. If you have already, that's great. If not, just try and figure out, okay, now that we're inside of the land of Redux, these actions now no longer have access to cart items in the scope of the context. We'll probably have to pass it in. But before you do that, just think about when you're writing these actions anyways, understand the context under which they'll be used and what you might have to do in order to get it to work. So try that out yourself and then join me in the next video where we will code this together as well as finishing up the rest of the setup for this cart. Welcome back, everyone. So let's finish setting up our action creators. Here inside of add item to cart, what I want to do is I want to make sure that I pass in the current state of what these cart items will be. Similarly, I want to do the same for remove item to cart as well as clear item from cart. These are all necessary because I need to actually generate the new cart items through which I will, instead of calling update, now what we'll do is we will dispatch the action itself. But the dispatch is going to be from the action, and the action is what we need to generate. So to generate the action, we need our create action because that's what we're going to return back from this function. And our create action is going to receive the new cart items as the payload, but we're also going to receive cart action types dot set cart items as the actual action type. So here, because each of these are called new cart actions, we can just move it over like so. Then lastly, we just need to make sure that we export out each of these action creators. And this will be the action creator that we use in order to replicate our previous behavior inside of context. So now that we have our action creators, we can of course further tweak them once we have everything set up. Now it's time to think about the selectors. So with our selectors, as we know, now what we want to do is we want to work off of the cart items inside of the reducer in order to generate the cart total as well as the cart count. So here, what I'm going to do is I am going to create the basic input selectors that I know we always need. The first one, of course, is to extract off just this slice of state. So here I'm going to say select cart reducer is equal to us receiving state and then us getting state.cart. So this will give us just this cart slice that is governed by this slice of the reducer. So nothing here, much different. The next thing that I want to do, which is going to be probably something we want to memoize, is getting the actual cart items off of this slice of our state. So here I'm going to say export const select cart items is equal to create selector, where we receive select cart reducer. And then off of this, we get the cart. We want to return cart.cart items. We probably want something similar for our is cart open. So I'm going to say select is cart open, which is equal to create selector, receiving select cart reducer. Once we get the cart, I want cart.is cart open. Now, as far as new count and the cart total goes, we want these as the logic in our new selector logic. So here I'm going to make const select cart count. And this is, again, a create selector that receives select cart items. Because off of these cart items is where we're going to actually get the total value of all of these items. So I'm going to take this reduce, I'm going to put it here. Similarly, I need a new select cart total, which is create selector, passing in select cart items again as the basis. And then from the cart items, now we'll reduce over these cart items for the total. So I'm just going to copy this over and get rid of the semicolon. But that's it. We know that we need to extrapolate out the logic that we had before. We just moved it into our new memoized selectors that we get from reselect. And the key thing here is that no longer are we storing cart total and cart quantity inside of our reducer. Instead now, everything is based off of cart items, which we know it will be. And through using memoized selectors, unless those cart items change, we won't be running any extra re-renders. So now comes the long and arduous process of making sure everything works as we expect it to by replacing everything that calls our old cart context. So to begin, what we know we need to do is we need to gut out the cart provider from our index.js because we are no longer utilizing the cart provider. The next thing that we need to do is figure out where cart context is being called inside of the application and slowly migrate over using these new methods that we've created, the action creators, the actual selectors. So what I'm going to do is I'm going to leave this to you, try it out, and in the next video, I'm going to show you how we do this. But I want you to get some practice first. Really figure out where you need to import, what you need to remove, what you need to call from what hooks. It's always good practice, and we have quite a few of them to do inside of our application. So try it out, and then in the next video, you'll see how I do it. I'll see you in the next video. Welcome back, everyone. In this video, we are going to migrate over all of these different references to cart context inside of our components that we found over so that we can now use the bindings in Redux because we've migrated the cart over. There's actually a strategy you can use to approach which of these to change first based on which components are able to have references that will open it up for us so we can access further ones. An example for this is that we know that everything now that references cart context is no longer working because we've removed the cart provider that we had before from our index.js. So the first thing that we should probably hook up is any places that have the most high-level access that will then unveil for us the remainder of the code. For example, we can't really see the cart dropdown unless we can open the cart dropdown. So what this means is that inside of our navigation, we probably want to do this first so that we can actually set is open or is not open. So to begin, let's get rid of any references to use context as well as the cart context. And then what we'll do is we will import in what we need from our appropriate store folder. So we know we need is cart open. This is going to be a selector that we have inside of our cart selectors. So let's go up into the appropriate file for cart selector. And here we'll say select is cart open. We also need useSelector, which we already have when we did our current user. So here I'm going to say is cart open is equal to useSelector passing in select is cart open. Now let's save our code. And what we know now is that we can see the cart dropdown as long as is cart open is true or false. So the binding there works. But the next thing we need to do is actually make it so that we can set that value is cart open. So to do that, what we'll have to do is go into our cart icon and we'll have to remove our reference to cart context, use context, and import in our dispatch. So here we know we have set is cart open, as well as reading isCartOpen and cart count. So that means we also will need useSelector because we have to select off the cart count value and isCartOpen. What we need now next is we have to import in the appropriate selectors as well as action creators. So let's first go up to the appropriate folder of store and then cart. And then we need one for our cart selector and we need one for our cart actions. So let's think about which ones we need. Here we need cart count, so let's get select cart count. And also we need select isCartOpen. As for our action creators, we just need our set isCartOpen. And here now, we don't need this anymore. We can just make sure that we get, first off, the cart count value, which is equal to useSelector, passing in select cart count. And then we also need our dispatch because we will be dispatching our action creators. And we can now say, hey, this toggle method right here that we already have, what it will do is it will say set isCartOpen is a action creator. So we know we have to dispatch this. So let's just wrap this inside of our dispatch. As for isCartOpen, we can get this value using our selector for select isCartOpen. And there we go. That's all we need. So now what we should be able to do is at least open and close the cart dropdown. So if we go back to our application, we see that's exactly what we get. Next step, we need to set up our cart dropdown so that it can actually show the values. So inside of our cart dropdown component, I'm going to get rid of cart context again, as well as use context. And here we see that we just need cart items. So I'm going to import in useSelector from React Redux. And then as far as the actual selector goes, I need select cart items from the cart selector. And here I'm just going to say I get my cart items from useSelector passing in select cart items. But in order for us to actually get cart items into this cart dropdown, we need to make sure our product card is able to actually dispatch the add item to cart. So here once again, let's get rid of our cart contexts. And what we know we need is pretty much just the add item to cart action. So I'm going to import in useDispatch because as we know, every single one of our actions needs to be dispatched. And then I'm going to import in our add item to cart method, which comes from the appropriate folder inside of our store once again. So let's go to store, cart, cart action. And let's just make sure that this is the right method. So here, I'm going to go into this file. And down here, we see that it is add item to cart. So this is indeed the correct name. And then all I need to do is get rid of this context, bring in dispatch using the useDispatch hook, and then just making sure that we dispatch out our action creator that had the same name as our old function. So now what I should be able to do is add items. But here we see cart items.find is not a function. So something we've done is a little off. Let's go back and check. Inside of here, we call add item to cart. And as we notice, we need to pass in cart items into our actual action creator. So we were not doing that, but we knew that we had to do this when we set up the actual action creator. So in order to get this value, what we'll have to do is get in the cart items that is currently inside of a Redux store. So we'll need to bring in useSelector and also import in the appropriate cart item selector. Select cart items like so. And now I can just say const cart items is equal to use selector, calling select cart items. And then I'll just pass cart items into add item to cart, like so. Because the first argument is the current cart items, this is the one that we need to add. And now, if I go back to the application, and let's refresh. When I hit add, there we see. We got the appropriate actions firing, and here we see that we are indeed getting our correct values. So at this point now, we've migrated everything we need inside of the main application except for the actual checkout components. So you've seen me do it. If you haven't done it, try it out yourself. If any of this seems confusing, again, repractice and implement it and gut it out and then move it over. Again, as I mentioned, you want to think about the migration strategy. You want to pick the components that you need to unlock through the first surface level of the migration. And then as you go deeper, you're able to actually access those and modify them as well. So fix up the checkout and then join me in the next video where we'll do it together. Welcome back, everyone. The last two remaining files that we need to migrate out of cart context towards cart Redux is the checkout component and the checkout item component. To start with the checkout component, we know that we need the cart items and the cart total. So first, let's once again bring in the appropriate hooks that we need from React Redux. We need the use selector hook, like so. And then what we need is both the select cart items and select cart total. And these will come from our store folder, our cart folder, our cart selector. And then it's just a matter of replacing our cart items that we were getting from context before to use the selector, select cart items, and then the cart total so that we're using the selector, select cart total. Now what we need to do is do the same thing for our checkout item. So our checkout item has both add item to cart, remove item from cart, and clear item from cart. And as we know with these three methods that we have, which are our action creators, they need the cart items as well. So this component is actually going to be the one that calls probably the most. So we'll need our use selector. We'll also need use dispatch. And then we're going to bring in our select cart items from our cart selector. And we also need both our add item to cart from our cart action. We need our clear item from cart. And we also need remove item from cart. It seems that I've called it remove item to cart. So let's actually fix this and name this something that is more grammatically correct. Instead of remove item to cart, I'm going to say remove item from cart. And then here, I'm going to reflect the same as well. And now what we can do is we can start replacing what we had before. So these three methods are now action creators, which will need to be dispatched. So of course, this means that remove item to cart is remove item from cart, like so. We no longer need context because we've imported them in from the correct action creator file. And then I just need to wrap these in the dispatch, which we will get from our use dispatch. So just a lot of boilerplate at this point. Everything is something that we're already pretty comfortable doing. The other thing we need is we need to get the cart items from our use selector, select cart items. And what we can do is make sure that when we call clear items from cart, we pass it the cart items as the first argument. And then we're going to do the same for these two remaining methods. We're going to wrap this in a dispatch, and we're going to pass cart items as the first parameter, and do the same for the remaining one. And now if we save this, let's check to make sure our code works. So going back here, we go to checkout. We see that now we're inside. We can remove items, our total updates respectively. We can get rid of an item, and we can clear the item. So there we go. Everything works. And that is our full migration. So the last thing we need to do is just remove the corresponding context for cart because we don't need this anymore. In fact, we can even delete our context folder because there's nothing inside. And there we go. We've migrated everything over from our cart into Redux. So there's a lot of little things that we had to tweak, but what we really understood is that there is a different way of thinking about how to structure your code when you're using Redux versus context. The primary one is that inside of your cart actions, you want to figure out what you need because you no longer have that scoped context that you had before. You have to pass everything inside of these function creators, and they should be as pure as possible. Similarly, a lot of the logic that we are dependent on is being extrapolated into selectors. And using reselect, we can memoize them so that they are just as efficient as if we were to store them using either useReducer or useState inside of a context component. So now that we have this done, another great benefit that we get from Redux is actually the ability to persist inside of local storage. And it's technically doable as well inside of context, but you have to write your own code to do so. Whereas inside of Redux, there is a very, very popular library called Redux Persist. What it essentially allows us to do, Redux Persist, is persist any of our local state into local storage on the web browser, meaning that every browser has access to this little slice of memory. We can actually commit any state changes that the user has to that local storage so that when they come back to their session, they can actually rehydrate this store with their previous state, which means the application, if done correctly, the state of the application is reflected by Redux. So that means that technically we can actually persist their cart throughout their journey. Let's say they leave and they come back or they refresh. If we refresh right now, what we notice is that our cart goes back to 0. But we can actually persist this using Redux Persist. So that's what we're going to do in the next video. Welcome back, everyone. In this video, what we're going to do is we are going to introduce in Redux Persist. Now, Redux Persist is a tool that allows us to persist our reducer values inside of local storage. So to start, what we need to do is we need to add in Redux Persist as a library. So once it's inside, there's a lot of nuanced setup and configuration we have to do. Not a lot, but at least there's some that won't make a lot of sense upright until we actually see it in action. So in order to use it, what we need to do is we have to import in two things from Redux Persist. We have to import in first the actual persist store method from Redux Persist like this. And then the other thing we need is persist reducer. These are the two methods that will help us actually set up our persistence. We need a configuration object that tells Redux Persist what we want. Now, this config is relatively straightforward, and you can find what other values you can set inside of the docs that I've linked for Redux Persist. But here in our current config object, we need to say, okay, what's the key? So the key is the part that we want to start with. And root just says, I want you to persist the whole thing, which is what we want. We want to start from the root level. Then, as far as the storage, what do we want to store this into? So here we need to import this in from Redux Persist /lib/storage. So by default in any web browser, this will just use local storage, which is what we want. So this is what we'll pass as the storage value, like so. Except using this shorthand where we cast the variable as the key name. And then what we need is we need to think about whether we want to blacklist or whitelist any of these reducer values. So here, this is where you would put in an array of strings of the actual values that you don't want, for which reducer you don't want to persist. For us, we know that our user value is coming from our auth state listener anyways. So if that's the case, we probably don't want to persist the user, because this might conflict and clash with local storage in a way where we get some weird interactive behavior we may not want. So I'm just going to blacklist the user. Now what I'm going to do is I'm going to say I want to create a persisted reducer using this persist config. So I'm going to call persist reducer like so. And here I'm going to pass it two things. First is the persist config, and then the next thing is the root reducer. With these two now, I have created a persisted reducer, which is what I want to use for my store. So now my store is by default going to be using persisted reducer. And then what I'm going to do is I'm also going to export out a persister object, which calls persist store using the store object. So it's using these new modified persisted values that we have in Redux that we can now persist the store. But to do so, we have to actually go into our index.js, and we need to import the component that we're going to pass all of this to. So here, what we're going to import in is this thing called a persist gate. So I'm going to import in persist gate, which is a component specifically from Redux persists that we can use for React. So this lists under Redux persist, not React, /integration/React, like this. Now this component we want to wrap inside of our provider. And we want to wrap all of our application inside of our new persist gate. And what we pass to persist gate is our persister that we are now exporting from this file. So I'm going to say persister is equal to persister. And now if we go back to our application, if we have, looking inside of our cart, we have some items. Let's refresh now. What we see is that we have retained the same items. And looking inside of our code here, we see that we receive an action of type Redux persist or persist/persist, and then persist/rehydrate. So here, this rehydrate, as you can see, is giving us back the actual values that we told it to persist. Remember, we said don't persist the actual user. And through this, we're now able to actually retain the initial state that the user previously had. If we remove some values and then we refresh again, we see that we are persisting the same values. One additional thing you can also add to this persist gate is you can pass a loading value. And here you just renders something. You can pass it a component or whatever you want when it's trying to determine how long it takes to actually rehydrate the store. So if I say null, essentially what happens is that it'll render nothing until persist is actually finished. But there we go. Now we have in local storage and persistence so that you can carry your actual state across multiple sessions. And this is, again, one of the benefits we get out of Redux is that the ecosystem for Redux has a lot of these solutions and tools already solved. You most likely want to use Redux when you're building a large application that has really large state and really complex state. If you don't need a lot of these optimizations, then just use Context API is enough. But now we've migrated the entire application to Redux, and this is pretty much a lot of what you need in Redux is just these same patterns over and over again. A lot of practice will go a long way. So at this point, you can continue to learn Redux by either building in new features yourself, or you can try and convert this application back to context. By doing so, you'll actually think about these mappings and all of these different logical decisions that we made in order to architect the application this way. So there's a lot of different ways that you can learn. Again, practice always makes perfect. But now that you're armed with the knowledge, at least you'll know what to do. Redux is one of those things that naturally, again, has a steep learning curve that will only get easier the more you practice. But that's it. We have in our Redux persist, we have Redux. And now you have seen what it takes in order to set up Redux as your state management service inside of a React application. Welcome back, everyone. In this video, we are going to clean up some last-minute things that we have inside of our store. And also, I'm going to talk a little bit more about logging inside of Redux, because we have many options throughout the years. First off, what I want to do is mention that we actually have our own logger middleware, as we know, as well as Redux Logger. We can really pick and choose which one we prefer. It's up to you. If you want to use Redux Logger, which is what I actually prefer to use, again, just keep in mind that we need to get the result using next.action, and only then are we able to actually get the next state. So when you look at your code, as we've gone through extensively, you may not see the order of your actions and the code inside of your components rendering in a way that seems super predictable. If you feel like you don't like that, of course, you can write your own logger middleware, as we've seen, and using this, you can figure out and get a more accurate depiction of what you want your actions to be. So what I want to do is I want to move this middleware that we've made into a middleware folder. And now we always have access to it. I'm going to similarly call it logger.js, export this out. And now, if you want it, just import it. Otherwise, personally, I'm just going to use Redux Logger, and I'm going to pass this middleware here. Now, one other thing I want to mention is that we should only be running this logger middleware when we're in development. When we're in production, we don't want to console log anything to the logs. So here, what I'm going to do is I'm going to actually leverage the process.environment.node environment variable, which is something that we always have access to that tells us whether or not we're in development or production based on the string development or production, like so. So if our node environment is currently development, only then should we render the logger. Now, of course, if this is untrue, where our node environment is equal to production, what happens is we never actually end up evaluating logger, but we just get false. And we don't want to pass false as a middleware. So we need to make sure that we also filter out by Boolean. What this does is essentially it filters out anything where it is not true. So if we come here, I want to quickly show you an example. So let's say, for example, we have this value 2 equals 3. As you can see that I was starting to type out. What I'm going to say is that ampersand here as well, I'm just going to put an object. And inside this object, I'm going to say A goes to string like this. Notice that this is equal to false, which is what we expect. Now, if I put this inside of an array, if I .filter this and I pass Boolean, what will happen is it will remove anything that's got false or falsiness into it. So now we are filtering out if this is false. If this is true, however, what happens instead is that we will get the actual object inside. So this is how we keep the middleware if we are indeed evaluating in development. And now our middleware is going to only apply when we're actually inside of development, which we see right here when I refresh. There's our Redux Logger. If I want to see that it's actually working, I can just flip this to production. And now if I save this, there we go. We see that no matter what happens, none of these actions are now logging. So this is some optimizations we can make to make sure that we hide our logger. Again, if you want to use Redux Logger, you can. If you want to use Middleware Logger, you can as well. Now, if you want this to be a little bit more clear, we want to switch this back so that we're in development. You can also say that if the node environment is also just not in production, don't render the logger. This one is also a little bit more clear because sometimes you might have other additional environments determined for you. You can actually add more environments if you wanted to. It just depends on your project. So this is actually the safest one. We essentially say, as long as we're not in production, render the logger. If we are, don't use it. Now there is one more tool that a lot of different projects like to use. It's kind of a mixture. It is actually a Chrome extension that does require us to interact with it in order for us to utilize it. And I'll show you how that one works as well. So if you look inside your resources folder, I have a link to this extension called Redux DevTools only in Chrome. So you want to add it to Chrome. And then the way it works is that you'll get this little Chrome extension icon that only triggers if the web page is enabled for Redux DevTools. The way that you set up a website so that it actually can use Redux DevTools is that here inside of your store, you need to modify the compose method. You modify it in the sense that you determine whether or not you want to use Redux's compose or the DevTools compose. So the way that you write this code is you say const compose enhancer. Essentially, it just says, hey, I have this compose method that I'm going to use, and I'm going to determine which one to use. If the process.environment.node does not equal production. So very similar to what we saw before. We don't want to use this if we're in production. If we're not, then it's okay. So if we're not in production and we have a window object, because during our build step, there's no window object on the server. So for this reason, we don't want to break our code. So we want to make sure that we say, hey, only if there's a window object and window.underscore_redux_DevTools_extension_compose_. So this right here is a protected keyword. And what we're saying is that if we're not in production and there's a window object and these DevTools exist. So DevTools as a Chrome extension is going to attach this to the window object, which is their own compose. Then use this compose. Otherwise, just use the compose that we have from Redux. And now what we do is we call our compose enhancer instead of compose. If these fail, then we'll use regular compose just as we had before. Otherwise, run the actual one from Redux DevTools. And now what happens if we've rebuilt properly is if we go back to our application, what we can see if we refresh is that inside, we see that our DevTools is highlighted. If I click this now, notice how this new tab opens, or not new tab, but this little modal. Inside of here, we can see all of the different events that happened and at what time they happened. These all happened within very quick milliseconds. And now we can actually look at the action itself. Here we see that there's a set current user. This was the action. It had this type. It had this payload. This was the state that we had after we had updated. If we look at the diff, we can see what values got changed on what reducer. We see that in the user reducer, the current user value went from null to this payload object. Similarly, what we can also do is we can use this timeline to jump through the different portions of our application while the Redux state was being modified. So this might not be as clear, but let's say, for example, I go to my shop, I add some more items here, and I go to checkout. And what I'll do is I will modify these values. I will remove some of these values. And now, if we go back and we reopen Redux DevTools, we see there's a bunch of these set cart items method that happened. We can technically skip through and look at how our application state changed based on these actions that fired. So this gives us control over the application state based on all of these different actions that are firing through Redux. So this dev tool is really good if you want to see and you're manipulating very complex Redux state, just what's happening at every step, what's getting modified, and you'll notice that your application, in fact, reflects accordingly, because this is directly modifying the reducers so that you can see the state that's being modified in turn. So there we go. This is Redux DevTools, another very popular tool. You can feel free to use whichever ones you want. You can use a combination of them. It's really up to you. The world is your oyster. So now we've learned the majority of setting up Redux by itself and how to use Redux inside of our application. In the next video, what we're going to start covering is actually some additional Redux libraries that you may encounter in your journey as a developer. Only at scale, though. I do want to mention that a lot of these projects that you work on, only at scale will you start using the next libraries we're going to talk about. So I'll see you in the next video. Welcome back, everyone. In this video, we're going to discuss Redux-Thunk. Redux-Thunk is one flavor of asynchronous side effects inside of Redux. What this means is that we allow our application to fire actions, and then those actions now do not have to flow through the Redux diagram in a synchronous manner. Instead, now we get Redux bindings, which means we can read from the store or we can dispatch new actions within the actual middleware section of this Redux flow. We don't have to only figure out how to essentially coordinate these asynchronous behaviors inside of components, which is how we've done it so far. Instead, now with a middleware, you can actually do that inside of here, which opens up really powerful architecture patterns, because essentially your components are purely dictating how these actions get fired. Now, what the actions do, what APIs they need to call, what asynchronous behavior needs to happen, all happens inside of middleware. So let's talk about Redux-Thunk and where it fits inside of this middleware. So Redux-Thunk, of course, is itself a middleware. And what it allows us to do is receive actions that are functions. It's actually very, very simple once you understand how it works. But what happens here is that we have some action, and it's going to be an asynchronous action. So instead of us dispatching a action in the typical format of an object with a type and a payload, instead we pass a function. This function goes to the Redux-Thunk, and what happens is that Redux-Thunk takes this function and it passes into it a dispatch. This dispatch is the same dispatch that we have used up until this point. What we do with this dispatch is now we can dispatch new actions from right inside of this thunk. And now this new action will go back into the flow and it might hit another thunk, or it might continue on into the subsequent Redux store and further reducers, etc. The key benefit here is that through thunks now, we're able to abstract out some of our logic into the thunks themselves. And this opens us up to new patterns, which we're going to cover in this video. So in order for us to begin using thunks, we need to first add the Redux-Thunk library. So while this is loading, let me explain a little bit about Redux-Thunk. So earlier, if you remember, inside of our store.js file, I had actually mentioned that we were essentially setting up our middleware when we wrote our logger to account for this thunk. The reason why is because inside of logger.js, if the action has no type, then what we do is we pass the action onwards. And the reason why we do this is because all thunks really do is allow actions to be passed as functions. So there is some middleware somewhere where inside what it does is it receives the action. So let's imagine this is thunk middleware. And again, if you remember, it takes the format, it receives a store, it receives next, and then it receives the action. And what it does is essentially checks if action equals, or in fact, if type of action is equal to function, then what it does is it runs the action. And it passes dispatch into that action so that you're able to essentially use a function as a action thunk. So this will become more clear once we start using it. So what we do is we import thunk from Redux-Thunk. And all we need to do now is just pass this into the middleware array. And that's it. Now we can start writing thunks. So what you want to do with thunks is essentially you want to figure out where in your application code base you have asynchronous behavior that you can move into a action-driven flow. So here what we do is we get categories and documents when this component mounts, and then we essentially set it into our reducer when we get it back. This is the perfect opportunity to use this in a thunk. So in order for us to do this, we actually have to modify and change up our architecture a little bit for our category reducer. So first what we need to do is we need to tell our reducer to track whether or not it is in a loading state right now for the data it will hold. So of course, by default, it won't be until something triggers it to be. And that we'll talk about when we get to the actions portion. We also need to start tracking our error states, because as we do asynchronous fetching now, our reducer should be aware of whether or not an error occurred in the fetching process. So this is the first step. The next step is to modify our action types. So essentially what happens now is we are performing fetch requests. So here we're going to say, I'm going to fetch a category, but this is the start of the fetching process. So the reason why we say fetch start is because there are two possible cases that can occur during the fetch process. We can either succeed, so we say fetch category success, or we can fail. So we'll say fetch categories failed. Now, depending on what happened in this process, we will now determine whether or not we want to store the data or store an error state. So instead of setting the categories like this through an action, we're going to set it when we succeed. So let me just get rid of the set categories here, and let's modify our corresponding reducer. So what we need to think about is that we no longer are setting categories on this action. Instead, we're setting it on fetch category success. If it succeeds, then we're going to set the categories with the payload that we get from this action. The other things we need to account for, though, is also category action types dot fetch start. When we start fetching, it's essentially the time when we are beginning our API request. So this is just as we fire it, meaning that we don't know whether or not it's going to succeed or fail. So what we need to say is that is loading at this point is going to be true, because the moment that we start fetching, we are in a loading state. As for fetch category success, we want to say that it is now false, because once we get back a actual result and it's successful, then we're not loading anymore because we have now set the categories payload. And finally, we need the same thing for failure. So whenever we fail, is loading is going to be false, but the error is also going to be the error. And this will be a payload that we pass in with this action. And there we go. We have now modified our reducer in order to work with this. So now what we can do is we can actually start coming up with the actions. So as I mentioned, these actions are now going to reflect these three states, and they're also going to create a function action. So this is what we're going to do in the next video. So before we start, just think about these three states and think about whether or not this pattern makes sense to you. When we start, we're loading. If we succeed, we stop loading. We have a correct payload. If we fail, we also stop loading, but we have an error. This is going to be the fundamental basis now of the majority of our asynchronous actions when it comes to fetching inside of any Redux-based side effect library, whether it be Redux-Thunk, Redux Observable, or Redux-Saga. It's all going to follow this new pattern. And we're going to also talk about why in this pattern and how this is useful. So join me in the next video where we'll continue. Welcome back, everyone. So let's leverage our start, success, and fail action types inside of our category actions. So what we need to do is we need to first create these three new actions. So first of all, one is going to be fetch categories start. And as you guessed it, this is just going to be the action, of course, that tells our application, or rather our Redux store, that we are starting to fetch categories. Here, what we're going to do is create an action, and all we need to give it is the fact that this has the type start. There's no payload required. Our reducer already knows that the moment we see this action, all we're going to do, set loading to true. That's all it is, nothing else. So here, that is our start action. The next ones we need are going to be success and failure. So let's define success first. So here, inside of success, this is pretty much going to be what we had here. Except instead of set categories, we are triggering this action as the success action. Similarly, the payload that we're going to pass to it is going to be the categories array, which is what we want to send through. Next, what we need is fetch categories failed. So fetch categories failed, of course, we'll call the correct. And then we're also going to pass error as the payload. And now we have our three methods. What we need to do is we need to now figure out how to create the thunk action that will trigger the correspondingly correct actions. So these three are synchronous. And they're not even thunks, they're just regular actions. A thunk is going to be an action that we say specifically fetch categories async, like this. I like to call them async. In fact, Redux-Thunk also recommends that you declare your thunk actions with that last word async, so that we can look at this action creator function and know that it is indeed something that is asynchronous and a thunk. So as I mentioned, it's just a function that returns a function that gets a dispatch. This function can in fact be an async function, which is what we're going to use. Because with this async function, what we want to do is we want to be able to determine how we are fetching these categories, what to do when it succeeds, and what to do when it fails. Currently, we have this functionality inside of our shop component. This is all we actually really need, because this dispatch, instead of happening here now, we're going to do it inside. So first, let's bring in our get categories and documents. And now what we're going to do is we are going to wrap this entire function inside of a try catch block. Because what we're saying is that, hey, I want you to try and run this asynchronous method. If at any point inside it throws an error, which it will, if our await call on getDocs for some reason fails, then this async function is going to throw an error, which we will then catch. So here, this is pretty much our basic format. To begin with, the first thing that we're going to do is we are going to dispatch the fact that we started fetching the categories. So we're going to dispatch calling our action creator fetch category start. And then what happens is that inside, if we succeed from this await call, then what we're going to do is say fetch categories success. And here what we're going to pass to it is the actual categories array. And then, of course, if we have an error, we will dispatch our fetch categories failed and pass the error through. I also forgot to wrap this in a dispatch as well. So this is our new asynchronous function. This is our thunk. So what I want to do is use this inside of the shop component. So instead of calling set categories, I'm going to say fetch categories async. And we're of course still going to dispatch this as our action creator, but now we don't need this anymore. In fact, this function isn't even asynchronous anymore. It's just a regular dispatch that triggers the moment this component mounts. And now, if I save this, now if we come back to our application, here we very clearly see that our action is being logged. Now, of course, this is Redux logger, so there is no type to define because it's just a function. So here, though, what we see is we are indeed dispatching this asynchronous action as a function. And then further down, we see, oh, there's our fetch category start. And then right here, down here, we see fetch category success. Payload is indeed our categories items. And then we see our categories gets updated with the correct array. So this flow is the way that we now have hooked into our actual Redux flow with a thunk. And what we've really done is we have essentially moved out the synchronous and loading code into a thunk instead. This means that all of this asynchronous behavior of fetching is all handled by Redux now. Because through this thunk now, this shop component does not have any need to understand or maintain and balance any async await actions or any of the actual asynchronous coordination. All of that is now just driven by an event. All our component knows is that the moment I start, I'm just going to dispatch an event to say, hey, start fetching something. Whether or not it succeeds or fails is not governed by our actual component anymore. That now all lives inside of this middleware, which is a very clean separation of logic. It allows us to get even more granular and individual contribution of each of these different functions now, because now this responsibility is no longer up to our component. Our component simply consumes data and shows data. Here now, inside of Redux, is how we actually fetch that data. And this is why there's a very popular move towards bringing in a asynchronous Redux library like Redux-Thunk when you get to a point where you want this action-driven architecture and you want to separate out this asynchronous behavior. It typically happens when your project scales quite large and you have a lot of asynchronous behavior happening in your application. And this is what we've just done. We have moved out that category fetching into this action creator. So now that we've done this, the next thing we need to do is figure out how we can leverage the loading value that is inside of our category reducer to make our code a little bit more UX friendly. So that's what we'll do in the next video. So I'll see you there. Welcome back, everyone. In this video, we are going to leverage the isLoading inside of our state in order to show or hide a spinner for our category and our category preview component. The reason why we do so is because these components leverage the actual data we need to get back in order to show their content. So we want to have some kind of indicator for our different users so that they know that this fetch is in progress. So what I want you to do is go into your components folder and create the spinner component. Inside, we will have both a spinner.styles.jsx as well as a spinner.component.jsx. So for the styles, I want you to look inside your resources folder, get the style sheet, and paste it in. This is going to be a bunch of style components. So make sure that you import in styled components in order for this to work. As for the actual spinner component, let's import in the two different components that we have, the spinner overlay and the spinner container. So here, I'm going to import from our styles, and I want to import in the spinner container and the spinner overlay. The component itself is just a simple component, and all it renders is both a spinner overlay that contains the spinner container. Just a very simple component. Then we're going to export this out by default. And now what we're going to do is, depending on the isLoading value, we will conditionally render the actual component inside of category, or at least the relevant portion of it, or we're going to render the spinner. So to do that, what we'll need to do is create a new selector. So this selector is going to get us the value of isLoading. So I want to say select is categories loading, like this. Or we can even be a little bit more consistent and say categories is loading, select categories is loading. And this is going to be a selector. So we're going to use create selector. We're going to pass it select category reducer, which will give us the categories slice. And then all we're going to take off of this slice is the isLoading value. And that's what we're going to return. So now inside of our category component, we can use the useSelector so that we get isLoading. And then we need to import this in from our category selector as well. And with this isLoading value, we now have to either render this part of the entire component, or we can render the spinner. So let's bring that in as well. I'm going to import in spinner from components, spinner, spinner component. So looking at this, we know that at any given point, we must have the category. For them to have accessed this component, there must be some category value we have. So what we can do is we can say, okay, if isLoading is true, then what we're going to do is we are going to render the spinner component. If it's not true, then we're going to render the category container, like so. And now if we save this, and we go to our application, and we go into one of these, and we refresh, there we see the loading spinner. So there we go. What we can also do now is we can add this spinner as well to our other component, which is our categories preview. So just like before, we need to bring in the spinner component. And what we also need is to bring in the appropriate selector. So select categories is loading. And now we just say const is loading is equal to use selector, passing select categories is loading. And then inside of here, we just check. I'm going to just separate these out so that it's easier for me to group this component like so. And I'm going to say is loading. Yes. Show the spinner. Otherwise, show this component. So now that I've saved this, let's go back here. Let's go to shop. Let's refresh so that we fetch. And there we go. Now that we have in this thunk and the ability to check whether the loading state is present, we have a lot more flexibility in how we determine the user experience. Thanks to this is loading ability to check now, it's a lot easier for us to segment out the user experience into a way where our component knows, hey, I'm just going to determine based off this Boolean whether or not I'm in a loading state or not. This is a very powerful pattern because essentially it does not matter. If you have any asynchronous fetching happening, because of thunks now, we know whether or not we're in a loading state or not in a loading state. It's a lot easier to reason about and segment out the logic that we have in this flow that typically occurs throughout so many different web applications. One thing I do want you to notice though is that whenever you refresh, for a split second, you do see these components. And the reason for that is because we are caching those values inside of Redux Persist. Because now we have a loading spinner, we don't actually need to leverage Redux Persist for this categories preview anymore. Or not just the categories preview, but the categories in general. So what we can do now is we can say, hey, inside of persist config, really the main thing that we want to persist is the cart. That's really the primary benefit that we leverage when it comes to local storage persistence. There may be more. Maybe you want to store some other things as well. But given how we've architected the application and when we think about the feature of the product that we're building, we don't want them to see anything that they don't need to see. We already have this loading spinner. We know we have to get categories from a separate database anyways. Now, when you refresh, you don't see it. You just see the loading spinner and then you see your content. And that's pretty much it. That's as simple as Redux-Thunk is. It's really just this additional function that you now can pass instead that allows you to really set up this structure of success, start, and failures. If you're curious about what the failure looks like, we really haven't done anything with the error, but this might be where you log the error to something. You might want to handle it in your own way. The main thing is that you have it inside of your actual reducer now, your category reducer. If you want to test it, you can easily go inside of here, and all we need to do is just await a new error. So we could just say promise.reject like this, and we can throw a new error. And here we'll say new error, whoops, like that. So now if we refresh and we look, we see we got a fetch categories failed. And there's our error. We have not handled it, of course, but we can if we wanted to. But there we go. Now you understand how thunks work. It seems a lot scarier than it is when you hear asynchronous side effect event handling inside of Redux. It sounds more intimidating than it is. Really all it is that now you have this middleware that allows you to pass functions that can get called. If you think about it, all we're saying is that, hey, I want an action that essentially is just an async await. And all I wanted to have access to is dispatch. And that's pretty much it. That's all thunks are. And now that we understand thunks, we can move on to the next topic. I'll see you in the next video. Welcome back, everyone. In this video, we are going to discuss Redux-Saga. Redux-Saga is a side effect state management library just like Redux-Thunk, except it allows a lot more patterns and it's a lot more complex. In fact, it might actually be the most complex library within the Redux ecosystem, and the reason for its complexity is due to the power that it brings to your system. You're still within the Flux architecture system of Redux, but the main advantage of Redux-Saga is it allows you to perform very complex coordination of asynchronous side effects inside of Redux. So in this series, I'm going to talk about the high level of how the flow of data changes with Redux-Saga, but the main thing that I want you to take away is that the actual implementation we'll learn once we have to code it. This is just really going to be a flow diagram of what we already know with actions, but now with Redux-Saga inside instead. So looking at our typical Redux flow, we have our middleware sitting in front of our reducers. Redux-Saga is indeed a middleware, but I want you to understand that it flows differently from how you would typically expect middleware to flow when they receive actions. Typically, with most middleware, actions hit middleware before they hit the reducer. But Sagas is different. The actions will actually hit the reducers first before moving on to the Saga. So in this case, it flows after the reducers have updated. So if you think about an action flow, it starts from a component and it moves up and it goes through every other middleware except for the Saga. Then it moves through the corresponding reducers and it updates their value. And then do those actions finally hit the Sagas. The Sagas will respond to these actions and perform certain business logic, certain asynchronous requests. Whatever it is, it's just in the realm of writing JavaScript code based on an action. From here, maybe new actions are generated. Maybe the Saga does something and it gets a value, and then it's like, oh, I need to fire off an action so that I can subsequently update the reducers. So that's what the Sagas will do. They might fire a new action, those will pass through the middleware, and then it'll continue on the flow. But the thing about these actions is that these actions might also flow through the Sagas again. Actions fired by Sagas can trigger other Sagas, and this is a very important thing to know. So this is Redux-Saga at a high level. And if this seems confusing, don't worry, it'll make more sense as we write out the code for it. But the main thing I want you to understand about Sagas that's unique to Sagas is that they fire after the reducers have updated. And this becomes relevant when we actually receive an action. Because if in the Saga, when we get the action, we are looking at the state of the store, we will actually have the state of the store after it's been updated by the action that we're responding to. So that's an important thing to remember when you think about your Saga writing about what the value in the store will be. So let's go into our application. So the first thing we need to do is include the Redux-Saga library. So we'll say yarn add Redux-Saga. As we resolve and include the package, what we'll do is we need to modify our store.js so that we can actually run Sagas. One way to think about the configuration for Saga is that it's kind of similar to configuring reducers. There is a root reducer when you think about reducers, and there's also a root Saga when you think about Sagas, meaning that all of our Sagas combine into one Saga. So in order for us to make this work, we have to go into our store folder and we make a new file called rootsaga.js. The root Saga's entire point is to encapsulate all of the different Sagas, and this will make sense once we actually start working with these Sagas. We have a couple methods that we import exclusively from Redux-Saga, and they are the all and the call. So Redux-Saga has a bunch of reducer-esque bindings or Redux-esque bindings that allow us to actually interact with the Redux store while we're working within the Sagas themselves. And the Sagas themselves are based off of JavaScript generator functions. If you're unfamiliar with generator functions, do not worry. We will discuss them in the next video. It will be a full lesson breakdown of what generator functions are. What we're doing now is just configuring the actual Saga code so that we can actually start working with them before we even write any Sagas at all. But what we need to do is we need to say, hey, I want to import all and call from Redux Saga /effects. So again, effects, side effects. What we need to do from here is we need to export out a generator function. And that generator function is distinguished by this function signature word and then the star. That is a ES6 generator function. Then we say root saga. And this for now is all we need. We're not going to use the all in call, but we will later. I just want to set this up for now. Once we have the root saga, we're going to come into our store.js. And what we're going to do here is we need to import in create saga. So again, sagas replace thunks. You mainly want one asynchronous side effect library. You can either choose thunk, you're going to choose saga, or if you're in the flavor of observables, you'll choose Redux-RxJS or Redux Observable. That one is a lot less common, so I'm not going to discuss that one, but it's another one of these asynchronous state management libraries. But because we're no longer using thunk, we want to import in instead create saga middleware from Redux-Saga. So with create saga middleware, what we're going to do is we are also going to need the root saga to make it work. So let's import in our root saga from our root saga file. Next, we need to actually create saga middleware. And this is where we call the create saga middleware. And then we put this inside of our middleware's array. So this middleware array now has the saga middleware, and after the store has been instantiated with the actual saga middleware inside, then what we do is we tell the saga middleware to run. So you're going to use the .run method, and you're going to pass it your root saga. So this, again, is very unique to Redux-Saga's configuration and instantiation. But now we have the saga set up. As far as populating the root saga with the corresponding sagas, this is where we need to really understand generator functions. So again, this function signature that we see here, the function star, that is a generator function. So I'm going to explain what that is in the next video, because right now, at the very least, we've set up the corresponding configuration for Redux-Saga. So now we can actually start writing out this code. So come with me in the next video. Let's learn all about generators. I'll see you in the next video. In this lesson, we are going to explore the most common building block of a saga, which is a generator function. Now, the generator function is a new-ish feature that was brought into the JavaScript ecosystem and native to JavaScript now. And what it is a function that resembles async await. Now, it's not exactly async await. It's got almost a different flair to it, but it's very similar in the sense that with our async await functions, we await our asynchronous events, right? Our promise-based events, where we pause the execution inside of an async function whenever we see the await call. Well, generator functions are very similar in the sense that they also pause their execution whenever they see a specific key inside of the function, and that key is called a yield. Now, I'll show you what that looks like when we write our first generator function. Now, in order for us to do it, there's actually a special syntax. We actually have to declare it with our old school style of writing function declaration. So we actually got to write function, but what we do is we put the star to declare that this is a generator function. And then what we can do is we can name our function. So I'm going to name it gen, and it's going to take no parameters for now. And all this function does is it calls console.log a, just the letter A, and then it console.logs the letter B. Now, when we instantiate this function, meaning that when we invoke it, we actually get back this generator object, which we can cast as some variable g, right? I'm just going to name this constant g, and it's going to be equal to us invoking gen, the function. Now, if this was a regular function, the moment I invoke gen, console log A and console log B will be logged out to our browser. And then G would just be set to undefined because functions that don't return anything would just return undefined. But in our case, when we invoke this gen, we see that nothing has happened. In fact, if we were to log our G, we see we get this weird gen suspended generator kind of object, right? So this is a generator object. And what we do on it is we call .next on it. And what .next will do is it will actually resume the execution inside of our function. So at this point, when we invoked it for the first time, we instantiated this generator object that actually is aware of the code inside of this function, but the execution inside of the function is paused. So until we call gen.next, this function actually will not run our console logs. But the moment I do, we see that it does. It logs out A and B, but then you see that we get back this object from calling .next. And what it is an object with a value prop and a done prop. The done prop is a Boolean telling us if there's anything else in the function to run or has it run through its entire course, which we know it does because all we did in our function was console log two things. Now this will change once we start using the yield key, and the yield key will also give this value a value. And I'm going to show you how that works. Let's refresh and let's make a new function, right? So again, we're going to call it gen, but this time we're going to take some integer value. And what we're going to do is we are going to yield the value that we pass in. The next call, we're going to yield I plus 10. So that's all we've done is essentially we're saying we write this function, right, called gen. It takes some integer value, some number, and then it yields that number that we passed in. And it also yields then the number plus 10. So now we're going to set some G value equal to our gen initialized with the value of, let's say actually 5. Now what happens when we call G dot? We know that we are going to actually get back that similar object that we saw before, right? You remember when we logged it, when we invoked next the first time? That object with the value key and then the done key. Well, I'm actually just going to make sure to hold on to that value. So I'm just going to call it gobj, right here. And now when I call it, you'll actually see that when we see what's on our gobj, right, our gobj is equal to that object, except now value is the I value that we yielded out the first time. And we'll also see that done is false, meaning that there's more that we can actually continue the execution on inside of our generator function. If I were to call g.next again this time, right, and let's set it to another object. Let's call it just jobj, right? Well, now we'll see that jobj has the value of the next yielded value, which is 5 plus 10, which gives us 15. It also now sees that done is still false. If we were to call g.next one last time, then we see that the done is true, but there's no value that gets returned in the undefined. Now, this is the main thing to remember with yields. The moment we call yields inside of our generator function, the yield key is pretty much telling our generator function, oh, hey, I don't want to do anything with this, right? I'm just going to resolve it however it is. If it's an asynchronous request, I'm going to resolve it, the async request. But I'm going to pass that value out into this object that we get back, right? And I'm going to set it to the value prop. Now, you might be wondering, when it's done, is there a way for us to get a value in this function? Well, actually, there is. The way that we would do it, right, let's just copy this, is we would actually cast it as the return value. So the last thing we can do is say return 25. And now if we did the same thing as we did last time with gen 5, if I do g.next, right, we see that this is up to our second yield. If I do g.next one more time, well, the final value that gets resolved is our return from our function, and then the done is true. But the main benefit is that the yield will invoke the value, right, of whatever it's yielding and return it outside of our generator. This is primarily what generators are used for. It's just if you want to stash multiple executions, but you want to control when you want to move and continue the execution in this function onwards. And this is the basis of sagas. Sagas work on this yield-based format because they need to know and give us control over when we want to continue with an execution of the block of code that we've written, or we want to do something with it first. Now, it'll make more sense once we start writing it, but I just wanted you to see this generator syntax. I did not want you to be confused by what we're about to write, because what we're about to write is going to look kind of different from code that we've written before. The closest comparison I'm going to draw, again, is to async await. But now that we've seen this as well, we just need to remember that whenever we see yield, we just need to know that our code is stopping at this point, even if it's asynchronous code, just like async await. So let's dive into implementing sagas into our code base. Welcome back, everyone. In this video, we are going to write our first saga. And the saga we're going to make is the category saga. This saga is primarily going to replace our fetch categories async thunk. So what we want to do first is we want to create a new file inside of categories. I'm going to call it category.saga.js. And inside, what I need to replicate is this method. So I'm going to copy over our fetch categories async thunk just to use as a reference, because we're really moving from thunks to sagas here. What I need to import are going to be first 4 of the saga-based effect generators. So these are very similar to the different methods that we use inside of actual generator functions. However, sagas have Redux bindings on them, meaning that we're able to access the Redux store, we're able to dispatch to it, and we do so through these methods. So first what I'm going to do is import from Redux-Saga/effects. And that effects pretty much tells you these are side effect generators. I need take latest, I need all, I need call, and I need put. So I'm going to discuss what each of them do when we use them. For now, we just need to import them in. Next, what we need this get categories and documents. What we also need is we need our actual action creators. So what I want is the fetch categories success, and I need fetch categories failed. And why we don't need fetch categories start, I'm going to talk about in a little bit once we actually start writing our saga. And the last thing we need is the categories action type. So now that I have this, the first thing I want to do is I need to set up the actual export from this sagas file. This is pretty much an accumulator that holds all of your sagas that are related to the category. So here I'm going to generate this generator function, so export function with the star. And then I'm going to say categories saga is equal to a function, and it yields the all call. Now, all is essentially an effect that says, hey, run everything inside and only complete when all of it is done. So remember with yield, at this point, it's going to execute this, and any further calls that we have down here don't happen until this finishes. So it's a pause essentially for this level until everything on this line following the yield is finished. All says that you can give me an array of different things that you are calling, or different functions, different generators, whatever. And what it will do is it will wait until all of them complete before we continue. Now, inside of this array is where we are going to add our generators when we write them. So the first generator I want to write is something that triggers when we call fetch category start. So generators respond to actions the same way that reducers do inside of their switch. With a switch statement, we say, hey, whenever I hear this action, I'm going to return something from my function. With sagas, it's similar. Whenever an action happens and I hear it, I want to do something with it. So this is where we first write our generator function. So this is going to be function star, and I'm going to say on fetch categories. So this just means, hey, the moment I hear the action, category action types.start. So before, our async was the thing that actually fired off the actual action. But now instead, we are responding to category start. So here what I'm going to do is say, hey, I want to yield and I want to call take latest. So take is where we receive actions. Take latest means if you hear a bunch of the same action, give me the latest one. All the previous ones that heard, let's say we heard the same action 5 times in a row, back to back to back to back, before the generator finished, cancel the previous one, just restart with the latest one. Again, that'll make more sense once we write these actual sagas out. So take latest gets 2 arguments. The first is the actual action type that you want to respond to. So here, I want to respond to fetch category start. The next argument is what you want to actually happen. So this is where we are going to create this fetch categories async saga. It's essentially all the code inside of our try. So we're saying the moment we hear category start, run all the code that you had in here. So here, let's make a export function, fetch categories async. Now, of course, we'll clash because we already have a function definition here, but we're going to get rid of it anyways. And inside of fetch categories async is where we are going to pretty much do everything we were doing inside of the try. The only thing is we need to modify this so that it works within the generator, because you cannot have async await in the generator. Again, the generator is actually the basis for async await. And here, instead of await, we need to yield. Anytime you call a function, what is happening with this function is that this is an asynchronous event that happens. And await is saying, hey, I want you to wait until this comes back with something. Yield is very similar. I want you to wait until this comes back with something. But this needs to be a generator effect, which is where you use call. Anywhere you have a function and you want to turn it into an effect, you essentially use the call keyword. The way that call works is you pass it a variable, which is a callable method. So for us, it's the get categories and documents method. And then what you pass to it are going to be the parameters for this. So get categories and documents receives a string, if you remember, and we're passing it the category string. So by calling it like this, we're saying, hey, this is the method, call it with these parameters. And now that we have this, what we need to do after is we need to actually dispatch out fetch category success when categories array comes back. But we don't actually call dispatch inside of a generator. We call put. So here we're going to say, I want you to yield put, and then we're going to call our fetch category success with the categories array. And then we're going to do the same thing with fetch categories failed in case we actually fail. And that's it. This is our fetch categories async saga. We then take this and we pass it as the second argument of our onFetch categories take latest. And now the way that the code will flow is that essentially we're saying whenever we take the latest, fetch categories start action. What we're going to do is we're going to initialize the fetch categories async saga. This saga is going to attempt to fetch our categories array from Firebase. And if that's successful, then we are going to put, which is the generator version of dispatch, this fetch category success action with the categories array. If this fails, meaning to fetch Firebase ever fails, then instead we're going to take that error and we are going to dispatch a fetch categories failed error. Both of these actions that get generated go back into the Redux flow and in turn will update the reducers or any sagas that are listening for these actions. Then what we're going to do is we're going to take this onFetch categories saga and we are going to listen to it inside of our categories saga aggregator. So here I'm going to say all is going to get the call with onFetch categories. Similarly, we need to take this category Saga and import it into the root Saga. And here, this is coming from our categories, category Saga. And what we're going to do, very similar with our root Saga as we have with our other aggregator sagas. We're going to yield the all call with an array, passing call category Saga. The last step that we need to do is that inside of our shop component, we need to stop dispatching fetch categories async. If you remember inside of this category action, this is no longer necessary because we no longer work with thunks. Instead, what we're going to use is we are just going to say, hey, fetch category start, because that's what this category Saga is listening for, fetch category start. So that is going to be what we dispatch out from our shop component on mount. And now if we go back to our application and we restart, what we see is that we see our fetch category start. And then what we see after we get the start is our fetch category success, which is a Redux-Saga action. And inside of here, you'll notice that we have indeed our categories payload. And of course, our state updates appropriately and the rest of our application works, hence why we can see these products. So this is it. This is our category Saga migration from a category Thunk. So right now, you may not realize why this pattern seems so powerful. What was the point of switching to the Thunk to a Saga when it really just seemed we had more boilerplate code added? This becomes much more powerful once we need to start coordinating multiple async events. And that's what we're going to do with the user actions and user thunks. So join me in the next video where we will tackle that together. I'll see you in the next video. Welcome back, everyone. In this video, we are going to tackle converting out a lot of our Firebase user methods into a Saga. So what do I mean by this? Currently inside of the application, we actually have a bunch of Firebase methods that are asynchronous methods, but we're keeping them inside of our components. So when you think about our sign in with Google method that calls, of course, our sign in with Google pop-up, or if you think about our sign in with user email and password, a lot of these methods we are currently baking into our components. If you think about our sign up component, we also have a similar create auth user with email and password method, also asynchronous and all interacting with our Firebase API. Finally, we also have this observable listener that we instantiate on the app. And all of this code currently is living deeply nested inside of our components. With sagas, we can attempt to remove these and put them into sagas so that our components are more free from this asynchronous code. In order for us to do that, though, we have to think deeply about what we're trying to do. So one thing I want to know about this auth listener is that unless we are inside of a component, we don't really have a way of keeping track of some kind of listener and then unsubscribing at some point. What we should do instead is convert this over into a promise-based single check to see if there is a user. So there's a couple modifications we need to make in order to convert this into a Saga-based flow. But through doing this, we will see an interesting pattern emerge with sagas. One thing I do want to mention is that this is not necessarily the right way to do it. Because Firebase has been optimized through their auth listener for us to essentially write this code very simply, there's nothing wrong with the way that we've coded out our app, our sign-in, and our sign-up. This is simply a way for us to code out sagas so that we can see what happens inside of a flow where we don't have something like an observable listener for authentication. And it's also another way for us to get more practice in terms of writing out auth flows through sagas. So this is a very important thing I do want to highlight. One thing as well is that we need to be able to convert a lot of this code over to asynchronous but more promise-based code in order for this to work as well, because generators, as we know, are essentially async awaits. So in order for us to make this work, though, we need to start by converting this on auth state listener code over into some type of single check. So instead of having a listener that responds every time a user state updates, instead we're going to wrap this in a promise inside of Firebase utils. So first things first, let's define this function. This function is going to be called getCurrentUser because that's what we're really trying to do. We're trying to see if there is an active user that's been authenticated already. And what we want to do, of course, is convert from an observable listener into a promise-based function call. So here what I'm going to do is I am going to return back a new promise. With this promise, we have the resolve and we have the reject, which are the positive and the negative handle cases for a promise. Resolve goes down the path when you successfully retrieve the value that you want back. Reject is what happens when you usually get some kind of error that you want to catch. So what we're going to say using a little bit of cleverness is we're going to say, okay, we know we have the unsubscribe from on-auth state changed because we get back the unsubscribe from the listener. So what we want to do, because this is a promise, is we don't want this listener to stay active. We want to unsubscribe the moment we get a value. Now, this on-auth state changed is what we get back from Firebase. We're not actually using the listener that we created for the actual application because now we're trying to modify it. So on-auth state change takes the auth object and then it takes the callback. And the callback, of course, gives us the user auth when it successfully gets a value when it first instantializes. The moment it instantiates and it gives us the user auth, we'll know immediately from that user auth whether or not there was already an existing user logged in. If there is or isn't, doesn't matter to us. The key thing is that we have the value and immediately we're going to unsubscribe. So we're going to close the listener. If we don't do this, there will be a memory leak, meaning that that listener is always active inside of our file, but we don't want that. We don't want it to take up more memory. So once we unsubscribe, we are also going to resolve with the user auth because now, of course, we have the actual user auth. Now, remember, this listener itself is asynchronous. So we're going to resolve the moment we get the value anyways. Once we're done with this, the other thing that this on-auth state change takes is a third optional parameter, which is a callback that runs when an error is thrown in the process of trying to fetch for the user auth. This is where we're going to pass our reject. Reject is a callback that takes the whatever you pass to it, usually it's an error, and it will actually reject it so the promise knows to reject. In this particular case, we're passing reject to this on-auth state change listener. The reject will pass the error into it, and then everything will behave as we expect it to. So this is our getCurrentUser. If I copy this and I go into our app.js, and what I'm going to do is I will remove all of this code that we don't need anymore. And what I'm going to say is, hey, just getCurrentUser. Just so we can test. This might actually end up being the way that we set up our code, but I want to test this function to see if it works. Inside of getCurrentUser, remember, this gives us a new promise. So I can actually call .then on it, and .then will get us back the user auth, which we can console log. So here, if I save this, and I go back to the application, there we see it logged. This is our user because we have a signed in user, and it runs when our app mounts for the first time. So using this method, we have now managed to essentially move out of that listener. So what we can do now is put this inside of a Saga, which will trigger a check. From here on, we need to now migrate the majority of the code that we have across the sign-up form, the sign-in form, and this app.js into a Saga and a series of new actions that will all perform these behaviors for us. So now I want you to join me in the next video where we will continue breaking this up and thinking about these flows, but now in the context of Sagas. I'll see you in the next video. Welcome back, everyone. In the last video, we created this getCurrentUser method. In this video, we are going to set up our actions so that we can utilize it inside of our Sagas. So what I want to do is I want to go into the user types. And here we're going to start adding some additional types to replicate all of these different methods we need to encapsulate. So let's think about what we have. We know we now have this new check user session, which is going to call that method we just created together. Additionally, we also know that we have different forms of sign-in, such as our Google sign-in, which we're going to create our Google sign-in start for. And we also have that email sign-in. So similarly, we're going to do an email sign-in start. One thing I do want you to understand though, let's go back to the code we have for Google sign-in start, email sign-in start, as well as check user session. So previously, let me just undo this so that we can at least see the code that we had before. So here inside, we have now encapsulated this method inside of our new getCurrentUser method. The thing here is primarily this create user document from auth. Essentially what we do whenever a user signs in, signs out, or signs in with Google, we are passing them through this create user document from auth. This methodology is now going to live inside of our Saga. The thing though is that no matter how the user signs in or signs up, they all pass through create user document from auth. All of our auth updates get triggered inside of here, which is what actually stores the user inside of Firebase in one of our tables, and then we extract it as a user document. So this means that all of our Google sign-in start, email sign-in, check user session, these are all actually flowing through the same sign-in. So here what I'm going to make is actually a sign-in success. Just a generic one, which whenever you successfully sign in with email or Google, you're going to pass through the same sign-in success saga. So we want to trigger a sign-in success with that user object that we receive. Similarly, this means that we also want a sign-in failure, a generic one as well, for any failures in our ability to sign in. So this is enough for us to at least start with some of our base sagas. Now, of course, we can always add more as we go, but I'm going to copy these 5 over as well because I want to make new action creators for them. So in order to keep track, I'm just going to put them here. And the new action creators we're going to make is one corresponding for each of these actions. So I want to say export const check user session is equal to create action, and then us passing in our user action types dot check user session. Next, what we also need is the Google sign-in start. So I'm going to export const Google sign-in start is equal to a create action passing in user action types dot Google sign-in start. We're also going to need a similar one for email sign-in start, which is equal to us saying this action, create action, and then user action dot email sign-in start. The thing that we know about email sign-in start though is that we need an email and a password. So these we're going to pass through as a payload inside of an object. Similarly, we know we need sign-in success and sign-in failed as well. So let's say sign-in success is equal to us receiving some user object or user auth. We'll figure that out once we start coding it out, but we'll use a placeholder for now. And we'll say create action using user action types dot sign in success. And then we'll pass the user through as the payload. And of course, we have a similar sign in failed. This, instead of giving us the user, will give us an error, and we will call sign in failure with the error. Actually, you know what? Let's call this sign in failed instead of failure, like that. There we go. So let's copy this over and let's update the corresponding action as well. So there's our new action creators. As for the reducer, we need to update as well. Inside of the reducer, we are now again no longer setting this on setCurrentUser. Additionally, we also need to add is loading, because now we're going to be fetching as well. We should also probably add the error state, which will default by null. And now what we want to do for this case user action types setCurrentUser. We still setCurrentUser, but now what we want to do is we want to attach it to most likely sign in success. So here we can say user action types dot sign in success, modify the state current user with the payload. Now, whenever we get a sign in failure, here we'll say sign in failed, and we'll return back with the state. We can set error equal to the payload. And there we go. This is at least enough for us now to begin checking to make sure if our users are going in or if our errors are going in. So let's go into our user folder and make a user.saga.js. In order for us to write our sagas, we know we need our 4 different generators. We need take latest, we need put, we need all, and we need call from Redux-Saga /effects. We also need our user action types. Additionally, we now need some of our actions. So let's bring in the ones we made. We made a sign in success. We made a sign in failed. We also made a Google sign in initialized or a Google sign in start, as well as email password sign in start. Now those though, we're probably going to dispatch from our sign up form and our sign in form respectively. So we don't need to make those in here because those actions will be dispatched from the components. Finally, what we also need is probably some utility functions from our Firebase, but again, we'll figure those out once we start actually coding out what's necessary. So the first thing we want to do is start instantiating our actual aggregator function for users. So here I'm going to say function star user sagas. And inside, as you know, we say yield all, call, and then whatever sagas we write. Oh, sorry, we don't need the const. Just export function user sagas. And here now, we want to set up the different entry sagas we have. So let's start with just the one that we made, the onCheck user session. So here I'm going to say export our generator function onCheck user session. This method is going to yield take latest off of our user action types.check user session. When this triggers, what we are going to call is a thing that will run that new function we created inside of our Firebase utils. So let's bring that in. Utils, Firebase, Firebase utils. And the method is the last one we just made here, getCurrentUser. So here we're going to make a new saga that will call our getCurrentUser. So let's think about what we want to call this. Let's call it something like is user authenticated, because then at least we'll know whether or not there's an authenticated user in our system. So let's export out a saga is user authenticated like this. And then inside is going to be a try catch block. Now I want you to take a second and think, what are we getting back from our getCurrentUser? If you remember, we get back this user auth object. So here, what we can say is const user auth is equal to yield, and then we can say call getCurrentUser. Because we are not actually passing in any parameters, we don't have to pass any subsequent arguments, but this is still going to call this just with no parameters. What we'll get back though is the user auth if successful. If it's successful and user auth is not equal to null, because remember, user auth can also be null. Null being there is no signed in or authenticated user, such as when we sign out, or if we are signed out. Then if that case, we don't really want to do anything because there's nothing to do with this null object. We only want to use it if there is a value. Now what we want to do with this user auth is essentially pass it to a new saga, which will handle creating an object for us inside of our Firebase, which was what we did before inside of our auth listener. But now we're going to move it to a Saga. So I want you to take a second and think about how to do that. In fact, try and do it yourself. In the next video, we will move on from this and then tie all of the other methods of email sign-in and Google sign-in to that same Saga. So join me in the next video where we'll do that together. Welcome back, everyone. In the last video, we were setting up our isUserAuthenticated method. Here, what we're saying is that once we call getCurrentUser, which is our promiseified version of checking if the user is still authenticated, we get the user auth. And if it exists, what we're going to do is recreate that process we had where we checked if the user doc reference exists. If it does, check the snapshot to see if that data is inside of our Firebase. If it is, then we return it. If not, then we generate it. If you remember, this is a method that lives inside of our Firebase utils as createUserDocument from auth. The key difference here is that once we had the user doc reference and we got the user snapshot, and after we generated everything, we return the user doc reference. Instead, we want the user snapshot because the data lives on the snapshot. The document reference is just a pointer to that space where that data could live. We want the snapshot now so that we can get the data and store it inside of our reducer. So here what I'm going to do is bring in that method that we just had, createUserDocument from auth. And I'm also going to make a method now that I will call once we have the user auth object. And all of our sign in, sign up with Google or with email and password are all going to flow through this new Saga. So this Saga, I'm going to call our getSnapshot from user auth. This is going to receive user auth as well as those additional details that we need when we do our sign up. If you remember, createUserDocument from auth also takes in the display name that they fill in during the sign up step. So here inside, we're going to have a try catch block. And what we're going to try to do, again, is essentially figure out if we can get that user snapshot. So here I'm going to say const user snapshot is what I'm going to try and get back from yielding to calling this method create user document from auth, passing it the user auth object, as well as additional details. Anywhere you're going to call a function, you want to use the call effect generator. Now, inside of Redux-Saga, every single step that yields, you want to be as descriptive as possible. Now, descriptive here essentially means creating an effect for it. That's why these are called effect generators. An effect is essentially a plain object that describes what's trying to happen. So here with call, this is just going to say, hey, I've got some object where the function name is going to be create user document from auth like this. And then it's going to say params are whatever these subsequent are. This might not be the shape, but this just gives you an idea. What this allows us to do is actually make testing easier when we're going to test sagas, but also we're just essentially handing over the execution of this API call or any of this code to our actual generator. And you want to hand over as much to the generator as you can because the generator is going to be the one that can cancel these. But more on that later. The key thing to know is that anywhere you're going to make some kind of call to either a new Saga or to some function method, especially if it's an API call or asynchronous call, use the call effect. So now that we have our user snapshot, let's just console log out user snapshot as well as user snapshot.data. What we also want to do is that if this fails for some reason, we want to yield out that sign in failed method, passing the error down. Similarly, if we fail inside of our isUserAuthenticated, I'm also going to use the same sign in failed method. And now that we have our new generator, let's call this inside of our isUserAuthenticated method. So here we're going to say, once we have this user auth, if it's not null, assuming that they're trying to sign in, then we're going to call our get snapshot from user auth method that we just made. And we're going to pass it the user auth as the argument. So now we're going to save this. We also need to pass this in as the second argument of our take latest and pass this into our on check user session using our call as well. And then we're going to take the user Saga, go into our root Saga, import it, and add it to our root Saga. And finally, what we want to make sure we also do is inside of app.js, where we were mounting before, and we had our initial auth state listener, and then we were testing get current user. We don't need any of this anymore. Instead, all we're doing is triggering our check user session. So that's what we want to dispatch out. So now that we have everything, let's go over the flow of what's going to happen. The app's going to mount. It's going to dispatch check user session. Check user session is our new action type, which we have a Saga that is listening for. Once we hear it, we are going to call isUserAuthenticated, which is going to call our getCurrentUser method. This is that promiseified version of checking if our auth state has changed, i.e. if there is a user auth that still exists. If it does, it's going to take that user auth and it's going to pass it into getSnapshotFromUserAuth. GetSnapshotFromUserAuth is going to use that user auth object to determine if there is a user snapshot for it. If there isn't, it's going to make one. If there is, it won't, but either way, we get it back, on which we will console log out to see the data. So let's go back here. And down here, we see that after check user session fires, we're getting our double logs. Here is the data where we see all the fields that we want. But what we don't see is the ID. You'll notice that the ID is actually on the snapshot. This is one of those more annoying parts of Firebase's data, where you need to get the ID from either the document reference or the snapshot. So what we have to do in order to actually push this data into our reducer is we will yield out put, and in this put, we're going to say our sign in success, where we're going to pass it an object where ID points to user snapshot.id. And then we'll spread through the rest of our user snapshot.data, like so. And this, if we go back to check now, we see that we get our sign-in success from our Saga, and inside of user, current user, this is all of the data that we want. So there we go. Everything's working now. My challenge to you now is to figure out if you can hook up and create the remaining Sagas as well as the corresponding components in order to move all of the sign-in, the sign-up from Google, from email password into our Sagas and flow everything appropriately through our new getSnapshotFromUserAuth Saga, as well as replace the remaining component code with the appropriate action flow. And you may even need to add new action types to get everything to work. But we've essentially learned how to set up most of this code now. It's really just about getting granular about it and practicing. So try it out, and then join me in the next video where we will go through everything else together. Welcome back, everyone. In this video, we are going to create the sign in with email and password and sign in with Google Sagas now. So to start, what we want to do is we want to create the entry point Sagas. So these are the ones that trigger based on the start action of the corresponding email sign-in or the corresponding Google sign-in. So here, let's start by saying export function for our Saga on Google sign-in start. And this will yield take latest of our user action types dot Google sign-in start. Here, we're probably going to use some method, which is on Google sign-in, or we can call it even something more specific, like sign in with Google. Actually, I like that nomenclature better. This is what we're going to use. We're going to say export function, sign in with Google, and this is what's going to trigger our Google pop-up. So if you remember, we had already created the utility functions for ourselves inside of Firebase utils. So here we're going to say sign in with Google pop-up is what we want to import in, and we want to try and catch block. Inside of our try, what we're going to try and do is trigger the pop-up and then take that authentication object, pull off the user, which is the user auth, and then run that through our get snapshot from user auth. So here I want to yield call on our Google sign-in pop-up method. This value is going to return us that auth object, if you remember. And on it is a user keyword, which gives us the actual user auth object that we use so far inside of our Saga. So with this value, what we're going to do is we're going to call our get snapshot from user auth. So here we are going to yield out calling our get snapshot from user auth, passing in the user. This should now work, but we can't test it yet without setting up the rest of our catch. So here we're going to yield put sign. We're using sign in failed because we have the same failure action for all of our sign in failures. So we're also going to pass error like so. And then we're going to now pass this on Google Sign in Start into our user Saga. So we're hooking it into all of our Saga flows. Now, in order for us to actually trigger Google Sign in Start, we have to dispatch the Google Sign in Start action. And we're going to do that inside of our sign in form. So instead of actually manually calling the utility method, we are now going to dispatch, which means that we need to import in use dispatch from React Redux. And we also need to bring in the action creator. So let's import in from our store folder, our user, and then user action. And this should be Google Sign in Start. And then inside of sign in with Google, we just dispatch, which we get back from use dispatch. And now we can dispatch the appropriate Google Sign in Start. So now let's test to make sure everything works here. Now here we are back inside of our website. You'll notice that we have our sign out. Some of you may still be signed in, some of you might not. If you notice, when you click sign out, nothing happens. But under the hood, we've actually still triggered our Firebase sign out method, which does sign us out. It's just that we haven't actually connected the components. But if you click sign out and then you refresh, you will notice that we are now not signed in. So now we can navigate to sign in. We can hit sign in with Google. And there we see user Google Sign in Start. It triggers our pop-up, which we can now use to actually sign in successfully. And if we look inside, there we go. We see we've signed in with the correct user. So everything works for me. Now what we want to do is do the same thing for our email sign-in. So in order to set this up, it's pretty much going to be the exact same steps, except using the actual sign-in with email and password. So first, let's start with creating the entry point Saga. So again, I'm going to need an export function. And this time it'll be on email sign in start. This is going to yield take latest on user action types dot email sign in start all the way up here. And here I am going to call this on, let's think of a name. Thinking of names is honestly sometimes one of the hardest things. Let's just call it sign in with email. And this is going to be a new generator function. And here we're going to try with what we need. So let's think about this sign in with email. This is going to receive the full action. So when you call this, the action actually gets passed in like this. So the action has the payload, and on the payload is going to be the email and the password. So when we think about what we're passing in, we need to look at the user action. The user action is passing us email and password as an object. So here we can actually destructure this off like so. We can say, I want the payload, and then off of the payload, I want the email and password as two separate parameters. And then what we're going to do with that is we are going to very similarly get the user off of the auth object we get back from yielding to calling the sign in auth user with email and password. Now that's a method that, if you remember, we also made before from Firebase utils. So this method we are going to call, and we're going to pass it email and password like so. Then once we get the user object, just like we did before, we're going to call getSnapshot from user auth, which we're going to pass the actual user auth object. And then we're just going to catch the error. And on the error, we are going to yield our put sign in failed. So now with our sign in with email, we need to make sure that we add this into our appropriate Saga. And also, we need to set up the sign-in form component so that we trigger it with the appropriate email and password. So here, if I remember, it's email, sign-in start. And down here, where we were originally actually calling sign-in user auth, we will now be dispatching instead. And we're going to dispatch with the email and the password. And now, this is pretty much it. Let's just get rid of this unused. Import now. Go back to the application. We'll hit sign out. We'll refresh. We'll see that we're no longer signed in. We have the appropriate fields. We hit sign in. There we go. Sign in success properly. And again, the user is the correct user. So we have everything that we need. Again, if you have not done this before, if you watch me do it, it's honestly relatively straightforward because the hardest part was really setting up this get user snapshot from user auth. And a lot of it was just rethinking about how we coordinate Firebase to do this for us anyways. So now my challenge to you is to finish the rest with the sign up. The sign up and also the sign out. Currently, we just call the sign out method, but I want to see if you can figure out how to set up sign out so it also fits within this flow. Because sign out itself is also an asynchronous API call because we're telling auth to sign us out of Firebase. So do that and then join me in the next video where we'll do it together. Welcome back, everyone. In this video, we are going to write our sign up sagas. Now, the sign up sagas are a little bit more interesting. The reason why is because we're probably going to have to make it in multiple steps. If you remember with how our sign-up form component works, is that when the user submits the form, we check if their password matches. If it does, then what we do is we create an auth user with the email and password. So this creates a user auth for us, very similar to Google Sign In. Once we get that user auth object, then we manually trigger create user document from auth. The reason being that when you sign up, you are not signed in. So signing up and signing in with that signed up user are two different steps. We did merge the actual sign in step with generating the actual user document from the user auth. So that is an additional thing that we will need to do. So when breaking up the saga, these are probably going to be two sagas. One to create the user and one to sign in the user with the signed up user. So the first thing we need to do is inside of our action types, create the 3 new action types for sign up. So we'll say sign up start, user slash, and then we need sign up success, user slash, and then we need sign up failed. And then we'll create the corresponding actions. So the first thing we need is that when we sign up start, we are going to receive the email, the password, and the display name, because those are the only fields that we ask them to fill in. From here, we are going to create a new action using our new sign up start. And then we'll pass an object as the payload where we have the email, the password, and the display name. We also need this sign up success. So with sign up success, let's think about what it is that we're going to get back. We're going to get back that user auth object, and then we need any additional details that we're going to store for that user. For us, that's most likely going to be the display name that gets passed through. And if we in the future choose to add more fields, we'll have to also add those in here, but those are all going to fall under this category of additional details. So here I'm going to say sign up success is going to be us receiving an object where we have the user and the additional details. We're going to say create action, calling user action types dot sign up success. And then we're just going to pass through the user and the additional details. So here, because this is the same, we can technically actually tweak this a bit. Maybe we can make it so that when we call sign up success, we get them as separate fields, which we then aggregate inside of this object. This might be much more clear rather than actually passing an object. And then finally, we need our sign up failed, which is just going to give us an error. And we'll call create action on user action types dot sign up failed. And here we'll pass the error as the payload. So let's start actually writing the sagas with these three new actions. So first what we're going to do is we need the entry point saga. So I'm going to say export function on sign up start. This is going to yield take latest on user action types dot sign up start. And here I'm going to call sign up, which is the name of this generator that I've yet to write. So here, let's create it. We'll say export function star sign up. We receive the action. Off the action, we just want the payload. And off the payload, we're going to get the email, the password, as well as the display name. And now what we're going to do is we are going to attempt to create this user auth object. So of course, we have our try catch block. And then we need to actually bring in the method that we had created in our Firebase utils, our create auth user with email and password. So importing it in, we're going to say yield call create auth user with email and password. And here we're just going to pass email and password. We don't do anything yet with a display name. When this call succeeds, what we get back again is an auth object that we've already seen before. So this is on the user key as we've done so far up to this point. And once that succeeds, what we'll do is we'll say, hey, we have succeeded in signing up. So we'll create that sign up success method. Now this is that action that we had just created right here. And what we're doing is we're dispatching sign up success. Sign up success doesn't actually do anything to our reducers. It's not for the reducers. It's for our user saga. So we need to create yet even another entry saga for on sign up success. And here we're going to yield take latest our user action types dot sign up success. So we're listening for sign up success. And once that happens, we are going to trigger a sign in after sign up generator. So this is where, as I mentioned, we need to break up the two steps. So we'll need another generator, and this generator is going to receive the action that we had made for sign up success. So it's going to get a payload of user and additional details on the action. So we're going to want to destructure off payload, the user and the additional details. And then we're going to yield all of these values to our get snapshot from user auth. And there we go. That is our sign in after sign up generator. So what we need to do now is just make sure that we're actually passing the appropriate values to our sign up success. So sign up success is going to get user and additional details as two values. So let's set that up where we pass them in as user and then the additional details as an object with just display name. And then that's pretty much all we need for the try section. As far as the catch section, we need to yield out the put as we always do where we have sign up failed, and we pass the error. And now that we have these, we need to make sure that we're also listening for them inside of our Saga. So we'll call both on sign up start and sign up success. And then once we're all listening, we need to make sure our sign up form now is actually dispatching sign up start. So here what we'll do is we will bring in our hook so that we have access to dispatch. And we also need to bring in the appropriate sign up start action creator. And then we need to get the dispatch from the use dispatch hook. And then with dispatch, we now replace this method right here with our dispatch, our sign up start, and then we pass it the email, the password, and the display name. So we save this. We have everything set up. So now let's sign in. Let's use my good friend Mo, who builds the React Native course. I'm going to say mo@gmail. And now if I sign up, we see that we have our sign up success, and we see that we have our sign in success. Inside of here, if we look inside of our user and our current user, you may notice that there's something odd here in the fact that we only have our ID, but not the other values. This is actually something that's a little bit annoying about Firebase with this create user through email and password. Sometimes this is a little slower. And what it's doing is it's rectifying and actually trying to rewrite this. This might actually be an error with V9. I'm not fully sure, but if you refresh, because we know we've successfully signed in, if you now check inside of your current user, you actually see all of those other fields that we had. So this is one tiny little tweak that actually happens that we got to watch out for. But at the very least, we know that on our side, as far as our code is correct, that's all that really matters. But here we go. We have our sign up and then we have our sign in. So this is a really monstrous and challenging part of the course. Absolutely. A lot of new concepts, a lot of coordination, a lot of new patterns with generators we haven't learned before. But before we move on, there's still one more, which is sign out. So I do want you to try and figure it out yourself first. If not, join me in the next video. We'll code out sign out together. I'll see you in the next video. Welcome back, everyone. In this video, we are going to make our sign out into its own Saga. Now, the reason we have to is because even though Firebase is signing out the user, we are not aware that Firebase has done so because we don't have an auth listener anymore. So we need to now make this sign out process part of our actual sign out Saga. So to do this, we need to, once again, create the sign out trio. So we'll have our sign out start. We'll have our sign out success. And we'll have our sign out failed. Using these three, we now need to create the appropriate user actions. So when you think about it, with sign out, we actually don't need anything. All of signing out is going to just set everything to null. So as long as we succeed, technically, we don't need any payloads. So I'll say sign out start is just equal to us creating the action of sign out start. Then our sign out success is just us creating, there we go, create action, user action types, sign out success, and we need the same thing for our failed, which is just us saying sign out failed. Actually, this should be sign out success. Actually, sign out failed, we need the error. My apologies. Failed always has the error payload, but success doesn't. Because success, we're just going to set it to null. So let's go into our user reducer. And this is what we're going to say. We want to say that on user action dot sign out failed, like so. This actually allows us to multiple match if you stack them like this. In fact, we even need sign up failed. That's another failure that we didn't account for, like this. And now we've accounted for all three. If sign in success, if sign in failed, sign out failed, sign up failed. Now we have our reducer set up. So we have our actions, we have our reducers, now we need our sagas. So for our sagas, we know that what we need to do is we need to listen for on sign out start. And also we need a call to our Firebase so that we can get the method that signs out our user. So here, what we are going to do is we are going to do a entry on sign out start like this. Yield take latest user action types dot sign out start. And here what we're going to call is sign out. Sign out is going to be a generator, and this is just going to receive nothing, as we know. What it's really going to try to do, though, is call our sign out user method, which we need to import in. This is what we've been using inside of our navigation. So now instead, we are going to wrap this inside of our try catch. So we're going to call sign out user. If this is successful, then we will say that sign out success, which this should have auto imported. If you didn't do it, you need to import it for your user action. And while we're here, actually, let's also bring in sign out failed, because we need sign out failed as part of our catch block. Like so. So that's our saga. We have our sign out, which is being called by our on sign out start. And then we have to call it inside of our user sagas. And then the last thing to do is now to update our navigation component so that sign out user is calling sign out start. So we got to bring in our use dispatch. And now instead of calling this Firebase utils version, we need to bring in the action creator from store /user action. Sign out start like so. We need to get dispatch from use dispatch. And then what we can say is const sign out user is a function that dispatches out sign out start like so. And now, if we go into our application, we see that we are signed in. If we hit sign out, there we go. That updates. But we notice that for some reason, even though our sign out success works, our user is still signed in. So this is where we need to account for it inside of our user reducer. We need to say that case user action types dot sign out success. We need to return state current user goes to null. So oftentimes when you see your code not working the way you expect it to, chances are you've missed one of these 10 different little nuances inside of Redux that prevented it from updating. Honestly, this is a very common thing. Notice how much we're typing, how much boilerplate we're adding. This is honestly one of the most annoying things about using Redux and Sagas. It's so much boilerplate. But the main thing is that if something's not working, you know the flow. Actions to reducers to sagas, it's gonna be in there somewhere. You just have to figure out which one it is that you're missing. And now, if we come back, we refresh. Let's just make sure. We sign in. We see we're reflecting it. We sign out. There we go. We've signed out successfully. User, current user to null. That's it. All of our users have now been migrated over to Sagas. And this is the last of migrating our code over to Sagas. I know it's a lot. Honestly, it's overwhelming for me too. Every time I think about working with Sagas again, there is a lot of boilerplate to work through in order to get it to work. But Sagas are very powerful for this reason. Because of so much encapsulation inside of these generators, this coordination is present. Now, if this is challenging, don't worry. I'm completely with you. Sagas is challenging. A lot of this are very advanced patterns that honestly most intermediate React developers might not even come across with Sagas. So this is just one of those things that it's just part of the path of becoming a very advanced React user, is getting familiar with Redux and all of its ecosystem and figuring out when you need these libraries at scale. But you can see how with a lot of this, we're able to now encapsulate and control so much of the flow of data inside of our Redux system. So that's it. This is our lesson on Sagas. This is really the last of the more challenging and most potent parts of Redux that takes the hardest part to learn. So if you made it through, I really want you to pat yourself on the back because this is really challenging to have all done so soon. But now you understand Sagas. Let's move on with the rest of the course.
Hello everyone and welcome back. In this section of our course, we are going to learn about Redux Toolkit and how to use it inside of our application. So Redux Toolkit is a library created rather recently, a couple of years ago, by the Redux team, and it is a, as they call, official, unopinionated, batteries included toolset for efficient Redux development. Earlier on in the course, you remember I mentioned that I didn't want to teach you Redux Toolkit until I was certain that you understood how Redux works without the toolkit. The reason why is because Redux Toolkit is a package that makes it easier for us to write the boilerplate code that we familiarized ourselves with writing up until this point. What it's going to do is it's going to make it much quicker and faster for us to write out all of our Redux code. But I didn't want to teach it to you until I was certain you knew how to do it without it because it is a quality of life improvement. And in that magical quality of life improvement, it might make it a little bit harder for you to understand what all the parts of Redux are doing. But now that we understand all those parts, it's much easier for us to understand Redux Toolkit in the context of knowing Redux without it, so you know what the toolkit is doing for you in the first place. So what I want you to do is go into your resource folder and take the link that takes you to this repository, Crwn-Clothing v2 Redux Toolkit. I want you to clone this code down, and once you've done that, let's take a look at where this code is. So when I fork this out, this repository is where we were just after we've implemented Redux, but before we started doing asynchronous Redux. So before we started doing thunks and sagas. And if you look inside the code, you'll notice that inside of the store, we have our persist, we have our root reducer setup, we have all of our reducers. And the reason why we want to start from here is because I want to talk about what it is that Redux Toolkit is doing that makes it so it's easier for us to write out some of this code that we have already. It's been a while since we've been in this specific state of the application because we started using Typescript, we started doing sagas and thunks. So I want you to take a quick second just to go through and familiarize yourself with where the code is now. You should remember, because it's still exactly similar to what we've already got in our latest version of the application. It's just a couple changes back before a lot of the major additions that we had. So once we have an understanding of where we're at with this current code base, what we're going to do is we are going to go into our terminal and add in Redux Toolkit. So you're going to say yarn add at redux.js/toolkit. And this will now install our package for the toolkit. And let's wait for that to install. Now that we have Redux Toolkit installed, back inside the application, what I want to do is I want to go to store.js first. And what we're going to do is we're just going to comment out everything, because there's a lot of what we need to understand about what the toolkit is doing so that we can understand the actual code that we're working with. To begin with, before we were using the Redux library to import our apply middleware, create store, as well as compose.
We're not going to use this Redux package anymore. Instead, now everything is going to come from Redux Toolkit. So to begin off, let's import in configure store from Redux.js Toolkit. And this configure store function is going to take the place of create store as well as apply middleware. So I'm going to comment this out and I'm going to show you how this works. So first off, I want you to copy this configure store and then scroll down here. Instead of this export const store equals create store, we are now going to call configure store and we're going to pass it an object. This object is going to have this property of reducer. And this reducer is going to point to the actual reducer that we're going to give it as the root reducer. So for us, of course, it's in the name. Our root reducer code is going to stay the exact same. So we're going to take this root reducer and plug this in right here for our reducer. And now this is all you need in order to configure your store object with the new Redux Toolkit. It's just configure store now instead of create store. As far as our middleware is concerned, in order to add the middleware in, we have to learn a couple things about middleware. So what I'm going to do to begin is I'm going to uncomment out logger, and I'm also going to uncomment out this middleware's array where we check to make sure that we only include the logger if we are in development mode. With this now, what we can do is we can actually add the middleware into this configure store under a middleware section like so. So if you type middleware, here you can pass it an array and include our middlewares. Well, our middlewares itself is already an array, so you can just do this. But before you do this, there's a couple things I want to mention about Redux Toolkit. The first thing is that Redux Toolkit now includes 3 middlewares by default. One of them is Redux-Thunk. So Redux-Thunk, if you remember, is a way for us to write promise-based actions so that we can do asynchronous Redux. By default, Redux Toolkit ships with Redux-Thunk. You can remove the middleware by passing your own middleware. So the moment that we do this and we pass it the middleware, we are actually saying, hey, I don't want you to use your default middleware. I want you to use what I'm giving you. So if we do this, we now no longer have access to Redux-Thunk. But if you don't include anything, so you have no middleware property passed in, you are saying, hey, I want you to just give me the default middleware that you ship with, which is Redux-Thunk, and then 2 other middlewares, which we'll talk about later. The only reason I want to talk about them later is because they're really more so meant to help you catch some errors or some suggested opinionated things about how you should work with your Redux store that right now we're not really looking at, but we'll definitely cover them in a little bit. So for now, let's just say, okay, we understand how to add middleware, but before we add the middleware, we're just going to look at our basic store. So we learn how to configure our store. We know how to give it the reducer. We know how to give it middleware. But what about the actual Redux Toolkit library, and what is it doing for us that makes it a little bit different when it comes to writing our reducers? So here inside of our root reducer, everything here is about the same. The way that we wrote our reducers is okay. The only thing is that combined reducers is coming from Redux, and we're no longer using the Redux library. Instead, again, we are now using the Redux.js/toolkit. We're still using combined reducers though. This is still the same function. So all we're doing is we're changing from using Redux instead to Redux.js Toolkit. That's the only change we're making. So let's save that. And this is all we're doing in order to make sure our root reducer works as well as our actual store is up to date. So here's the other thing though. We have commented out Redux persist, and we'll talk about Redux persist later. But in order for our code to work, we have to also comment out this persist gate, because now we are no longer getting a persister from our store since we've commented it out. So that's just one major change we need to do in order to get started with understanding Redux Toolkit in the base setup for the store. Now that we have this, let's take a deeper dive into how Redux Toolkit actually helps us write our actions as well as our reducers. And I'll see you in the next lesson. Welcome back, everyone. In the last video, we learned about how to set up a bare bones Redux store using Redux Toolkit's configure store. In this video, we are going to talk more about some of the other quality of life improvements when it comes to writing Redux code that comes with Redux Toolkit. And we're going to start with our reducers. So I'm going to talk about the user reducer first and modify this to use Redux Toolkit because it's the most simple reducer we have. All it is pretty much a basic value of just current user, which we simply set whenever the action of set current user comes through our Redux store. So the flow of data and everything with Redux Toolkit is the same. Remember, the actual implementation of Redux does not change. All Redux-JS Toolkit does for us is it makes it easier to write Redux code. The way we did it before was that we would write our own reducer, and our reducer is just a function that receives the current state as well as the action, and then it will return you back an updated state. That's all it is. And inside of our reducer, we have this switch statement where we check based on the type of the action whether or not we want to respond. If we don't, we return the state as is. If we do, we return a new state object with the modified values. But it's always a new state object because Redux demands that all of our reducer code return objects that are immutable, meaning they cannot change. So this is very key. I want to stress this, and I know I've talked about this extensively already, but I just want to refresh this because there's a couple things that Redux Toolkit does that looks different but still enforces these same rules. So to begin with, we are going to import in create slice, which is this method from Redux Toolkit. This create slice method essentially takes the place of us actually writing out this reducer. So in order for us to start using it, I am going to say export const, and I'm just going to say user reducer old, just so that we can clarify. With our user reducer, which is now utilizing create slice. Create slice is a function. You pass it one parameter, which is an object. And this object is going to have a couple key values on it that actually tell us what this reducer is going to do. So the first one is the name. Now, this name value is going to be what you want to name this slice, but also what it does is it actually namespaces actions for us. Create slice not only creates the reducer, but it actually creates the actions as well as the action types. Now, this is one of the interesting things about create slice and Redux Toolkit is that we no longer have to define our own action types. This is now being handled by Redux Toolkit. So here I'm going to say, again, create slice, name, users. When I say this name is the namespace under which this action fires, if you remember before inside of our user types, what we were doing is we were always defining a namespace. Here I called it user, but the action type was set current user. That user is pretty much what this name is. So instead, you could do this, name is user, and this will give you that same namespacing. But the actual actions being generated is where we actually have to pass in another value in create slice. But before we do that, we also need to tell it what the initial state is. So this is the next value. Initial state points to initial state like so. Now, I mentioned before the actions. Before we did it with a switch statement. Now it is an object nestled under this reducers value. So reducers is exactly as it sounds. A reducer is a function that receives a state and an action and then returns you an object. Instead here, it's not the same. What we're doing is we are actually now going to define the name of the reducer function that represents the action that updates this slice of the user reducer state. So here I'm saying set current user like so. Now you might be wondering, oh, Yihua, this is a function that you're defining inside the object. How does this work? Well, here what this is it's just shorthand. Instead of saying set current user is a anonymous function like this, I'm instead saying, hey, just use this function namespace. Remember, we can write functions like this as well. And this will now create a namespace for us of the function. So instead, because of this
ability that we have in order to just define variables on our objects like so. That's all we're doing. It's just shorthand for that. So setCurrentUser is a function that behaves like a reducer. It gets the state and it gets the action. So the state here is going to be the current state of our user reducer slice. The action is every action that passes through our store. So as far as the flow of actions inside of a Redux application, all of this is the exact same. None of this changes. Again, Redux Toolkit is just a helper tool. It doesn't actually modify the underlying way that Redux behaves. This here, setCurrentUser, is going to be the action that we create. And we are going to respond inside of this user reducer whenever setCurrentUser is being dispatched. And what we do is we say, okay, what I want to do is I want to update the current user with the payload. So we're really just replicating this right here. This piece of our old reducer, we're now replicating in this new way. And the way that you do it inside of Redux Toolkit is you actually mutate the state, at least in your code. You're going to say state.currentUser equals action.payload. This right here is equivalent to what we were writing here before. Now you might be wondering, well, Yihua, didn't you tell us that one of the core tenets of Redux is that state is immutable? You should not mutate the state. What's actually happening here is that even though this looks mutable, it's actually under the hood still generating you a brand new object. Redux Toolkit is actually leveraging a library called Immer that is ensuring that these changes that look like mutations actually aren't mutations. It's just easier to read according to the opinions of the Redux team. Instead of having this really complicated structure which could grow where you're constantly spreading values, especially for nestled values, where we could imagine that, let's say, we had a deeply nested object that represented the state. Instead of doing it like this and then modifying, let's say, we had a user property on here, and here it was another object, and we would have to, let's say we didn't even change it. We would have to do something like this, potentially. And let's say it was the name value that we changed. Then you can see how this gets really crazy if you were to just constantly nestle all of this spreading and such. This was one of the trends that they noticed inside of the way that people were writing Redux before, which was that you would have these really difficult to read states. So one of the changes that they made was that, well, we know that mutations are much easier to read, but the problem with the legibility that you gain is that you lose the advantages of immutability, predictability in your code, which we've talked extensively about. Here, by using this mutation style, you're getting the readability, but under the hood, Redux Toolkit is actually still making sure that all of this is immutable. What it will do under the hood is that when it sees that the state value has been modified, it will perform a differential itself under the hood. It will see, oh, there's a mutation on this state object. Instead of mutating the state, I'm going to generate you a new state object just with these changes, which is the equivalent of what you see here. So this is a very critical thing about the way that you're going to write reducers using create_slice, is that you are now writing mutation-esque code on the state itself and just relying on Redux Toolkit under the hood to actually do the differential and also the generation of a brand new state object. So again, it looks like a mutation, but it's not. And this is due to the fact that under the hood, Redux Toolkit is using a library called Immer to ensure that there is immutability. It's just that you want to leverage the legibility of mutation style code. And this here now has generated for us a slice that pretty much replaces not only the reducer, but the actions as well as the types. So how does that work? Well, first, let's get rid of this because we don't need this anymore. Actually, instead of calling it user reducer, I'm going to call it user slice to make it more obvious, because user slice is actually an object we get back from create slice. And off of it, we can pull off the actual actions that we want. So I'm going to destructure off set current user, which is the name of the function that we wrote right here. And you're going to get this off user slice dot actions.
So .actions is one of the properties of the object returned from createSlice that has all of the actions that you write inside of your reducers here. Remember, I mentioned that these are actions that we get back. So that's one thing. The next thing is we want the actual reducer itself, because if this is a slice, what about the reducer that we pass to our root reducer in order to actually build out this slice of user? Well, this is under another namespace. So I'm going to say export const user reducer, which is user slice dot reducer. So under the dot reducer name, you get the actual reducer function that gets generated from createSlice as well. And this right here has now replaced both our reducer for user, it has replaced our action for user, and it has replaced our action types. So how do we actually utilize this new setCurrentUser action? That's what we're going to cover in the next video. But for now, what I want you to do is understand some of these big changes that have happened with using createSlice from Redux Toolkit. The major one is the fact that we're now writing mutations. I know this might seem a little bit more confusing because, again, immutability, but remember, the immutability is still there. It's just for legibility's sake, we are now using this mutation style and trusting Redux Toolkit under the hood to still be ensuring that our code is immutable. That's it. In the next video, let's utilize our new setCurrentUser's action and understand how we update our code accordingly. I'll see you in the next video. Welcome back, everyone. So in the last video, we learned how to use the createSlice method from Redux Toolkit in order to generate this slice object. On the slice, we were able to generate our actions based off of what we passed to this reducer's object, but also we generated the actual reducer itself. In this video, we're going to take a look at actually utilizing this action of setCurrentUser inside of our application. So before, what we had was inside of our user.action.js, we had our setCurrentUser function, which gets a user, and then it creates an action object where it's pretty much just the type equals this user type, and then the payload is the user. The action that we get here is the exact same. And what we're going to do is utilize it inside of app.js, which is where we were calling our previous setCurrentUser. So now, instead of getting setCurrentUser action from user.action, we get it from user.reducer. And here, this is pretty much just the exact same setCurrentUser we made in the last video. With this, that's pretty much it. We're still dispatching actions. The thing about this setCurrentUser is still an action creator. What it's done with this slice is that it's generated for us the actual action creators that are tied to the actual things that update the subsequent user reducer itself. So this setCurrentUser both created the action creator for us, which we have to use to dispatch the actual action that comes out of it. But also what it's done is it's created the corresponding reducer update with the same method. So now let's start up our server and let's take a look at it in action. But before we do that, let's just make sure that we're actually doing what we think it's doing. So remember here, setCurrentUser is coming from our user.reducer. So I'm just going to console log this. I'm going to save this, and then let's go into our application, and let's see what happens when we actually sign in. So let's go to our console. And here, when I refresh, on initialization, we see that our app.js is logging for us the action where type is user/setCurrentUser, and then the payload is null, of course, because on initialization, we have no signed in user. So everything here is correct. It's doing as we expected. Now, I want you to look at this type here, this string, user/setCurrentUser. This is where I mentioned earlier when we passed the name string into our createSlice, and we used user. That is this beginning part right here. The subsequent part is the name of the function. So going back to our user reducer, we see right here, name user, that was the initial half, and then the method setCurrentUser is also the action type that gets appended. So any new actions you create inside of this reducers is going to generate a new action type as well as the action creator that we just need to make sure that we destructure off and use. So here you can see how create slice has reduced our need for generating 3 files down to just the 1 file. Instead of a separate actions file, a separate reducer file, and a separate types file, we can now just congregate them all into one reducer file and generate the slice. If you want, you can call this user.slice.js instead of user.reducer.js to be more explicit, but it's really a matter of preference in this point. So with this, we now have everything we need in order to test the actual rest of our flow. So again, we're generating and dispatching out set current user whenever we have the user. So one thing that I do want to show you though is what happens when we try to sign in. So let's say we go to sign in and I hit my sign in right here. Here we do see that our payload is going through. This is indeed the object that we have been storing so far. But the one thing that you will notice is that we get this error. A non-serializable value was detected in an action in the path payload. So what is a non-serializable value? So a non-serializable value is essentially something in JavaScript that is not just a plain JavaScript object. These might be class constructors, things that are just not considered plain objects. The reason why this is throwing an error is twofold. One, the Redux team has determined that it's always been a best practice in order for you to only store non-serializable values inside of Redux. So these things, again, are plain objects, strings, numbers. That's it. No class constructors, no symbols, no promises, no functions. It has to just be something that can be stringified and understood. So in this particular case, we're seeing this error because what we get back from Firebase is this user IMPL class constructor. It has all the values that we need on it, but it is a non-serializable value in the eyes of Redux. And this error is being thrown because, as I mentioned before, when you look at your initialization of your store using configure store, you remember when I mentioned that with middleware, we get 3 middleware by default. One of that middleware was the Thunk. The other middleware is actually this non-serializable value. What this means is that Redux says that by default, I'm going to include a middleware into your store that will throw an error whenever you try to add a serializable value in an action or in your reducer. So here, what we're going to do is we can actually make sure that we can either abide by the suggestion of this middleware or we can ignore it. And this is where we're going to dive a little bit more into understanding middleware, because everything about our flow is working. It's just that we're getting this error right here about a non-serializable value. And there's a couple ways that we can tackle this. We can tackle this in the way where we address the middleware, or we can tackle this in a way where we can disable the middleware. And the ways that we can disable it are also numerous. That's what we're going to talk about in the next video. But for now, let's just highlight what we've done. We've created, using create slice, a slice for our user, and we've generated the reducer and the actions as well as the types. We are then dispatching using the action creators that come on user slice.actions and replacing what we had before. We're still dispatching these actions, but now we're able to actually dispatch what we had before, and our code still works the way it's supposed to. The only thing now is that we've tripped one of the middleware that comes by default with Redux Toolkit, which has to do with non-serializable values. So that's exactly what we're going to tackle next in the next video. I'll see you there. Welcome back, everyone. In this video, we're discussing one of the default middleware that ships with Redux Toolkit, which is the serializability check middleware. The reason why we're checking this, to go over again, which is what we learned from the last video, is the fact that we are trying to store a non-serializable value, which is not a string, a number, or a plain JavaScript object inside of our Redux store. The value we're trying to store, of course, is a class constructor that we get from our Firebase. So it's not really our value, it's Firebase's value, but again, it's one that is not recognized as a serializable value inside of Redux. So it's tripping up that default middleware. Now, there's a couple ways that we can tackle this, and we'll discuss the pros and cons of each, because there's not one size fits all for everything here. Even though this middleware is throwing this issue, The reason why it's doing so is because Redux Toolkit, again, has an opinion about how you should be writing your Redux. Now, I know it's the Redux team, and oftentimes what they say is the best practice is, in their opinion, the best practice and the one that the vast majority of the industry does follow. But you will encounter scenarios where you will want to figure out how you can sidestep these constraints because you're trying to utilize the library to do something you need to in your job. And oftentimes, the best practice may not be the practice that you need. And that's a very critical point to remember. So they do give you a failsafe and a way to step around these default middleware. So let's talk about first how you might encounter doing this, which is to disable the middleware. The way that you disable any of the default middleware inside of Redux Toolkit is first, you have your configure store and this middleware attribute. So here, as I mentioned before, you can pass it an array of middlewares, meaning that we have our middlewares here, which includes just the logger. If you pass it an array, what will happen is that this will override all of the default middleware that ships. So if I comment this out and we go back to our application, as we refresh, suddenly we do not see that issue throw anymore. We see that our logger is working, but we do not see that error throw. The reason for this is because when you pass it your own middleware, Redux assumes that you just want to roll your own middleware. You don't want any of the middleware that they have included. But if you do want to include your middleware, as well as the ones that they give by default, then what you do instead of passing an array is you pass a function. Now, this function is going to return a value, and the value you return is actually going to come from the parameter that Redux Toolkit passes to you. And this parameter is a function called getDefaultMiddleware. So this function will return back to you all of the array of your middleware. So here what's saying is that you're saying, hey, I'm going to give you a function. Whatever you return back from that function is what I want you to use as the middleware. And for us, in order to access the middleware by default that ships, it comes back from this. That's why you're saying, hey, return back from my function what getDefaultMiddleware returns back, which is the array of default middleware that we have. But here you can now start customizing what you want those default middleware options to be. So it's kind of like configuration. And this configuration is in the format that we have become quite familiar with, getting used to how Redux Toolkit works, which is that you pass it objects. And these objects have key value parameters, which will be the ones with the configurations we want for each of them. Now, if we wanted to modify specifically the serializable middleware, you say serializable check. And here we actually see that our interface is actually even helping us. So serializable check is the actual middleware name. And if you say false, then what this will do is that this will turn off that middleware completely. It'll essentially say, hey, I don't want you to serialize and check any of the values coming into the store. And now if we go back to our application, and let's say we refresh. Here, once again, what we see is that we do not see our logger, meaning that we haven't included that middleware, of course, which we've switched over to using just getDefaultMiddleware. But we also see that the serializable check does not fire anymore, even though we are signed in. As we can clearly see here, we're also logging out our user IMPL class constructor. So we know that everything's working as expected. It's just that we're no longer getting that error log. So this is one way you can turn it off. There are much more granular controls that you can also do inside of the serializable check. You can even specifically target different portions of the actual store or the actions or the paths and then turn them off there. You can check out how to do that inside of the actual documentation for Redux Toolkit. But as far as we're concerned, if we wanted to turn it off, that's how we would do so. Chances are, if you're just serializing some values and not others, you might get confusing unless you write a note about it. And let's say you just turn it off for one specific path. Alternatively, you can turn it off for actions. There is, again, very granular configurations that you can do with their default middleware here if you want to turn on or off the serializability checks. Again, it doesn't actually prevent anything from happening. All this does is it throws errors for you when those things happen. It won't actually make your app crash the way that you typically see when errors get thrown, the way that we're familiar with them. These are really just checks and balances to help guide you along with the Redux Toolkit's opinion of how you should use Redux. So this is one way. Now you might be wondering, how do I get the default middleware as well as our own custom middleware? Well, here, remember, this function just returns us an array back because we're saying, hey, this function is going to be invoked and it will give you this return of get default middleware. So what get default middleware gives you back is the array. What we want to do is we want to concat whatever value we have back from get default middleware with any additional middleware that we want to add. So here we can just concat on our middlewares. And now we're saying, hey, this function is going to receive back from middleware the array that comes out of get default middleware concatenated with our own middleware's array. So one final array of all the middlewares we want, which include the default middleware as well as our concatenated middlewares. And now if we go back and we refresh, here we can see that we have turned off their middleware for serializability check, but we also see that we have also our logger working. So there we go. We have the code that we want. Now, you might be wondering, well, what happens if I want to make sure that I don't pass a serializable value? Well, this is simple. The best way that you can do this if you want to include the default middleware. So let's just say we include default middleware. We also concat on our middlewares, but we want to make sure that we fix the serializable issue. The way that you can do that is you just have to give it a value that it understands. So to do that, what you can do is you can actually pick off the values that you want to have. So remember, this is really a class constructor. Actually, let's keep this console log and let's take a look. We refresh right here. And when we look inside of this value that we're getting, the payload is indeed an object. It's just a class constructor that the actual middleware is uncomfortable with, but it has the values that we want. So what we can do is we can say, okay, I just want the values that I need. So I'm going to say const picked user is equal to a function. Then what it's going to do is it will pick off the specific values I need, including the access token and the email off the parameter you pass it. And what it gives you back is it gives you back a new object where it has access token and email as the only parameters. So we're saying, hey, I want you to generate for me an object with just the picked values. And here I'm going to pass it in the user. So I'm immediately invoking this function that we just wrote. And all I'm doing is I'm selecting off the values I want and I'm putting it into a new object. And I'm also going to make sure that I only do this if we receive a user. Because if we don't receive a user, as we can tell when you trigger our auth state change listener, you might get null if a user signed out. So only if we receive back a user am I going to invoke this function. Now, I do think I need to wrap these in an additional parentheses in order to actually capture this as its own expression. And there we go. So then with our new picked user, we pass it into our set current user call as the payload. And if we save this and we go back to the application and we refresh, here, what we will see is that indeed what we're generating now with the action creator is our new picked off user. And we also see that inside of our Redux, we are indeed storing that new user format. We also see that we're not tripping up that non-serializer middleware anymore. And there we go. We've solved the problem. So these are two different strategies you can do. The first one is you can modify the underlying serializable middleware itself. You can modify the configuration. You can turn it off for certain parts of your store or turn it off altogether. Or you can make it so that your values do pass the checks and you make it something that is serializable, just like we did now. So that's it. This is two different ways that you can interact with the second of the three default middleware that ships. The third middleware that comes is what we're going to discuss in the next video. So I'll see you there. Welcome back, everyone. So in the last video, we discussed about the different middlewares that we can use. These are the three that come by default with Redux Toolkit. The first one is Redux-Thunk, which we already know how to use.
The second one we discussed in the last few videos, which has to do with non-serializable checks. And then the third one has to do with immutability checks. Now, the immutability check is simply just the fact that you cannot mutate values in your store. What I mean by this is that if you were to go into your reducer, let's say, for example, we have some value called test, and it is an array of some values. Let's say 3, 1, and 2. Now, let's say that we wanted to access this value. So what we do is we go into, let's say, our app.js, and we pull useSelector. The reason we pull useSelector is because we want to access this test value. So actually, let's even say let test equals useSelector, where we get our Redux state, and we go state.user.test. So here we're pulling off this test value. If you run something like test.sort, where you're trying to mutate the array that we have, what you will see is that this will actually throw an error. Now, this is not necessarily the immutability check that will throw an error, because there are numerous checks and balances in place that typically prevent us from mutating state in general. In fact, here, if we look inside of our state, and here we will see that there is an uncaught type error that we cannot assign to read-only property. So the fact that it's read-only is telling us that this is immutable. Now, there are numerous things inside of React that is making this happen, meaning you cannot mutate these values that are not designed to be changed. The fact that we're running in strict mode means that we have frozen arrays. That's one thing. But even if we were to modify and change this to an object, we would see the same error. For example, let's say instead of an array, we were to modify this to be an object, and we set this as a equals 1. And then inside app.js, instead of sorting it, we say test a, so we're taking that value, and we set it to 2. If we save this and we refresh, here again, we will see that we cannot assign values to read-only properties. So again, these are values that are not designed to be mutated. Inside of Redux, everything needs to be a new copy. This we know from the way that reducers are designed. So it makes sense that the values inside them are also not meant to be mutated. So there are a lot of checks and balances against mutation in general inside of React and Redux. So even without the actual middleware, we can't even mutate these values, but it's the same idea that this middleware is really just preventing you from actually running any mutations inside of your Redux. Now, whether you want to keep it or not, again, it's not actually going to change your code. It's just a warning. But that's really what this last third middleware is doing for us. So that's it. Those are the middleware that we have. We now know how to actually modify the default middleware. Again, you can read the documentation to see what kind of configuration options the 3 middleware take. And then if you want to additionally add your own middleware, you just need to concat on top of the return of get default middleware. So with that, we have covered the majority of what we need to know about configuring the store as well as working with the base slice. What I want you to attempt yourself is to convert the remaining code over into using Redux Toolkit. So the last things that we need to target is the actual categories and the cart reducer folders. So modify these on your own, and then if you feel like you got stuck, you can join me in the next few videos where we'll do it together. I'll see you in the next video. Welcome back, everyone. So hopefully you got a chance to attempt to upgrade the actual categories and the cart reducer over to using Create Slice. If not, let's do it together. And even if you did, you can watch this video and see me walk through how we would do it. So first off, we know that we no longer need these category types. So what we're going to do is import in Create Slice from Redux Toolkit. We're going to keep our initial state. And now we're no longer going to use this reducer value. So here, let's actually just comment this out so that we at least have a reference to the old reducer so we know what we need. So here, instead of categories reducer, I want to call this category slice. And what I'm also going to do is now just invoke create slice and pass it the namespace of categories for our actions. And then the actual initial state, I'm going to pass our categories initial state variable. And our reducers is going to point to this object. Now this
value here is going to be very similar to what we had previously inside of our user slice, which is where we really were just generating out a set value. So here, instead, we're running set categories. Set categories is just a function that takes a state and an action, and we just modify this state.categories value to be equal to the new payload that we're receiving. And that is all we need. What we need to do next is we need to make sure that we're exporting out these actions, so specifically our set categories action. We're going to destructure this off of category slice.actions. And we also need to make sure that we also export out our categories reducer, which is on the slice.reducer. There we go. Now let me just remove our commented out code here. And then what we need to do is we need to make sure that we are calling the correct file now that we've moved over our action creator. So our set categories method, here we can see that it's used in the shop component. So instead of categories.action, it's now categories.reducer. Outside of that, everything else is pretty much the same. We want to make sure that we're dispatching our action creator and we're passing our categories array. Is there anywhere else that we're doing so? It does not look like it. We do see that we still have our category action.js file, but we, again, are not using that anymore because we've pretty much moved everything into the actual category reducer here. So let's just make sure that everything is working. Let's go back here. Let's refresh and open up. And in here, we can see that inside of our state, right here, that we are firing off our categories/set categories, and that we are still indeed getting all of our category code. So everything's working as we expect. And that's all we need for categories. What we want to do is we want to make sure that we tidy up and remove any of the files that we're no longer using. So just like with our user folder, we are just using what's inside the reducer.js file now. We no longer need what's inside of action.js. We also don't need user.types anymore. Similarly, with categories, we don't need category.action.js, and we also don't need category.types.js. Our selectors are still our selectors. This is perfectly fine to keep. It's really just what was changed inside of the reducer. At this point, if you want it to be more clear, you can also rename these to user.slice.js. It's really up to you again. But now that we've done it for categories, let's do it for cart. Now, cart is definitely much more complicated. The reason for this is because we have some of these helper functions we want to keep, but the action creators themselves we want to migrate. So here's what I want to challenge you to do if you have not done this. Try and figure out yourself which of these actual functions you want to keep and then which ones you want to move into using create slice. Think about it a little bit because here you'll notice that the flow of the inputs is actually going to change a little based on how we have done it so far. So that's my challenge to you. In the next video, let's do this together. I'll see you in the next video. Welcome back, everyone. So in this video, we are going to start migrating everything from our cart action that we need over into our cart reducer. The easiest way to start this is to look at what we have and then think about what to move over. So to begin with, we know we have these two helper functions, our add cart to item and our remove cart item. The reason why we do these is because we know that when we receive cart items and a product to add, we go by quantity. So we have to first find the correct cart item, update it, otherwise create a new entry for it. That's the way that we've been doing cart items. So here we can copy this over, and what we can do is paste this into our actual cart.reducer file. So now that we have the actual helper functions, what we can do is start moving over or migrating over the actual action creators themselves. So first off, we want to bring in create slice. And now with create slice, we need to actually start creating the reducer. So here we're going to keep our initial state, but we're going to get rid of this cart reducer. And instead, we are going to create our cart slice. And here we're just going to say create slice. And again, under the namespace for the name, let's just say it's cart. As for the actual initial state value,
we're going to, of course, pass in our cart initial state. And now for the reducers value. Now, remember, this is where we need to create all of these different action creators that we've been using up till this point. So what do we have as far as our action creators go? Well, if we scroll down here, we see that we have these 5. Set is cart open, clear item from cart, remove item from cart, add item to cart. Actually, we have one more additional helper function. Let's just take all of these for now. We're going to move this in as well. I missed one right here, our clear items from cart. And now here, these are the methods we need to implement. So the first is going to be the add item to cart. Now, add item to cart, let's make this one really clear. We receive our state, we receive our action. From here, what we're going to do is we're going to say state.cartItems is going to be equal to what we get back from our add item to cart. Because here, what we're doing before is we are setting the cart items equal to the new cart items. We don't need to do that anymore. Instead, now what we're doing is we are directly just going to modify it in the action itself. So what we'll do is we'll say state.cartItems is equal to add cart items, or add cart item, sorry. And this is where we're going to pass in the variables. We're going to say state.cartItems. So we're going to give it the current cart items, and then we're going to also pass in the payload. And now our add cart item helper function, which is up here, is going to do what it does, give us back the new array, and we will now directly just set the cart items equal to this value. That's pretty much all we need to do. And then similarly, remove item from cart is going to do a very similar thing. State action state.cartItems is equal to remove cart item. So here we're calling our helper function. And just like before, state.cartItems and then action.payload. Next we have, as you can guess, clear item from cart, state and action. And just as before, state.cartItems is equal to clear cart item, which is where we have our helper function, clear cart item, and then state.cartItems and action.payload. So that gives us these 3 functions right here that we need to use as our action creators. The last one is set is cart open. So this one, set is cart open, state and action. And here we'll say state.isCartOpen is equal to action.payload. And now we have pretty much everything we need. These are all of our new action creators. What we want to do next is we want to make sure we're exporting both our actions as well as exporting our reducer. So let's say export, and then what we need to export is going to be the destructured action creators we just made. So let's do set is cart open, add item to cart, remove item from cart, as well as clear item from cart. And this is equal to cart slice dot actions. And let's not forget to export our actual reducer. So we'll say cart reducer, which is equal to cart slice dot reducer. And there we go. We now have updated all of these values. So we want to make sure now that we're actually using the correct values inside of our code base. Now let's look for set is cart open. Here inside of cart icon, we are calling our old action creator, which we now know needs to come from our reducer file instead. And as far as what we pass through as the payload, this all stays the same. So that's one. Where else are we doing it? Inside of nothing else. We don't need our cart action anymore since we're no longer using this file. So let's actually get rid of it. And now let's find our remaining actions. We have also add item to cart. Add item to cart is inside of our checkout component, as well as clear item from cart and remove item from cart. So here we can actually update this file as well to our reducer. And let's look at what we're passing into clear item from cart. Here we're passing cart items as well as the actual cart item. We had to do this before given how the structure of our code was, but now we just need to simply pass the cart item because our new action creators are getting them directly from create slice. which means that we no longer need to use this selector anymore inside of our code here. So we can actually get rid of all of this. And there now we have actually, in fact, updated all three methods that are calling our add item to cart, remove item from cart, and clear item from cart. Now, is there anywhere else where we have add item to cart? Yes, there is inside of our product card component. So here, just as we did before, we're going to update the file to our reducer file. And then instead of passing cart items, we're just going to pass the product. And we're also now going to get rid of this cart items, the selector, as well as our use selector. And there we go. We've now updated all of our functions as well as all of our action creators. So going back to our code, let's make sure everything still works. Let's refresh. Let's open up our console just so we make sure we see everything that's firing properly. And now, if we add items to cart, there, we see we are indeed adding the correct items. We go to our checkout. Let's test our add item. That's working. Remove item. That's working. If we remove everything, and we also just click the X, we see that everything's working. So our cart is now up to date. Last things we need to do is we just need to remove any of the old files that we're not using anymore. So for us in particular, it really has to do with this cart types, because now we're no longer using this as a reference anymore. We can delete that file. And there we go. We've now updated everything using the new create slice. And that's really all there is to Redux Toolkit. It's really just helping us reduce the amount of boilerplate code we typically needed to use in order to write the Redux. We had before our selector files, we had our action files, our action type files, as well as our reducer files. Now we've managed to pretty much just bring it all down to one file that holds our reducer, our action creators, as well as our action types, as we can see. And then what else there is that we can also have a separate selector file, which we'll always need because we still need to call use selector to pluck off these values off the state. But this is really just about drastically reducing down the amount of boilerplate code you need to write in Redux. So that's really all the benefits of Redux Toolkit for us inside of our application. We've done this migration, and it all is pretty easy for us to understand because we're already extremely comfortable writing Redux code altogether. So learning how this toolkit worked and then how to implement it was really simple because it's really, again, just doing things for us that makes it easier to write the code that we already know how to write. So there we go. That was implementing Redux Toolkit. And now you can go out and write all the code that you need with Redux Toolkit. Or if you want to write it in basic Redux without Redux Toolkit, you know exactly how to do it as well. Let's move on. Welcome back, everyone. In this video, we are going to learn about how to perform a payment using Stripe. Now, Stripe in this particular case is what actually provides us with this credit card information. Because I'm in a testing environment, you will see that the automatic credit card is being disabled, but these are all different things that we'll learn about when integrating with Stripe. In this particular case, we're able to insert a Stripe number with test cards, of course, which is what we're using. And then from here, we can create a payment which will fire off into a serverless function that we will learn about that will then complete the actual checkout, and we can see it logged inside of our Stripe dashboard. So we're going to learn all about payment integrations from the front end as well as serverless functions in this upcoming section. So in order to begin our high-level discussion, I want to focus on Stripe first. We know that with web development, we have a front end and a back end. The front end is primarily where we've worked with all of our code throughout this course. All of our React code lives on the front end. We have not actually written any back end code at all. With Stripe, though, Stripe is a service that lives outside of our front end and our back end applications. Stripe has their own servers, Stripe has their own API, and we on our application, the combination of our front end and back end, if we potentially had a back end, would have to interact with these Stripe APIs in order to perform a payment using Stripe. This is a very key concept when it comes to using any external third-party applications that provide a service to our application. In our particular case, Stripe provides the payment service, which is what we want to leverage inside of our app. The way that Stripe can identify our application
to us is that it provisions us a secret key. But the key word here is that it's a secret. If we were to keep this secret key on our front end, which is a very common thing that you will notice, is that a lot of third-party applications will give you a secret key. If you keep it on the front end and you try to make a payment request from your front end, passing the secret key to Stripe so that Stripe knows that this is you, you'll notice that Stripe will block this payment because you are not allowed to keep that secret key on the front end because there is very limited security on the front end. Instead, what you have to do is keep that secret key on the back end. So what we need to do is be able to make a request to make a payment to the back end. The back end, which has the secret key, then communicates and makes a request to Stripe so that a payment can be made. From here, Stripe will then allow us to make this payment because it can tell that this is not coming from some front-end browser. So this is a very key pattern that we need to know about using Stripe. We have to set up some kind of backend. Now, when you think about backends are very typical. Essentially, from a front end, we make some kind of request to a backend, and the backend sends us back a response. Now, where is this separation between front end and backend? Front end is pretty much anything that has to do with user interaction and the logic that comes from a user interacting on a browser website. The backend is anything beyond that. Backend coding typically has a lot of database interaction, a lot of cross-service interaction, a lot of data management, a lot of service management, anything that has to do with DevOps, infrastructure, which involves scaling up and scaling down the amount of resources, which we'll talk about. But backend is in itself a very large beast. And any API that we interact with on the front end is typically speaking with a backend server. For us, of course, we have not built any backend, but as we saw with Stripe, we need to have some kind of backend in order for us to actually complete a payment request to Stripe. So here what I'm going to talk about is serverless functions, which is something that makes this process significantly easier for us who are primarily focused on front-end and learning React, because React is not a back-end thing. So what we got to do to understand backend, though, is traditionally how backends work. As I mentioned, there are servers. A server is pretty much what you can imagine your computer to be. There is some hardware that has something to do with memory as well as performance speed. So memory in this case exists in two forms. You have RAM, which is pretty much immediate memory, and then you have your disk, which is like your hard drive, which essentially is more long-term memory. So the immediate memory that comes from your RAM is very quick to access, but it's also something that disappears whenever the server restarts. In the particular case with your disk, which is your long-term memory, even if you restart the server, that data lives in there, but as a result, it's much more slower to actually update that data and retrieve that data. But these two things form the basis of your server. All of the additional code you write on top of that is leveraging these resources of your RAM and your disk. So backends are very similar. They're essentially these computers that don't have a user interface. It just has the resources. And then you host your backend code on these resources, and then your front end makes requests to these servers. So you can see your backend as a combination of the servers and the supporting infrastructure that allows this to be done. So here, if a front end makes a request to your backend, let's say, for example, we make on average 100 requests per minute. One server is probably enough to service all of these front-end requests. Maybe these requests ask for some data from the backend. Maybe we do some transformations. Maybe we send out emails. Whatever it is that we have to do through a server. Generally speaking, depending on your architecture, one server is probably enough to service these 100 requests per minute. The problem becomes when we start hitting massive scale. Let's say we hit the size of a company like Amazon or Google, where we're making 10K requests per minute from numerous front ends. At this point, your backend needs to scale up. One server cannot service all of these requests anymore. So you have to manually, or your developer team has to manually figure out how to code out systems that can scale up the number of servers in order to service these 10,000 requests. Now, remember, these requests do fluctuate because there are seasons. You can imagine that for a company like Amazon, during the holiday season, they get way more purchases and sales and therefore requests than they do perhaps in the earlier portions of the year or during down parts of the year. This means that they are constantly scaling up and down resources, and if they go back for some reason to 100 requests per minute during a season, they need to scale down the number of servers. So even in the middle, they have to be a variable amount of servers that go up and down. Sometimes you get 10,000, sometimes you get 2,000, sometimes you get 500, 100. The idea is that it changes, and correspondingly, there is a process involved that requires us manually scaling up and down the number of servers to serve these requests. This, however, costs money and time to do. It costs money because, of course, these resources, these servers, take up physical space in the real world, and therefore they need to be purchased, they need to be maintained, and this maintenance, as well as the code it takes to write to scale these up and down, takes time. This time comes from developers, which in turn also costs money. So for a company, building out their own backend that's scalable is often a very expensive endeavor. Especially for us who are just trying to learn React and need to make Stripe payments, having to set up all the infrastructure and consider all of these things for our backend is just largely a big waste of time as far as learning frontend goes. If you want to learn backend, it's an incredible learning experience. But again, we're trying to learn React. So in order for us to simplify the process of setting up a backend that simply allows us to just make these payments to Stripe, what we can leverage is serverless functions. Serverless functions is a very efficient way for us in order to perform these backend functionalities, but with very minimal resources and commitment on our end in order to set these up. So that's what we're going to talk about in the next video. Welcome back, everyone. In this video, we're going to talk about serverless functions. In order for us to understand serverless functions, we need to go back to our example of our front end with this backend, which we completely own, where we have to provision our own resources, scale up our servers, either horizontally or vertically, and all of the complexity that comes with managing this, which, as we discussed, is a costly from a time and a money perspective ordeal. This is where typically most platforms will utilize something like a cloud service. Cloud services are essentially infrastructure as a service, which means that you are paying a company like Google with their GCP, Amazon with their AWS, or Microsoft with their Azure. These are massive companies that have a ton of these server resources, these physical resources, which have both the RAM, the memory, the disk, the database, all of that resource available. What they also do is they will build out a lot of these toolings and services that we use and the infrastructure to support it when it comes to building a backend. So what essentially happens is that they are now able to scale up horizontally for you or vertically. All that's happening now is when your front end makes requests to the cloud service knows roughly based on the amount of requests that it's getting, how much to provision for you. And you just pay for what you need. This is an incredible time and money saver, and this is why cloud services are exploding right now and have been exploding for such a long time. So let's simplify this by talking about serverless functions. When it comes to usual backends, you're writing Express servers, Node servers, Ruby servers, Rails servers, whatever it is that you're writing, there are numerous flavors of how you can write a server. But this is a lot of complexity because these servers are probably most likely constantly up and running. In our particular case, with a lot of what we need from a backend, we really just need that security layer and maybe access to some of those backend libraries to be able to make a request for us, and then that's it. Maybe the length of the request lasts 5, maybe 10 seconds. Anything after that, it doesn't need to continue to live. It serves a singular purpose. This is where serverless functions step in. And what I mean by a serverless function is it's essentially a function that lives on the cloud, and this function performs that single responsibility. It spins up, it does its responsibility, and then it's done. This is where you can talk about different functions, such as a function that essentially makes a backend payment. It receives a request, it has an amount on it, it makes a request to make that payment for that amount to some other service due to the fact that it lives on the backend, it being more secure now, and then it sends back the response to the front end, it's done. That function has finished its duty, and now it dissipates. You can imagine there are many API requests that do similar things. You can imagine that there is a send email, where essentially we send our backend function some email address and then some body text, and then the email service function just takes that information and then fires the body to the appropriate email address, and that's it. This is essentially what serverless functions are. It lives on the cloud service that has these near limitless resources, and it will generate and spin up these functions whenever they're being requested. Now, each of these functions lives on an endpoint, so it's still like an API that you interface with, but the thing is that behind that endpoint lives just the services function, not necessarily an entire server. So let's discuss about how this works. The cloud service has access to all the functions that we give to it, essentially the services that we need this cloud to provision for us, these functions. So what happens is that a front end might make the same thing, where it makes a bunch of requests to our cloud service. We might receive 100 payment requests per minute. In this case, the cloud service sees, oh, I need to spin up some of these resources in order to host this make payment function. And then here what happens is that all of these requests go to this resource that has access to these functions. It spins up these functions make these payments for each of these requests, and then it sends back a response, and then it's done. And then the service will now downgrade and get rid of all of the provision resources the moment the requests stop coming in. If we start getting a ton of payment requests, such as 10,000 of them per minute, then again, the cloud service will spin up a corresponding amount of resources in order to provision a duplication of these functions over and over again for each of these different requests. Again, these requests handled and then responses sent back, and then it spins down the service whenever, in a similar way, the number of requests go back down. So it's essentially what you can imagine with having to spin up your own servers, but here we're relying on a cloud service to spin up and down the number of servers or the amount of resources so that we can primarily just host our functions. So this is essentially how this process works. But you can imagine also from a front end, we might be receiving a bunch of different requests. Maybe we got 100 payment requests per minute. Let's say we receive 3,000 API requests per minute and then 5,000 email requests per minute. Now keep in mind, each of these requests are requesting a specific endpoint for a specific function. So here our cloud service knows that, so it will correspondingly provision the right amount of resources to service the amount that's coming in for each. So let's say there is arbitrarily 1 unit of make payment services in order to handle the amount of requests for the make payment function. Of course, there will be more for the API requests. So again, the service will provision enough resources to handle the 3,000 API requests from the function. And then, of course, the send email takes the most, so it will provision just enough there as well. But the key thing is that it will scale up and scale down for the corresponding requests for each function. And each function gets the amount of servers that it needs in order to handle this type of request. So this is essentially what we're combining together. We know that from our front end, we need to make payment requests to Stripe. So what we're going to do is we are going to write our own serverless functions and host them on Netlify. Netlify is then going to provision the resources for us so that we can actually make Stripe payments. And that is what we are going to do. So now that you understand the high-level concept about why we need serverless functions and how they're going to help us, let's jump into the code in the next video where we can start figuring out how to interact with Stripe. I'll see you in the next video. Welcome back, everyone. In this video, we are going to learn about Stripe and integrating with Stripe, as well as setting up Stripe so that we can start writing our code to make payments against it. Stripe is arguably one of the largest payment platform services ever made. And right now, it is one of the most popular, if not the most popular, in North America and Europe. In order for you to get started, you need to have a Stripe account. So to set up a Stripe account, you get the sign in, and then inside of the sign in page, if you do not have a Stripe account already, you scroll down here and you hit the sign up. Once you've gone through the sign up process, join me back here where we will take a look at the view that we first see with the dashboard. So once you've done that, come back and let's continue. Welcome back, everyone. So once you've signed in and registered, you will see this page. you'll notice that you're asking and being prompted to activate the account. The way to do that is that you have to give it your payment information, as well as your banking information and your business information. So normally when you have a business, this is where that step becomes important, because only when you do that are they allowed to legally let you accept payments. Here though, we're just working with the actual developer experience. And the only difference is that once you actually have all of this validated and activated, you can flip this from test mode to live production mode. As you can see here, it says, please activate your account to access live data. For us, this does not really matter. The actual coding experience for us is the exact same. And all we really need are these two values. If you scroll down here, you'll see for developers, there is a publishable key and a secret key. These are the two keys that I was talking about earlier. The secret key being actually the most important one. The publishable key, as you can tell, means that you can display this publicly. It's not a concern if people know what that key is. The secret key, though, is something that should be hidden. So this secret key should live on our backend or our serverless functions, which we'll talk about once we get to that section. The main thing I want you to do is remember these two values. We're going to have to go back to them later when we actually start integrating with Stripe. Now, the first thing we need to do is install the actual dependencies so our React application can work with Stripe. So let's, inside of our terminal, run yarn add at stripe/stripe-js, which is the JavaScript library that allows us to make Stripe payments. And then we need add stripe/react/stripe.js. This is the library that gives us the React elements and React bindings so that we can interact with the Stripe.js library inside of the React environment in a significantly easier way. So as these are installing, let's go back into our application. The first thing we need to do is actually register our application so it knows to use Stripe. Stripe provides us these React components known as Stripe elements that we can use, such as the card component, which was that component we saw when I was typing in the credit card information. Stripe knows how to do that and use that in order to actually perform a payment, making the process significantly easier. But we have to actually register the application the same way that you would a provider. So to do this, what we actually need is going to be from the React integration from Stripe. So here I want you to run imports and then elements from @stripe/react-stripe.js. This elements is a component that you want to wrap around your app. So this is similar to a provider. Any components inside of this elements will now have access to the Stripe elements that we will use later. But we actually have to pass this elements component something so that Stripe knows that this is registered to us, meaning that this React application, when it makes requests, goes to our specific account in Stripe. Now, this is where we're going to need that publishable key. And the way we're going to use it is inside of this source folder. I'm going to make a new folder that helps us with Stripe. You can technically also put it inside of your utils folder. It really does not matter, but since we have a utils folder, actually let's use the utils folder. Here, we're going to make a new Stripe folder, and inside we're going to make stripe.js or stripe.utils.js. This is going to create and instantiate for us our Stripe instance. So in order to do that, we need to import load Stripe from Stripe @stripe-stripe.js. Load Stripe is what runs in order for us to actually know that this is our Stripe instance. So here I'm going to export out a const called Stripe promise. And this is equal to us calling load Stripe. And here we have to pass it the publishable key. Now, as I mentioned, the publishable key is perfectly fine for us to expose. But just for our own security with these keys, we might as well put it inside somewhere safe. This is where we're going to use something called .env. .env is an environment file that we can add that makes it so that only our application has access to these files, because essentially it puts it on your process environment. It doesn't actually make it exposable anywhere inside of your code repository. So in order to do that, we have to first add a file called .env. Now, because this application is made in Create React App, by default, the front-end React application allows us to use this .env. It's actually already installed when we installed our Create React application. The only thing, though, is that in order for us to use it, we need to make sure that any variables we define in .env starts with React_app, all caps. So here I'm going to say React_app_stripe_publishable_key is equal to the string value of the publishable key. So here I want you to go back to your application, copy the publishable key value, and then paste this into this section right here. So once you've saved this, you will now have access to this value. The one thing, though, is that we never want to actually push our .env file up into GitHub. So what we have to do is in the git ignore, add .env. So now Git will ignore our environment. Moving on, what we're going to do is go into our Stripe utils.js, and now we can use this by saying process.environment.react. Well, actually here you can just directly copy the name. I can't remember sometimes all these variable names. But what happens is that under the hood, React will merge this .env file with our process environment. So now all of those key value pairs we have are accessible on process.env. So now this is essentially going to load our Stripe instance with our publishable key, which identifies our application to Stripe as our application. Then we're going to take this Stripe promise and we're going to import it into our index.js. Because as you can guess, this is what we need to pass into our elements that we get from React Stripe. So here I go to utils folder, Stripe, Stripe utils, Stripe promise here, we're going to copy, and then inside of elements right here, we are going to pass it as Stripe equals Stripe promise. And that's it. This is what we need to set up so that we can start working with Stripe now and create the corresponding components. So again, .env was the new thing. If you want to add more environment variables that are accessible in your front-end application, you want to always add React_app. This only works, of course, in Create React App, but this is .env. So now that we have this, let's move on and start actually coding out our new Stripe components. I'll see you in the next video. Welcome back, everyone. In this video, we're actually going to start coding out our checkout form. So this is pretty much just going to be a very simple form. You can update it if you want. I'm just going to make it so that all it shows is the credit card input and then a button that allows us to submit. So what we need to do is go into our components, and I'm going to make a new folder. And I'm going to call this payment-form because that's all this is for me. It's just a form that allows us to make a payment, and we're going to embed this on our checkout page. So here inside, I need this regular two files. I need payment-form.styles.jsx, and I need payment-form.component.jsx. So inside of our component, let's set up what we need. We are going to first import in essentially this card element that I keep talking about that Stripe.js gives us. So here I'm going to import in card element from @Stripe -React Stripe.js. This is pretty much the key component that will show what we actually want to show, which is that credit card input. And then I'm also going to import our custom button because I need some button to actually make this payment. And that's it. Now, as for the component itself, I'm going to say payment form is equal to some component, and then I'm going to export it out as the default. So for now, all I want to do is just show the element. I don't even care about it working or not. I just want to make sure that I can see what I want to see. So I'm going to make a div, and then inside of the div, I'm going to place this card element. And then I'm also going to place a button, and inside of this button, I'm going to say pay now, for example. And also I'm going to say button style, or button type actually, is going to be the inverted button. So let's import in as well our button types. And here I'm going to say this dot inverted. And now with the payment form, we have to put it inside of our checkout component. So here I am going to import in our payment form from components / payment form component. And I'll just embed this right here down at the bottom beneath the total. So let's save this and let's go back to our application. And here we see it. It's a little squished because we have not defined the actual sizing correctly, but at least we see the component is loading in. Now, what we can do now that we know it works is start actually making this look a little closer to what we need it to look like. So let's go back into our payment form component. What we're going to want to do is we are going to want to create some kind of wrapping component as well as an actual form, because this is going to be a submittable form. So we essentially want to say whenever this form submits, then perform the actual Stripe payment. So for us to do this, we got to go into paymentform.styles.jsx. I'm going to import in styled from Styled-Components. And here I'm not going to do anything too fancy. I'm just going to do a really simple container and then the form. So I'm going to say export const payment form container is equal to style.div. And inside of this div, I'm going to say it has a height of 300 pixels. I'm going to give it display flex. I'm going to say flex direction is column. And then I'm going to make sure to align everything in the center. So align items center, as well as justify content center. Next, what we need is the actual form. So I'm going to export const form container, which is equal to a styled form. Inside, I'm just going to say that this thing has a height of 100 pixels and a minimum width of, let's say, 500 pixels. Now what we want to do is we want to go into our payment form component and import in both of these new style components that we created. So I'm going to import this from payment form styles, our new payment form container, as well as our form container. So here, I don't really need this div anymore because now we've created our payment form container. And similarly, we have our form container, which I need to make sure to wrap everything in. And I'm also going to put an H2. And this H2 is going to say credit card payment, like so. Now, what we actually need to do in order to start interacting with this card element properly. So the way that Stripe works is that you can actually pass this entire card element with all of the appropriate data once it's filled in to Stripe. This is why this component is so easy. In order for us to actually use it, though, we have to create a payment handler. So this is something we're going to say that on submit for the form container, we want to pass this. So I'm going to say const payment handler is equal to a async function because we need to make a API request, which is going to be asynchronous. So first what we do is prevent default because we don't want any of the typical form submission to happen. Now what we're going to do is we need to actually create a couple things with Stripe in order for this to work. So this is where we need to start introducing a couple hooks. From React Stripe.js, we need to import in the use Stripe hook as well as use elements. So here we're going to get a Stripe instance from use Stripe. And this is what we're going to use to actually make requests in the format that Stripe needs it to be. And then we're going to bring in elements, which is use elements. So very similar hook pattern that we're used to. Next, what we're going to need to do is we need to actually first make sure that these two hooks are loaded in when the payment handler fires. So in order for that to work, I'm going to say if there is no Stripe instance or there is no elements instance, in either case, I will just exit. I don't want anything to happen. So never proceed unless both of these are present. Then what we're going to do is we need to make a fetch request to our backend in order to create a payment intent. And a payment intent is essentially something that Stripe creates so that it knows that, oh, there is a payment coming. And this payment intent is what Stripe uses to actually confirm that there's a final payment about to happen. So for us to do that, we need to now start talking about our Netlify function. So we're up to this point now where we need to actually make a request to the backend, so we gotta touch upon the backend. So that's what we're gonna do in the next video. We're going to figure out how to create a Stripe payment intent with a Netlify function. I'll see you in the next video. Welcome back, everyone. In this video, we are going to set up a Netlify function. So the great thing about Netlify is that it makes it very easy for us to use these serverless functions. Under the hood, they use AWS's Lambda function, which is essentially a specific resource on the AWS cloud configuration that allows us to create these functions that run for 10 seconds roughly. So that's just enough time for us to actually create this request, wait for the response, and then send it back. And the way that we create them is inside of your root folder. You're going to make a new folder called Netlify. By default, Netlify is going to look inside of this Netlify folder for another folder called functions. And any functions that you define inside of here, which are JavaScript files, it will build for you during your build step. So it will actually proposition and create the correct resources so that it can serve up your functions whenever requests get made to them. So this is the first step. The next step is to actually name the function files. So essentially whatever the name of the file is whatever the name of the route will be. So here I want to call this create-payment-intent.js because what we're making is a payment intent. Now, in order for us to make this work, we need a couple back-end specific libraries. Specifically, we need the ones that allow us to work with Stripe. So to do this, what we're going to do with these Netlify functions is they share the same package JSON file as our root application. So we're going to add them to the same exact package JSON. So go back to your terminal. And what we're going to do is we are going to add in through the same package JSON. Remember, you're going to yarn add Stripe, which is the Stripe library we need for our backend. And then the other one we need is .env. Now remember when I mentioned that Create React App has .env under the hood? Well, for us, we're not in Create React App land when we're working with our serverless functions. It's like a brand new node environment. So what we need is going to be .env as well for this application. So now let's add these in. And then what we're going to do is go back to our application, and inside of your N file, your .m file, Netlify functions is going to share this same .m file in local testing. When we actually deploy this into Netlify, we will add these variables manually into the environment section of Netlify, but we'll talk about that when we get to the hosting section. What I want to do is be able to access this. So to do that, you need to go into your Stripe and add your secret key here. So I'm going to call it something a little bit more obvious. So something like Stripe secret key, because it's not for React app, but I'm just going to add Stripe secret key is equal to the string. Now I don't want to show you mine. You should never show your secret key to anybody. So just paste it and make sure it's a string. Go into your developer section of your Stripe dashboard and then just copy the secret key. You have to click it to reveal it and then copy it. But that's what I want you to do. I want you to copy it and then paste it into your secret file. And then when you come back, we'll have assumed that you've done that. Okay, so I'm going to assume that you've done what I said, where you copy your secret key, put it into your .m file. And now back inside of our serverless function, what we're going to do is we are going to require the moment that this mounts, we're going to require .env, and we're going to run .config on it. Now, you might notice that the code we write here is going to be a little different. If you're unfamiliar with Node, primarily we actually aren't using a lot of ES6 features. So this is one of these things that we're kind of going back to writing old school vanilla JavaScript. So if you're unfamiliar, don't worry, requires pretty much just an older version of import. So we're requiring the .env, so we're essentially importing in the .env library, and we're running config, which will essentially attach all of those secret variables on the .env file onto our process environment. Once we have that, what we're going to do is we are also going to get Stripe. So Stripe, we're going to say require from Stripe. And now, once we get this, what we're going to do is we are going to pass it our secret variable. So here I'm going to say process.env.stripe_secret key, because that's the name that I gave to my variable that has the secret key. And now that we have this, we can now start working with the actual function. The function that is housed inside of this file, it is the main export. So to do this, you're going to say exports.handler, which is, again, the old school way of saying export that we're used to. And this handler is equal to an async function that receives an event. And then what it's going to do is that this event is pretty much the request and the response. If you've ever worked with Express before, this is essentially a stripped down version without Express. It's just a very basic function that will receive this event request and then do something with it. So here I'm going to write a try catch block. And what I'm going to say is that when you send me this event, I am going to make a payment intent to Stripe using this Stripe library. In order for me to make a payment intent, though, there's a couple things I need to know. I need to know the currency, and I need to know the payment method that I'm going to accept, as well as the amount. So here I'm going to say, okay, I'm going to assume, and this is something we need to know, and pass in. We're going to pass the amount as an integer. And essentially, it's going to be a value. So let's say if it was $100, we would pass in 100 followed by 2 zeros. So it's essentially in cents. There's no decimals. So it's a whole number. So we just got to think about whatever we're passing through. If we're assuming it's dollars, just multiply it by 100. This amount is going to come from the event body. But because it's in JSON, we need to parse it. So we're going to say JSON parse event.body. So on that event body is going to be some value amount, and that amount is going to be the actual integer we use. Then what we're going to say is, okay, I'm going to make a payment intent. So I'm going to say const payment intent is equal to await, because again, this is us making a request to the Stripe server to say, hey, I want to make this payment. We're going to say stripe.paymentintents.create. So this is from the Stripe library. We're going to create a payment intent and pass it an object where we're going to give it the amount, we're going to give it the currency, and here I'm going to say USD. And then we're also going to say underscore payment method types. This is going to be an array which accepts the different payment types that we can perform for this. I'm going to say it's just credit card because I'm not taking any other payment intent types. And then once this is done, we're going to return this back. So we're going to return an object with a status code of 200. And we're also going to pass back a body object. And this is us JSON stringifying an object with a payment intent as the key value. So that's all this is doing. So essentially we're saying, hey, if you give us this value and we succeed in getting a payment intent, we're going to send this back to you. If there is an error, what we're going to do is we're going to log the error for ourselves inside of our development environment so that we can see it. And then what we're going to do is return back status 400. And here we're just going to pass back the error. And that's it. That's all we need for this function. Now, in order for actually to test this function, we need to actually leverage something called the Netlify CLI. The CLI will allow us to build our entire project in the kind of environment that Netlify would, but doing it locally on your own computer. So we have our function set up. In order for us to hook this together and test it, we're going to need Netlify CLI, which we'll learn about in the next video. So again, what we've done now is we have set up a very basic function that receives a request where we expect an amount value. We then pass this into Stripe to make a payment intent, which as it sounds like, it's an intent to make a payment that Stripe registers. And then what happens is that we return that intent back to the front end, if successful. If unsuccessful, we return back a 400 with the error. Very simple. And now we're going to hook this together with the Netlify CLI. So I'll see you in the next video. Welcome back, everyone. In this video, we are going to install the Netlify CLI, which stands for Netlify Command Line Interface. It's a terminal tool that we can use in order to simulate the Netlify environment when it comes to building out our application, which also involves allowing us to build up our Netlify functions so that we can interact with them in a local environment. Similarly, the Netlify CLI is going to take the place of our typical dev server. So that's what makes it really handy because again, it's simulating our build process for us. So what you can do is cancel your current build server inside of your terminal. And what you're going to do is you are going to run npm install-g. So we're going to globally install onto our terminal or into our computer the Netlify-CLI. So while this is installing, I'm going to talk a little bit about what the CLI enables us to do. Using the CLI, you can essentially control as much of the Netlify platform as you would through the Netlify website UI. The only difference is that with the CLI, you can do it all through the command line. This is useful when you want to run programs that actually perform some of these functions for you. So if you want to programmatically set variables, update different things on the actual website profile that you have, you don't have to go through the interface to do so. You can do it through the CLI if you are a power user like that. CLIs are very useful for that reason, primarily because they give power users the ability to do everything they need to. So here we see that it's done. And in order for us to make sure it works, we just run Netlify in our command line. What we should see is that there is a list of instructions that we now have access to. So the primary one that we want to do is first log in. So if you run Netlify login, this will connect your Netlify CLI to your login instance. So if you hit this, it will prompt you with whether or not you want to open up the browser to a Netlify account. Now, I, of course, am already logged in. So what you can do when it prompts you, say yes, it'll take you to Netlify where you will sign in. And once you've signed in, it'll redirect you. And now your credentials are linked to your Netlify CLI. Once you have the CLI, all you need to run is Netlify dev. And now what will happen is that it will spin up a development server and build our project the way that you typically would inside of Netlify. So whatever it takes for Netlify to spin up your actual website, it's doing the same thing. The other thing that happens is that we are now also running our Netlify function. So what happens with the CLI when it builds is it will go into your Netlify folder inside of your root folder, and it will find a functions folder and build all of those folders as well. So inside of our functions, of course, we have the one file, which is our create payment intent.js. And now this is set up. So what we can do is we can now test it. So inside of our payment form, what we were doing before was we needed a payment intent in order for this to work. So as we know, inside of our create payment intent, it is expecting an amount value. So this is where what we need to do is pass a amount value in as a request to our Netlify function. So as I mentioned, Netlify works with functions as if they are API endpoints. So in order for us to do this, what we're going to say is, okay, let's make the request in order to get this payment intent. So I'm going to say const response is equal to await fetch. Now here you're going to pass it the route relative to your application URL because Netlify will build all of our functions relative to the root. And the way it works is it goes /.netlify/functions, because for us, we're putting it inside of the functions folder, and then / the name of the file. So here it's create payment intent. This is going to be the route. Then we pass the fetch object that is going to define what we're trying to do. So the method here is a post method. So that's what we're saying. The headers is going to be a object where the content type is equal to application/JSON. So here we're saying, hey, I'm going to send you this body in JSON format. And the body is going to be JSON.stringify. And it's going to be an object where we pass amount. And let's just do 10,000 for now. We'll hook up our actual selector for the actual total, but we'll do that after. Let's just verify everything works. Once this fetch completes, we will say .then, I want the response, and I just want to convert this to JSON before I actually resolve it back to my actual response. I don't want to have to go through that extra step. So I'm just doing my .then here. Once I have this, then I'm just going to console.log the response. And what I want to do as well is I want to take the payment handler and attach it to the onSubmit of the form container. So essentially what we're saying is that whenever this form submits, and remember, any button inside of your form container will automatically be a submission button unless stated otherwise. So for us, that's exactly what we want. So we'll save this and let's go back to our application. And here, because we aren't actually using the card yet, we can just submit the form and we should make a payment intent for that value of 10,000. And here we see we log back our object with the response with the payment intent. This payment intent has a bunch of fields on it, but the main thing that we want is this client secret. This client secret is what attaches an actual payment to the payment intent that was generated from the backend. So remember how I mentioned our backend tells Stripe, hey, this user intends to pay. I'm telling you the value that he intends to pay. So give me back a handshake token, which is essentially this client secret, so that when I actually pass you the payment details with this secret, you know that this payment is connected to that intent to pay. So now that we have this set up, what we need to do is actually build out the rest of this flow. So I want to get off this client secret. So I'm going to say const client secret is equal to response.paymentintent.client secret underscore secret. Now we can do it like this, or we can destructure. You can do payment intent and then client secret like this as well. This will also give us the appropriate client secret value. We can console log the client secret like this, just to make sure that everything is working. Again, some teams enforce that everything is destructured so that you know where everything's coming from. It's a lot clearer. If we hit pay now, there we go. We see our client secret. And now with this client secret, what we're going to do is we are going to create the actual payment. So to do this, we're going to say const payment result is equal to us calling the Stripe instance dot confirm card payment. So confirm card payment is the card payment method, specifically for cards. And here you're going to pass it as the first argument, your client secret. And then the second argument is a configuration object where payment method, so payment underscore method, is going to go to an object. And on this object, we're going to pass the card. So in order to get the card element, we're going to say elements. So this again is the elements instance that we got from useElements dot get element. And what you're going to pass this is the card element. So the reason why this works is because inside of Stripe, you remember in our index.js, what we did is we created this elements wrapper. Inside of here, any element can only exist once. So there's actually a plethora of different elements that we can bring in. We just specifically chose the card element. I'll post a link with the list of the other elements, but here by saying get element and saying the exact specific element, because again, only one instance of it, what Stripe is going to do is actually get off all the appropriate details it needs in order to pass this payment value that gets inserted in as a result. So here we have the card, and then what we're going to say is billing details. Here we're going to say name. We can put whatever we want. We're going to use the current username. But again, we haven't hooked up the user or anything, so I'm just going to say Yihuazhang as a test. And then as for payment result, what we can do is we can now check. If we get back an error from Stripe, if payment result dot error, then we're just going to alert that error. So we'll say payment result dot error. Otherwise, we were successful. So we'll say if payment result dot payment intent dot status is equal to succeeded. So this, of course, is what we get back from Stripe. We'll say if this is successful, then we will alert payment successful. Either way, we'll get an alert depending on what happens. So now we're going to save this. We're going to go back to our application. We're going to refresh. And now that we are actually expecting to use the credit card, I'm going to go 4242, 4242. Now this is the test credit card. 0424. You can use any date as long as it's in the future. And then as for CVC and zip, they can be whatever you want. Key thing is that as long as this date is ahead of time, and then the credit card is 4242, 4242, this only works in test. It's Stripe's test Visa credit card. If we hit pay now, we see there was large secret. We're going to attempt to make a payment. And there we go. We see the payment is successful. And now if we go to our actual Stripe dashboard and we go to developers, what we'll see right there is a payment. So we got a successful call. Additionally, if we actually want to see what happened, you can check payments. Inside of payments here, we'll see that these were all of those incomplete payment intents that we generated. But the successful payment right here was because we successfully charged the card or the test card. So again, as I mentioned, when your backend Netlify function makes a payment intent, this shows up here saying that, oh, somebody is intending to pay, but then the customer did not enter the payment method, meaning they never actually completed the payment with the credit card. And here, this payment complete is actually because we succeeded. But this is it. We've successfully hooked into the full Stripe flow. We learned a lot of things. We definitely learned about Stripe significantly, and we learned a lot about Netlify functions. There was a lot of steps that we had to go through in order to set this up. But when you really think about it and boil it down, it's actually a very simple amount of code. Beyond working with Stripe to make this work and their very key nuances about how you use their Stripe objects, everything else is actually very simple. So that's it. In the next video, what we can do is clean this up a little bit, make it look a little prettier, but we've pretty much written the bulk of the logic that is required in order to make this work. Once we clean up all of our components, then what we can do is deploy this and see it live as well. I'll see you in the next video. Welcome back, everyone. So in this video, let's tidy up our payment form component to make it more user-friendly. We need to put in a real amount, and we also need to perhaps block the button or show some kind of pending state when this payment is going through. Because usually with card payments, it's probably one of the most tense moments for anyone from a user experience standpoint. E-commerce typically really has a high need for security as well as a positive user experience, just because, again, parting with money is one of the most painful things that a user can go through. So what we want to do is we want to import in the use state hook from React, because we're going to hold some state that will determine whether or not we're in a loading state for making a payment. We also need to bring in the use selector hook because we're going to need to pull off two values. One is the current user, the other is the actual amount. So in order to pull those off, of course, we need our selectors. So let's bring in our select cart total from our store and our cart selector. And similarly, let's also bring in our select current user from our store, our user, and our user selector. So now that we have our two selectors, what we want to do is we want to come down into our actual component so that we can actually pull off these values. So first I'm going to say const amount is equal to use selector select cart total. And then what I'm also going to get is the current user. Const current user is equal to use selector select current user. With these values now, what we're going to do is we are going to pass this amount value in instead of our hard-coded value. And we need to make sure that this is equal to amount multiplied by 100, because currently our values are stored as whole dollars. So by multiplying it by 100, we're converting it into the cents value, which is how Stripe expects all of its payment values. As for current user, now what we can say is that the name goes to, we can say if current user exists, then we'll use current user dot display name. Otherwise, we can put, let's say, guest. Typically what you would do here is inside of the checkout flow, you would have more forms, more fields. You would ask for their email, you would ask for their shipping address, etc. But again, we're just trying to get a lean actual card payment here. You can add more of them if you want. Again, the docs are pretty straightforward. I'm just going to use the basic card form just to show you the actual integration. If you want to expand on this feature, of course, feel free to do so. Here we have our completed actual intent now and the actual payment. But what we also want to do is we want to have some kind of loading state for the user. So this is where we might do something like const is processing payment. And we'll say set is processing payment. This will be use state of a Boolean value, and by default it's false. And what we'll do is we can actually disable our button if this is in some type of state like this. So here what I'm going to do is I am going to say that this button is disabled if is processing payment is true. So in order for this to be true, what we need to do is set it to true when this payment is happening. So here inside, the moment that we pass this point and we're about to start a fetch, here we're going to set is processing payment to true. And the point when we know that we have it back and we're done processing is when we hit this portion. We're either going to have an error or we're going to succeed, but it's all synchronous. So here we can set is processing to false. And now if we come back to the application inside of our React application, and I insert in a test card, and I hit pay now, there you should now see that this button is disabled. Meaning that if I keep clicking it, nothing will happen. Notice how we just get the one alert. But however, the thing is that this is not that, from a UI standpoint, clear to us that this button is disabled. So we can even go a step further and improve upon our button component. What I want to do is come in here, and I am actually going to create a spinner state for this. So first off, what I also want to do is I want to expand upon the functionality. I'm actually going to put a is loading prop that we can conditionally pass in. If this gets passed in, then what we'll do is on the button itself, we'll say disabled is loading. So now we don't have to code it. However, if there is another condition that would disable this, meaning that if we wanted to pass in disabled for something else, our other prop spread will overwrite this disabled value. So now this gives us both functionalities. What we also want to do is we want to be able to show a loading spinner instead of the actual text inside this button. What I'm going to do is I am going to go into button styles, and I'm going to make another spinner. So for this spinner, what I want you to do is you can pretty much just take the spinner that we already have inside of styles and copy this over. If you wanted to import this from the spinner styles, you can do that as well. So in order to do that, you would just have to copy it over, but I want to tweak the width and the height. So this is why I want to copy this over. But actually, let me show you. We can do this inside of button. We can modify it. We can import in the spinner container from and we're going to go up to our spinner component, and we're going to target specifically spinner styles. And here with the spinner container, what we're going to say is export const button spinner is a styled version of spinner container. So remember, you can pass it any style component, overwrite any of the styling. The reason why is because I want the width to be smaller. I'm going to do width 30 pixels, height 30 pixels. So I'm just reducing the actual size. Everything else, I'm going to keep the exact same. The other thing I'm going to want to do is up here inside of the actual base button, I'm also going to make sure that I vertically align this component. So I'm going to say align items center. And now we just need to copy the button spinner over. And then what we can say is that inside of here, if is loading is true, then show the button spinner. Otherwise, show the children. So if no value gets passed for is loading, of course, is loading is going to be undefined, which is falsy, which will default show the children. So here, this is our new and improved button component. In order for us to use this, it's already here. If anything, I might just want to make sure that this is showing the inverted button type, which it already is. So let's save this and let's go check. Let's just refresh for good measure. And now the total is 540. Here for the card number, I'm going to do 42424242. Oh, looks like I mistyped one of these values. 42424242. 4242. There we go. Okay, as long as this is correct and the date is forward, everything else doesn't matter. I hit pay now. And there I see payment successful. We didn't see the loader. Of course, it's because I did not modify this from disable to is loading like this. Let's resave. Let's go back. Let's refresh. Inside again of our card number 4242 4242 4242 4242 42424. Pay now. There, we see our loader. This tells us that we're prompted. Payment successful. And there we go. Any other tweaks we can make? We could, of course, improve upon this button as well. We can give it a little bit more spacing. So what we could do is import in the button from our button/button component. And then we can call this our payment button, which is equal to styled button. Whoop, here we go. And let's say, for example, we wanted something like maybe a margin, or yeah, let's do a margin. Let's margin left auto so that we push it all the way to the right. And then let's do a margin top of 30 pixels. Now, of course, everything on this button is going to behave like a custom button that we've made. So instead of importing in button, we can just import in from our own payment form styles, the payment button, and we can just replace the button with our payment button. And now, there we go. It looks a little better. We hit pay now, the spinner occurs, and then the payment's successful. What you can also do is you can fire an action to clear the cart from this point. Again, whatever you think you want to do to make this experience more fluid from a user experience standpoint, you now have every single skill. You have use of sagas, you know how to use your selectors, you know how to use your actions, you know how to use these components. I have now taught you every single thing you need in order to improve this experience however you want. So really, this is my challenge to you now. You can make an order confirmation page. You can do whatever you want, because after this step, we actually see inside of Stripe, if we refresh, we should see multiple payments now, all for that 540 amount that we have made recently. Here, there we see it. Every time we fired it off, we were successful. We had our guest because currently, of course, we are not logged in. But if we're signed in, they see our username instead. So let's try this with our actual account. 1234, 1234. We'll sign in. We'll go to our checkout. I don't want to save that. I'm going to do this card. Pay now. Payment successful. And now if I refresh, we see my display name. We fully integrated with Stripe. There you go. This is now a fully fledged out, honestly, pretty decently working e-commerce website. There's additional security checks you can add, of course, for Stripe. But again, it's just about sifting through the documentation, adding some additional configuration patterns. Most of that, though, is not the core base of what we need. From a functionality goes, you have a fully fleshed out e-commerce website. A lot of these patterns will scale. Really, at this point, it's just about expanding upon your inventory, adding more features, changing the UI so that maybe it's a little prettier. But this is the very last feature as far as adding additional functionality to this website goes. So now in the next video, let's push this up and make sure that our Netlify also builds out the functions. And to do that, we'll have to tweak our Netlify settings a little bit. So join me in the next video where we will deploy this. I'll see you in the next video. Welcome back, everyone. Some of you may have noticed that inside of your deployed application, you cannot use the Google sign-in. The reason for this is because we have not added our new domain as part of the authorized list to use that authentication service. So here, just copy the actual URL for your website that you've been given for Netlify. Go into your authentication tab in Firebase, go to your sign-in method, and hit edit for Google. And then down here, inside of authorized domains, click add domain, paste in that URL, and now this should work. So now that it's added in, let's go back. And what we can do is open up our application, go to the sign in, hit sign in with Google. And there we go. We can now properly authenticate into our application with Google sign in. So that's just one quick thing to note. Remember, again, if you ever change the domain or actually want more of your subdomains or whatever, if you choose to end up renaming this website and getting a new actual URL for this, you're going to want to add that domain here as well. This is just those things that you have to do for these authentication services. So remember that key step. And with that, let's continue with the course. Welcome back, everyone. Here inside of our Netlify dashboard, what we want to do is access your site, and on your site, go to your site settings. In our actual local development, we're using .env in order to have environment variables so that our local server can access them. Unfortunately, Netlify does not have access to .env because it's reading from the actual repository in GitHub. And as we remember, we have ignored .env from being posted to the repository because, of course, this is not a key we want to reveal to anybody else. Luckily for us, though, we can set these environment variables the same way that we've used them in .env here inside of our site settings. So inside your site settings, go to Build and Deploy. And inside of Build and Deploy, scroll down until you see Environment Variables. Here, when you hit Edit Variable, what you're going to do is actually add them by the variable name and then the value. So as you can see, I've entered them in before, but for you, you're going to do the same thing for both that React app Stripe publishable key, but also the Stripe secret key. You can literally just copy your .m file variables over into here. So for the key, you're going to put your React app Stripe publishable key. As for the value, what you want to do is you want to copy the value without the quotations. Now, of course, I'm not going to show you my environment variables, but that's what I'm saying. You don't have to post it as a string. You can just post the characters of the actual key inside here as the value. So do that for both the React app Stripe publishable key and also the Stripe secret key. And they want to be the exact same key values that you have. Again, the value not being in the quotes. So do that, come back. I'm going to assume you've done that. And then let's actually deploy our website. So now that we've done that, you should have React app Stripe publishable key as well as Stripe secret key added into your environment variables and saved. Now what we're going to do, if you have yet to actually commit this code, if you commit it now, everything should build properly. But what I'm going to show you is if you want to manually trigger a deployment. So here we can go to deploys, and what we can do is just click trigger deploy. And now what will happen is we will manually actually deploy a new build with the latest code. The reason I'm doing this is because I've already pushed my code up, so the CLI has actually already built the website, but I'm just gonna show you manually what this is gonna look like. Again, if you haven't committed and you have our new function code in, just deploy that, meaning that you should just push that code up to GitHub, let our connection and our CLI build the website. And here, now while you're waiting, let's just quickly wait a second because we can actually see our functions build inside of these logs. So I'm just going to fast forward through this section. So here you can see step 2 is functions bundling. So this is actually adding our functions. And as you can clearly see, this is our create payment intent function. It was built successfully, and now the site should properly build. Script is successful. If we scroll up, we see that we have published. So if we preview the deployment now, here we can see that I've actually already got a live session. And what I'm going to do is just show you with exactly the flows that we should expect to see. So I'm going to sign in with my Google account. And then what I'm going to do, if you haven't already added items to your cart, add some value, go to the checkout, scroll down here to the card payment, and just add in the test credit card. If you hit pay now, what you'll see is that we should see a successful payment. If we come into our Stripe dashboard, we see that I have successfully made a payment with Yihua. So that's it. We are live and deployed with our Netlify functions. All of our functionality is now in production. All that's left now is to learn a couple more optimizations that we can make with our React application. But as far as our Capstone project goes, we are at feature completion. Congratulations, you've made it through. You have learned about all of the different tools that come to help us build features inside of React. From this point forward, what I'm going to teach you is mainly just additional optimizations and primarily a lot of the tools that kind of make your process a little bit more efficient, such as performance and such as Typescript, etc. So I want you to take a second, take a breather, pat yourself on the back, appreciate what you've built. Before you learn something new, maybe go back and add some more features to the application if you want. Make it look a little bit more unique to your style. Again, I have built this website, and since the filming of this course, there's actually been a lot of students who have built this website as well. So if you want to tweak some of the designs and make it look a little bit more like your own, please feel free to do so. You have earned that, and it's a great way to practice the skills that you've picked up so far. I'm very proud of you. And when you're ready, come join me in the next video where we'll start a new topic. I'll see you in the next video. Welcome back, everyone. In this video, we are going to talk about TypeScript. From this point forward, we are going to try and migrate all of our existing React applications to TypeScript in order to understand the advantages that TypeScript brings and also understand why TypeScript is slowly becoming even more popular than JavaScript when it comes to actually coding out your applications. So TypeScript is actually a language that extends from JavaScript that is maintained by Microsoft. The thing about TypeScript is that it emulates a typically statically typed language, which JavaScript is not. We'll discuss statically typed languages versus non, like JavaScript, in a little bit. The main thing I want you to understand about TypeScript is that when it comes to writing TypeScript, if you can write TypeScript, you can definitely write JavaScript. But if you can write JavaScript, it does not mean you can write TypeScript. So I want you to see TypeScript as almost an enhanced version of JavaScript. It still has all the core logic of JavaScript, but there is now this extra layer on top when it comes to type safety. Now, we talk a lot about types, but what are types to begin with? So to begin, we have discussed certain types before, such as primitive types in JavaScript. So if you think about primitive types, you know there are integers, which is essentially any number value. You know there are strings. You know there are objects. There are functions, which are essentially extensions of objects. They're a special type of object. We also have arrays. We also have booleans, like true, false. And we also have null, which is its own type. Undefined, which is its own type, as well as symbols, but you don't really need to use symbols. The main thing that you want to know about these different types is that every single thing that you cast in JavaScript to some variable or anything that holds value is some kind of type. When you think about it, typically we are constantly passing types around. Different types also have different methods on it. If you think about strings, if we have some string value called myString, using this string that holds my name, I can perform a bunch of different transformations on it, such as to local uppercase. This will uppercase all the string. The thing though is that you cannot call this to local uppercase on some array. So let's say I had my array value like this. If I try to call my array dot to local uppercase, here you're going to see my local uppercase is not a function. So this, though, as you can see, is a type error. When you think about a type error, it implies that you are trying to call something on a type that does not have that method or function. It's essentially saying you have the wrong type here, which is exactly the case. To local uppercase is a string method. Here we're trying to call a string method on an array. It's the wrong type to use that method. So in JavaScript, when you really think about all of these methods that we call constantly, .map on arrays, .filter, .reduce, these are all array methods. When you think about object, calling object.assign, these are also all specific methods to specific types. So when it comes to using these types, when you think about writing some of your code, let's say you had some function called myFunction. And what it did is it takes some message. And then with this message, what we return is message.toLowerCase. If we passed into myFunc a string value like this, we get it back as lowercase. However, when we use myFunc, when you think about it, if you're exporting this out of your file and you're trying to call this somewhere else, it's very easy to forget that myFunc takes a message. In fact, it's also easy to forget when looking at the method what exactly this thing it's expecting to receive is going to be. We happen to know that toLowerCase is only a string method, but what if it was calling some other method that we were unaware of? In general, it's very challenging for us to be fully aware when looking at all of our functions on all of our code, what the types of the things that they hold are. TypeScript actually aims to resolve that. Essentially, with TypeScript, every single variable, every single thing you pass, every function, everything you write, statically says, these are the only types I'm willing to accept. These are the only types I'm going to give you back. Everything is typed, meaning all of the types are defined. We lose out on the flexibility of JavaScript because, of course, with JavaScript, with myFunc, nothing stops me from passing in an object. But again, we're going to get a type error because once I pass an object, it's going to try and call a method that doesn't exist. But JavaScript does not stop you from calling myFunc with a type that it's not expecting. Now, this is where it comes to being static typed versus not statically typed. JavaScript is not statically typed. What that means is that at what point is it actually going to check that this type is not what it's expecting it to be in order to call toLowerCase on it? Well, it actually does it at runtime. When it actually tries to execute myFunc, when it got called here with message being an object, and then when toLowerCase attempted to be run, that's when it realized, oh, this method doesn't exist. This is the wrong type. With a statically typed language, you can't even pass this an object. When you define your code and you write your code out, if you were to even try and write this code without running it, TypeScript will throw you a type error and it will say, hey, you have to give me a string. I'm expecting a string. You're giving me an object. This is not going to work. This is at a very low level the main advantage of TypeScript. But in order for this to extend itself and for us to see a lot of the advantages that it brings, we need to start working with it first in order to really explore all of the benefits. So that's what we're going to do. In this lesson, we are going to integrate with TypeScript. We're going to convert over first our Monsters-Rolodex project into TypeScript so that we can learn about some of the benefits that TypeScript brings. There is a lot of complexity that comes with TypeScript, but once you get familiar with it, it's just really a matter of practice And another important thing to know is that with a lot of TypeScript, while there are definitely some best practices, a lot of it is considered an art, not necessarily a science. There's a balance here that we're trying to strike in being typed enough that we get the security that comes from TypeScript, but not so much that we are so hindered from writing code quickly and efficiently. This is really the dance of writing TypeScript and why for a long time there was a slower adoption. But the benefits that it brings in the long run and that statically typed confidence you have in your code is actually a net benefit to speed and quality of code and even the actual efficiency of how much code you can pump out in the long run. There's a lot of advantages to writing TypeScript. It's just we have to get through that beginning valley that makes it challenging. So there's a lot in these lessons about TypeScript. So once you're ready, let's dive right into it in the next video. Welcome back, everyone. So here we are inside of the Create React App documents, and we're looking at specifically their adding TypeScript section. The reason why we want to read this section is because Create React App under the hood has actually already configured their Webpack and also some additional configurations when they set up the project for us with Create React App so that it can actually support TypeScript pretty easily. You can actually spin up your instance of Create React App application with TypeScript by default by using a -- template TypeScript. For us, though, we initialized our application without TypeScript because we wanted to be able to write our code without thinking about TypeScript first. We had to learn React, but now we're ready to learn TypeScript and specifically TypeScript in React. So if you scroll down here, you'll actually find a section where it's adding TypeScript to an existing React project. So what we're going to do is we are going to copy this entire thing. So the reason we want this is because there are a bunch of different libraries that we need to install in order for TypeScript to run. So here, what we're going to do is we're going to go back into our terminal. And inside your Monsters-Rolodex project, I want you to add inside that line that we just copied over, and we're going to install a bunch of these libraries. The other thing that we need to set up is actually a tsconfig file. So TypeScript, as I mentioned, is not necessarily JavaScript. It's like another language, even though it's remarkably similar to JavaScript. So essentially what happens is we need to tell our TypeScript configuration what we want to support. Essentially, this is kind of like us telling TypeScript we want to support React with its types. We also want to tell it that there's a certain version of JavaScript that we want to support. Like, for example, up to certain versions of TypeScript, they don't actually support generators the way that we need it to in order for us to properly type our sagas. So essentially, the tsconfig allows us to configure our TypeScript so that it runs in the version we need it to. Now, normally when you build out your project in TypeScript using the Create React App TypeScript template, it will build out this tsconfig file for you. But because we started without it, we're not going to get that. So what we're going to do is we are going to add in our own tsconfig.json file. And inside what I want you to do is I want you to paste what I'm going to give you. Now, this is essentially the exact file that's going to get generated for you when you build your project in TypeScript. So when you run Create React App with the template and the generate tsconfig file, we're really just pasting that one over. So that's what I want you to do. I want you to go into your resource folder, find the tsconfig file, copy it, and paste it in. It's literally just the exact same file because it comes with what we need it to have. So once we have in our tsconfig file, we can start migrating our code over to TypeScript. And to do that, what we need to do is actually change these files from JSX and .js over to .ts or .tsx. The .ts essentially stands for TypeScript. And the way that we're going to start migrating is we're going to start thinking about it in isolation. So the easiest way for me to teach you TypeScript is to begin by typing some of the more basic parts of the application. And then as we grow, we'll discuss more, think about more types, think about more of a strategy of migrating an application over to TypeScript. Honestly, there's a lot to discuss, but we have a great way forward. So the best place to begin is for us to just start with our search box. The search box component is a simple component. Now, in order for us to start typing this file, we need to convert it from a JS file over to a TS file. If it's JSX, then it's TSX. If it's JS, then it's TS. So TSX is a JX file, except instead it's in TypeScript. If you look down here, it says TypeScript React, which is what we want it to be. The moment you switch it over, you'll notice that the VS Code compiler is going to throw some errors because this is invalid TypeScript. If you hover over it, you see binding element class name implicitly has an any type. Now, any is a special keyword. Inside of TypeScript, any means that it can be anything at all. Any possible type can be passed as an argument. Now, if any type can be passed, then automatically this defeats the purpose of using TypeScript because we want to implicitly or explicitly know what types are being passed through or cast as these variables. So this is a very important thing to remember. You never want to use any. In fact, it's probably the number one golden rule in TypeScript. Never use the any keyword. In fact, if any type is any, you want to figure out there's probably some kind of strategy to tie this to some type of type. There are even cases where you have no idea what you're getting, but there's actually another type you can assign to that is more type safe than any. But the key thing, almost 99.9% of the time, you will never use any. Now, before we start typing these parameters, let's talk about typing in general and how that works. I'm going to create a variable called name. If I wanted to type this name and say that this is always going to hold a string value, the way that we type this is we use a colon. Following the colon, we then define the type. So here I'm going to say it's going to be a string. Now, you want to use these lowercase primitive types. Typically inside of JavaScript, you're probably used to seeing capitalized string. You want to use the lowercase value because this is a specific type we get from TypeScript representing the actual primitive. You have the string, you have booleans, you have numbers, and you have the arrays, the objects, as well as the functions, but those are more specific and we'll discuss those after. We're just going to start with basic types for now. With string, if you set it to string, you'll notice now that when you hover over this variable, in that first line, it says const name is string. So right now, TypeScript's compiler knows, oh, this value has been cast to a string, even though we haven't assigned the value yet. Now what we can do is if we assign it a value of string, then what we notice is simply that it's declared, but it's never used. So this is a warning, but it's not an error. What happens though, if you were to assign this a value that is not matching of the type, like a number? If you hover over it now, in that third line, you'll see type number is not assignable to type string. So JavaScript's compiler now knows, oh, this value you're trying to assign to me is a number, but this doesn't match the type that has been explicitly stated to this value of name. And now it will throw an error. Now, as we advance, this will get more complex, especially when we need to actually define the types for objects and for arrays, which is what we'll discuss in the next video. For now, all we need to know is that once we've installed TypeScript and you want to convert a file over to TypeScript, convert the file extension to ts or .tsx. And then for the actual values, if you want to assign them to some kind of type, you must use the colon. And we've learned a little bit also about how the TypeScript compiler inside of VS Code helps us realize that we're throwing type errors. So with that, let's move on to the next video. Welcome back, everyone. In the last video, we learned about how to type values. In this video, we are going to start typing out this actual component where we're receiving these props. So one thing I want to talk about is typing objects as well as typing functions. Let's start with typing functions. When we think about this functional component, this is really, as we know, a function that has a specific return of some kind of HTML element. Other than that, nothing prevents it from being just a normal function. When you want to type a function, the way that you have to type the signature, so here, let's say we were typing some kind of function. We don't actually know what this function returns yet. This is just a placeholder for now. But as we know with typing, we use the colon, and then here we need to define the actual function itself. So if you think about the conditions of a function, important things of the function are the parameters that it receives and then the return value of the function. A function only cares about the types internally to itself when it receives properties. It has to receive the actual types that it's expecting to receive. So you want to type the parameters coming in. As far as TypeScript is concerned, whatever happens in the function is not TypeScript's business. But what comes out of that function as a return value, that is TypeScript's business, because TypeScript needs to ensure that whatever you're returning from the function matches the type that you tell is going to return. So the actual syntax of typing is going to be a curly bracket representing the parameters, and then a fat arrow followed by the actual return type. Now let's say we have a function, and this function gets 3 values, A, B, and C. Similarly, what you're going to type is going to also be A, B, and C. But here what you're going to do is you are going to define the types themselves for these parameter values. So first we actually need to match each variable in the parameter, A, B, and C. What you're then going to do is for these parameters, you're also going to use a colon. And this colon is going to say what these values are expected to be. So here, let's say for A, it's a string. Let's say for B, it's a number. And let's say for C, it's a Boolean value. What you need to return from this is now dependent on what the actual return of the function is. Let's say, for example, after all of these different calculations, what we return back is also a Boolean. Let's say it's true, for example. What you need to do here is that you need to return a Boolean. So you can just state that the value you can expect to come back from this function is going to be a Boolean. But we also have functions that don't have returns. Sometimes we just run a function and it doesn't actually return anything. If that's the case, then what we want to say is that we return back void. And with void, void is a special type that essentially says, hey, this is going to be nothing. It's very much like undefined in JavaScript. You just expect no return back, no specific type. And now with this, that's how you type a function. There are more complexities of typing functions that we will uncover as we go along, but this is pretty much the basics as far as we are concerned. So now the reason why we need to learn how to type a function is because we have these 3 types where the third one is a function because it's a handler. But what you'll also notice is that this is actually a destructure statement inside of our function. So what we're destructuring off is actually one variable called props. And props, as we know, is an object. So how do we type objects? Inside of TypeScript, you have 2 options for typing objects, and they're very unique. You actually have to define them ahead of time as either a type or as an interface. Now, types and interfaces are very similar. They used to be more different when TypeScript first came out, but over time, their overlap is significantly greater now. The key golden rule to remember about types versus interfaces is that interfaces are extendable, very similar to class components. If you remember with class components, you can extend one class component from another and inherit all of that class component's original methods. Similarly, with interfaces, you can actually do the same thing. So let's say we were to define an interface. First, you use the keyword interface, and then you have to write the name of this interface that you want to call it. So for us, if it was search box properties, then we would say I, because all interfaces start with an I to designate that they are a interface. I search box props. This is some kind of object. Then you put the curly braces, defining to this TypeScript file that this is now an interface. The inside is going to represent the shape of the actual object you're trying to define. So here, because we're looking at class name, placeholder, and onChange handler, we would say class name. Now, class name needs to point not to a value, but the actual type, which we know is a string. So that is going to be how you type these key value pairs inside of TypeScript with an interface. Similarly, we could say placeholder, which is also a string. Now, if this placeholder is an optional property, you can put a question mark here. This will now tell TypeScript that what you can get here is either string or null. It's essentially the equivalent. Because with an optional placeholder value, we're essentially declaring to TypeScript, hey, you can expect a string, but I might not always give it to you. Now, as for the actual onChange handler, the reason why I started this conversation about types and interfaces is because I was talking about how interfaces are extensible. So what I mean by this, okay, here we have our props. We've typed 2 of them. We haven't typed the onChange handler. We have this interface that defines the object shape and the corresponding values that we're expecting. If we do : and then iSearch box props here, so we're saying that the props that you're going to receive is of this type of iSearch box props, you'll notice that we see onChange handler does not exist on our type. What we could do, of course, is simply just add it as the third parameter here inside of this interface. But when I say that you can extend, essentially you can do this actually a couple of ways. Let's say, for example, we had some random additional interface. Let's call it change handler. So I change handler props. And this takes some onChange handler as a prop. And what it receives is some actual function definition. So let's say it's A, which is a string, and then it returns back void. Let's use that as the example. What you can do is you can actually say interface iSearch box props extends iChange handler. And now what you'll see happens is that this iSearch box props is now passing. Because what happens is that our iSearch box props is extending whatever was inside of here. So this is actually getting added into this iSearch box props as well. So we're inheriting whatever additional props were on this iChange handler props as far as typing is concerned. Another thing that you can do with interfaces is you can actually overload them. So if we write this twice, TypeScript under the hood is going to also combine these together so that your iSearch box props now contains all 3 of these values. This is designed pretty much mostly for object-oriented programming style inside of JavaScript. So most likely you're writing Node or you're writing some Angular code, which is also more object-oriented. But the main idea with TypeScript here is that it's giving you this ability to write interfaces that are extensible as well as composable through this overloading, which is where you're saying, hey, I'm going to define this more than one time. I just want you to combine all of them together into one final shape. This is interfaces. The alternative is to write types. Types are very similar to interfaces, but we lack both of these functionalities. We do not have the ability to overload, and we do not have the ability to extend. So we'll talk about types in the next video. Welcome back, everyone. So we were talking about our interfaces versus types. So types are a different style of coding out our objects and typing them. The way that type works is very similar to interface, except you don't need the I. So we can say interface of iSearch box props can be converted to type search box props like this, except we need to use an equal sign. And then inside, we need to define an object that represents the shape of this props object. Similarly, we'll do the same thing. Class name is string, nothing different here. Placeholder, also the same. If optional, can pass the question mark, also a string. And then for the actual function, once again, we can also put a function. And now we can just put this search box props as the type. Now you might be wondering, what is the main difference between using a type versus using an interface, other than the fact that interfaces offer us the ability to extend and offer us the ability to overload, like so. Types allow us to do something known as a union. Now, a union is essentially a combination of types. So let's write one out so I can give you an example. Let's say we had some variable that was an address, and the address could be equal to two different styles of objects, maybe one for US addresses, maybe one for Canadian addresses. So the difference would be that here you would have, of course, your street, which is a string, and you would also have your state on the US, which is a string. But if you are in Canada, this instead would be a province, which is also a string. So in this particular case, we know that the state and the province are optional, but they can exist as either one. How this would work is that we could say that there is a type Canadian address, which is equal to this that needs, of course, your street, which is a string. But also, you could have a province, which is a string. And similarly, we have a type US address. And here, street is a string, but state is also a string. Actually, this should be province like so. In order to make a union, we could say type North American address is equal to Canadian address, and then this one bar US address. We've created now a union type, meaning that address, if being passed our union, can now represent both a street with some value, or it can have a state with some value, as well as a province. Both are equally valid. You'll notice that this is perfectly fine. Province works, state also works. It's not throwing for us any additional errors. Now, nothing is stopping us from adding any additional union types on top of this. We can add something like an Italian address. And this also has a street, which is a string, but it also can have a region, which is also a string. This region, of course, could be something like Tuscany or Amalfi. But now, if you add this, once again, this still works. If we didn't have Italian address, then of course you see that we have an error because this cannot have region inside of our North American address. So of course, it's no longer North American. We can probably just put Western, or we can just put address if we think it's going to extend. But this is the thing about types. You're allowed to do unions on them. There's also a couple other advantages, which we'll discuss once we use more of types. But this is really a preferential choice. A lot of projects like to use interfaces. A lot of projects like to use types. Typically, the golden rule is that if you are writing more of a functional style of code, functional programming style, then you use types. If you do more of an object-oriented style, then you use interfaces. Personally, I like functional programming a lot, so I am going to continue using types for the remainder of this course, but you can feel free to use interfaces. It's pretty common in its overlap, so there's not that much difference. So what we need to keep then is pretty much just our search box props type. So here, one thing you'll notice is that our function definition, while we just type something, this is not correct. We actually are not even receiving the correct value here. The reason why this is not the same. is because you'll notice that here inside of onChange, instead of directly just passing onChange handler like so, I've written it another way, where we're explicitly getting the actual event inside of a callback, which we then pass to our onChange handler. Now, the reason I did it like this is because I want to know what this event is that we're getting from React. And this is very important because React actually has a lot of types by default inside of all of these components that they've given us. The reason why React has typed all of these HTML but Reactified JSX components is so that we can actually use TypeScript with them. In this particular case, if you switch back to this version, you'll notice that onChange gives you an error. It says that our type of this function, so you see type a string, fat arrow void, is not assignable to type change event handler HTML input element. Change event handler is actually a functional type definition that we get from React. So here we can import this in from React. And it's called, if we highlight over it again, change event handler. Now, change event handler is essentially a function type that we receive from React. We can put this here. And what we also need to pass it, if you remember, when we had our definition like this, where we received some kind of event. Notice that this event is of React change event HTML input element. Here, we want to pass that HTML input element into this change event handler. Because if you hover over this, reading this definition, alias, type, change event handler, notice that there are angular brackets. This angular bracket is essentially representing that you can pass to this type a parameter. The same way that you pass a parameter to a function, certain types by definition, you can actually also pass it a parameter. This parameter, though, is a type. You have to pass it a type so that it can use that type inside of its own type definition. For example, what you're seeing here with change event handler is that it receives some parameter value of t. This t has to be some kind of element type. Now, element here is a union. It's a numerous bunch of different HTML element types, of which HTML input element is one of them. So what happens is you pass it this parameter t, and then it uses it to define what the change event type is going to be. So notice that we say equals and then round brackets event, change event of type t. So we're saying, hey, give me some type t, and this is going to be what I use to define the type that I have later on. If that seems confusing, don't worry. We're going to work with these types of type parameters. These are known as generics, and we're definitely going to explore those. For now, though, all you need to know is that we are going to pass to it a type parameter of HTML input element. And now this change event handler is correct. So we don't even need this anymore. And here we go. We see that everything here works. The reason why you can pass this different input elements types is because there are actually onChange methods across many different HTML components. Input is just one of them. We have it for text boxes, we have it for dropdowns, we have it for radios. There are numerous different components that register an onChange. As a result, depending on which input element is triggering this onChange, they might have different values on the event. So React is saying, hey, tell me what type of onChange this is going to be. So I know that this function is ready to receive the correct event type. Again, React is typed by default. The fact that it's typed means that all of these components have these type definitions and what they expect on their methods themselves. So as a result now, this extends for us a way to leverage these existing types that React has made in order to define the functions that we'll pass to it. Many libraries by default now have TypeScript in them because, again, TypeScript is so popular. And by doing this, we need to always import some of these types so that we can make sure to the library that we're giving it what it wants. So this is probably the part where it gets a little challenging to learn TypeScript because you do need to constantly reference the documentation in each of these libraries to know what the types you receive will be. But over time, you'll pick up some of the patterns, such as what I just showed you, where you can just look at the actual things that are being passed to you. This is one of the beautiful things about using VS Code for TypeScript, because VS Code and TypeScript are both made by Microsoft. So by default, TypeScript is embedded as the engine that runs VS Code. So the compiler is extremely accurate and helpful. But this is it. We have typed out the search box component. We've learned quite a few things actually about types, interfaces, strings, and functions, as well as third-party library types that we can inherit. And we've started to learn about these type parameters that we pass known as generics. So I know this is very, very overwhelming, but I guarantee you once you learn more about TypeScript, you'll actually learn way more about JavaScript and you'll get really intentional understanding how JavaScript works. So now that we have finished typing our search box, let's continue typing the rest of our project. I'll see you in the next video. Welcome back, everyone. In the last video, we learned about the change event handler and the receiving of HTML input elements as an argument for what this function defines. Now, this function by default returns void, which is what change event handler assumes you're going to do. You don't need to return anything because it's not expecting you to receive anything. But if for some reason you wanted on your change handler to actually register some type of return, for whatever reason, another way that you can actually define this function is you can bring in the change event. Change event is the event definition instead of the actual function definition. And what this means is that you can define your own function definition. So you can say, I'm going to give you some function where I expect to receive the event of change event, where the change event is registered to HTML input element. If you remember earlier, when we looked at the actual change event handler, when we hovered over the parameter, we noticed that we were receiving the change event as well, where we were passing the actual type. So before we do that and take a look at that, I'm just also going to now explicitly return void, because that's what this function does. If you want to return something else though, again, you could put something here like your Boolean or your string or whatever this change event you happen to return for whatever reason. This is just another way that you can define this. But going back to this change event, I also want to bring in this change event handler. And I just want to show this side by side so we really understand what's happening here. So when I hover over change event handler, again, we receive some generic t, which is equal to an element, and then that gets passed to change event. So essentially, this is change event. Change event here is expecting some value t in order for us to tell it what type of HTML element this change event is for. So really, this function that we see right here is really just us typing it out like so, more manually. That's really just something I wanted to highlight to you. If you wanted to define your own function, normally, if you look at this actual definition and you see that there's a change event that is being defined in the actual function type definition, you can use that very easily as well and write your own function definition so you get more granular control, such as if you wanted to pass back or return some specific type, or if you wanted to even add additional parameters for some reason. Again, this main idea is that oftentimes when it comes to typing with third-party libraries, you really just got to read the types. It gives you a better idea of what the functions do, but it also gives you more granular control with your typing as well. And this becomes especially important as we start interacting with more and more third-party libraries. So that's it. I just wanted to highlight to you that there are numerous ways that you can type out these third-party interactive parameters that you're passing. So here, let's just use the change event so that we can be more explicit in what we see. So with that, let's type the rest of our project. Welcome back, everyone. So now that we've typed out our search box, let's type out our app.js. Our app.js contains the bulk of our logic and code, so this is probably going to require a lot of typing because we have so many things defined. The first step is always to rename this from JS to TS. Whatever it is before, name it to the new one. Now here, one thing I want to mention is that this is indeed JSX. So we can even update this to TSX to be more explicit. The reason it works even with .js is because under the hood, Create React App has set up Babel so that even if it's JS, it will attempt to use JSX if it needs to, if it realizes that you're trying to return JSX elements. That's just one of the advantages of using Create React App, so that our code gets registered even if we're not using the correct file function type. So inside, one thing I want you to notice right out the gate. We do see that there are a bunch of highlights about where our errors are. There's going to be a process, oftentimes when migrating an application, where the moment you switch your files over to TypeScript, you will see a bunch of errors. This is actually a good thing because through these errors, you're able to now figure out what you need to type in order for your code to work. So first things first, there's a couple things we need to think about. Chances are, the most critical part of our application that needs to be typed is going to be the data that we receive. The data that we receive is from this fetch. But the thing about this fetch is that we don't actually know what it is that we're getting back from this fetch. We know the shape of the object if we literally go to this URL and we check it out. So if we come here and paste it in, we do see that this will be the shape. But the problem is that we are not getting this from the actual API that we're calling. There's no third-party library that's giving us this type. If we were to type this ourselves, now we're creating a connection between our application and this website. They might update these values. We would have no idea. And if our application is in production, we're suddenly going to break. So what we want to do is figure out a way to defend ourselves from these changes as best as we can. What you want to do here is you do want to type this up somehow. Instead of just assuming we're going to get anything, we are doing some type of, say, transformation in order for us to actually be able to ensure that we have the correct values, at least if they're there. For us, for example, we mainly know that we're only using name. And if I remember correctly, we're just using email and the ID. Those are the only three variables that we need from this object that we're getting back. In order for us to type this fetch, the easiest way is to actually create a utility function. So as we know, we want to make a utils folder following our best practices. And inside of here, we can create a new file and we can call it fetch.utils.js or data because we're getting data. And here, actually, let's make this a TS file because we know we want to use TypeScript from now on. Here, what we're going to say is that I want to create some kind of generic getter function. So this is some getData function. What it does is that it is a async function. So I'm going to define just the function first before we actually start typing this. And what it will do is it's going to get some response back. This response is going to come from us calling fetch on some URL value. So we can say path or we can say URL. What we do then is we return this response, but we convert it to JSON because when we get it back, it's not going to be in the JSON format and we want to have it in the JSON format. This means that this function that we export out of here is going to receive some type of string as the URL. So if we were to type this, but what does this function actually return? This is where we need to explicitly tell what we're returning back. So earlier we saw what a function definition looks like if we were to define the function type. But here, what you can do as well, when you write out a function like this, you don't actually need to put the fat arrow. You can just say, okay, in the parameters, I'm going to directly define the types. And then in order for me to tell what gets returned back from this function, what type is getting returned, you can put colon here. And then here, you just put the return type. What we're returning back is going to be an await. If you return an await, you're actually returning back a promise. And a promise just like we saw before with our change event, receives a parameter because it needs to know what's the type that you're going to give me that I'm going to return as the actual resolved value from this promise. This is where you can use a generic because it can be anything. We don't know what we're getting back. This response value does not have a type. We don't know at this point. But what we do know is that probably when we call getData, we ourselves are probably going to know what URL we're passing to it. So in turn, we probably have an idea as the coder what the actual type that this URL is getting back is going to be. Because this is a generic function. It can call fetch on Google API. It can call fetch on the actual JSON placeholder. It can call it on an Amazon link. We don't know what we're calling fetch from inside of the function. The function itself has no idea. So as a result, we need to define to it what this will be. But when we call the getData, because we are passing in the URL, we know very likely what we're going to get back. So as a result, this is where we have to actually say, hey, I know what this promise is going to be. Let me tell you. And the way you do that is you use a generic. And as I mentioned with a generic, it's essentially a type parameter that can be used throughout the rest of this function inside of its definitions for types. So what we're going to say is that I'm going to pass you some parameter t. T typically is the starting type. So it's like T, S, R, etc. Those are the parameter names that are most frequently used. So here we're going to say, okay, let me give you some type T. And this is what you're going to pass into the promise. So doing this now, we're essentially saying, okay, getData is going to receive some type T. This type T is what you're going to return from this function inside of a promise. And now if we were to use this, remember we need to pass it some type T. We first need to import in the actual getData from our utils folder, data utils. And then what we can do is actually call getData and get the appropriate value. So inside of useEffect, instead of using fetch like this, what we're going to do is we are going to now create a new async function called fetchUsers, which is going to be, again, an asynchronous function that will actually retrieve these users and then set it inside of the monsters array. So let's talk about how to do that. So first we know that we get back the users from us calling our getData. We're calling getData with this URL. But here we need to define what the actual type that we're getting is going to be. Because right now, users, we don't actually know, which is why we're saying it's unknown. It's an unknown type. We don't know what the type that we're going to get is. We haven't defined it yet. We have to pass it in, as I mentioned, as a generic. What we know is that we have, again, those three values we want. So we can say this type is going to be of type monster. This monster has an ID, which is a string. It has a name, which is a string, and it has an email, which is a string. And we know this because we were earlier referencing the actual values inside of the website itself when we were looking at the fetch and we were looking at the JSON object. So here with this type monster, we know that we're getting it back as an array. So what we can say is that let me pass to you what this generic is going to be. It's going to be a monster, but it's in an array. So the way that you can define array is you can put these square brackets after the type, or you can say array like this. And this also works. This also defines an interface of type array. So again, if you look at this, you see interface array with the T being the generic. Monster is what it contains. So it's an array of monsters. But this is long and lengthy. I prefer using just this square bracket definition. And now we also know this is an array of monsters. So now what's going to happen is that if you hover over getData, you'll notice that it has our type definition. We are saying that this is a getData where we receive the monster array as the generic. Then what it returns back is a promise of the monster array. Notice how it took the generic and it passed it into the promise as the value. This is how you can use these generics, and now we know for sure that users is a monsters array. Because using type inference, TSX is able to know, oh, if I await this get data, I'm going to definitely get back a promise with a resolve value of a monsters array. Await is going to resolve that value, cast it to the users, so of course you're going to get an array of monsters. And now users is explicitly typed to a monsters array, which is what it's expecting. And just like that now, we have type safety. Now moving forward, what we also need to do is we need to set inside of our use state this monsters array. But this is not typed either. So what we're going to do in the next video is we type out what this will be. So join me in the next video and let's type out use state. Welcome back, everyone. In the last video, we learned about how to pass this generic monsters array into our own function definition where we're expecting a generic. Now, generic is a thing that is very prevalent across all of TypeScript because essentially you're writing composable types, you're writing parameterized types. It's a way for you to actually get a lot of extensibility and power out of your TypeScript. And React and all these third-party libraries utilize generics extensively. So we were talking about using setState. What I want you to see is that once we get our users, let's say I call setMonsters and I pass in our users. Notice how there throw an error. Argument of type monsters array is not assignable to parameter of type setState action never array. Type monster array is not assignable to type never array. Type monster is not assignable to type never. What is all this mean, especially the never? Never is a very special keyword inside of TypeScript. It's a very special type. Essentially, the never type is the opposite of the any type. It means that nothing can ever get assigned to never. The reason why it says this is because it needs to make sure that you are defending your code base and making it strictly typed. setState right here, if you look at useState, notice that right now it's initialized with the never type for the array as the default value. The reason why it's getting an array is because we passed it the array. So it's at least knowing we're getting an array. But the problem is we did not type this array. So it just automatically applies never. TypeScript is smart like that because it knows that if you're giving me an empty array, you have not defined the type for me. I'm not going to set it to any because that would be extremely not type safe. I'm forcing you to give me a type in order for me to actually set this value. So now what we need to do then is pass it as a generic argument, our monsters array. Now what this knows is that useState knows we are going to get an initial state of a monsters array. Our setState is going to expect a monsters array as the actual definition of what gets received as the argument. And now we'll notice that setMonsters works. setMonsters is equal to some function where the value is a setState action that receives the monsters array as the actual type. And now that is how you type useState. Now you might be wondering, well, Yuhua, don't we need to type the useState? So if you hover over it, you actually notice that we don't. And the reason for this is because TypeScript is able to infer the type if it has a type already. When we passed in useState, the default initial state that we pass for search field is a empty string. Now, an empty string is explicitly typed because there's no way a string can be any other type. So here what you see is that useState is already assigned to this string. Search field will infer that type and know that it can only be a string. Because if you're giving useState an initial value of a string, it's only setting strings. There's no way that you can set for anything else. So if you try and call it setSearchField and pass it any other type other than string, you will get an error. This also means that we do not need to explicitly type useState as a result because it can infer that type. Similarly, our useState for our filtered monsters takes the monsters from our actual previous useState as the default initial state. This is explicitly typed to monsters array, which we've already done. So now this use state is going to also infer that from the initial state. There is a lot of inference inside of TypeScript so that we don't have to get too explicit about everything. And this is how we type use state. There's numerous ways that we can utilize this typing, and again, you'll only get more familiar with practice. So now that we have this monster type, what we want to do is utilize it in other places that require it. Now, chances are we're going to need to actually import this monster type in other components. So we might as well export it for now. We can finally get rid of this fetch, since we now have our own function that will make this async fetch. And let's make sure to actually call this function as well. Let's save this now, and let's continue typing the rest of this function. Down here, we have this onSearchChange event. This gives us some event that we then use in order to call our setSearch field. The problem is that the event here is of an any type, because again, onSearchChange, this function, React does not know what this actual event is. We know that this is supposed to go to the actual onChange handler, but we need to actually type onSearchChange so that React knows what exactly this event will be. So here, what we know for sure is that we're definitely returning void from this function because there's no explicit returns inside the function itself. This event is a change event. So what we can do is from React, import in the change event. This is what we did earlier when we looked at our change event typing. So essentially, we just need to do the same thing. We know it's a change event. We know we're getting an HTML input element. And now this event is correct. OnSearchChange receives this event, change event. We then pass this into onChange handler, which similarly is expecting an event with that exact change event of HTML input element. So now this is properly typed. If we go back to our application, let's close our JSON placeholder. Here, if we start typing, we see that our code still works. So now that we've typed out our app.tsx, we still have two remaining components to type. The cardless component, which receives monsters, and this card component, which receives a monster. So very simply, in order to type these remaining two files, we just need to import in that monster type that we are exporting from our app component. So you go up to your app.tsx and you import in the monster type. And then now it's just a matter of typing out card components. So I'll say type card props is equal to us receiving a monster, which is of the monster type. Then we can just pass this like so. And of course, you'll notice that this is saying type aliases can only be used in TypeScript files, which just means that we did not convert this from JSX over to TSX. But once we do that, we notice again, everything works. Cardless component being the last one, just like we did with the other component, convert it to TSX, import in monster from our app component, and then we type out our cardless props. Monsters is a monster array. And then we pass cardless props like this. And there we go. We go into our application. Once again, we notice everything works. So that's it. You've learned really pretty much the core parts of typing React. There are, of course, other additional type structures that we need to get more familiar with. But generally speaking, this pattern of typing these things out, thinking about what it is that you're going to type, this forms the basis of TypeScript. It's really just getting familiar of when you're going to use generics, when you need to create new types, where you're going to set some of these values, and then allowing the inference to work in the places where it does, where it's going to infer the types anyways, and typing the places where they're not. Just trusting the TypeScript compiler to tell you where things are not being properly typed and set, and then just moving on from there. Now, my challenge to you is to start trying to type whatever you can inside of our actual final project, Crwn-Clothing. Start working from it. For now, I want you to avoid the generators or the sagas because the sagas are actually quite challenging to type, and we'll cover that together later on. But for now, just start typing the things that you know inside of your components. Start thinking about it. And then in the next video, we'll do it together. I'll see you in the next video. Welcome back, everyone. In this video, we are going to begin the process of typing out our final project, which is our Crwn-Clothing application. Now, I am not going to lie to you. The process of learning TypeScript with Redux is actually quite a steep learning curve. The reason why it's so challenging is because we have to learn a lot of new concepts, as well as flexing the ones that we know already in a manner that makes it so our code is extensible in Redux. The main thing, though, is that once you type Redux, you will accelerate your understanding of TypeScript quite significantly. But there is a lot of code changes that we need to make in order to make our code work with Redux the way we need it to, where it's type safe. Now, the first thing that we need to do is install the relevant libraries. So this is a command that we're pulling from the Create React App Adding TypeScript section of the docs. Again, you can check your resources folder for that. And as this is installing, what we're also going to need is our tsconfig file. So here inside of our application, just like we did with our actual Monsters-Rolodex project, we are going to add in a tsconfig file. So here, just do tsconfig.json. And again, look inside your resources folder and find the actual tsconfig file that I have included. And then I want you to paste that in here. Once you have this, you're going to go into your reducerutils.js file. We are going to start with Redux first because this is where our data lives. And from Redux, we are going to have to learn and touch upon a lot of additional concepts in order to make this code work. So I'm not going to lie to you. As I mentioned earlier, this is going to be quite complex. In fact, we're going to learn a lot of concepts that TypeScript introduces, such as function overloading, some really interesting usage of generics, as well as some additional functionality that we can get from the utilization of TypeScript features. The first thing that we need to do is think about what we're going to do and why. So in this video, I'm going to highlight how we're going to convert this over to TypeScript. We're going to start with the simplest reducer that we have, which is our categories reducer. Inside of our categories reducer, we are going to start with our actions. What we know about our action types is that we have this object that has these fields that we want. The thing about these fields, though, is that these are not just strings. These, in fact, are specific constants. They just happen to be strings. But really, what we're saying is that there are only 3 actions that our categories reducer or category saga, or any reducer, in fact, can recognize that is relevant to the categories. And it is these 3 values. These are the only 3 category-related action types. So this can actually be converted to an enumerable type, which is an enum. And an enum is a special, it's not even a type, it's actually an extended version or extended data structure that TypeScript introduces to us. And it's usable the same way that you can use an object. The only thing about it is that it has fixed values. In other words, instead, when you hover over categories action type right now with our object, notice how these keys point to strings. Instead, if we were to convert this to an enum, so first, let's convert this from JS to TS. What we can do is say export enum, category action types, and you get rid of this equal sign. And then instead of these colons, you set an equal. And this is your enum. Now, if you hover over it, enum categories action type is going to contain these 3 members, meaning that the 3 values that you can use as keys, just like you do with objects, though, they will only be equal to one of these 3 options. So this first step allows us now to essentially capture these literal string values, these literal strings, as the types themselves that we need to reference. So that's the first thing. By doing this, now when we go into our category action, just like before, we still have these create actions generating these action objects for us. But now we need to type these actions. The thing, however, with our reducer is that what we need to do is that inside of our reducer, we want to isolate the actions we respond to, because here we know we're going to receive every action. But the actions we want to respond to are specifically the category's action types. So essentially what happens is that only when we receive an action of these three types do we actually want our reducer to react. Now, regardless of the fact that we receive all the actions that ever fire, because in Redux that does happen. Remember, every reducer gets every action. Our reducer does technically only care about these three. So there needs to be a way where we can generically type the action, but inside of our reducer, we want to narrow the scope so that our actions are only the ones that are relevant to us, which are these three action types. So we need to think of a way so that we can extend upon our action creator so that we can make it work inside of Typescript. The other thing as well is that inside of this reducer, we will need something known as type narrowing, and that comes from using type predicates. And we're going to discuss that when we go back to our reducer utils, and we are going to write some additional functionality here. But the key thing that we're talking about right now is that we need to generate from these action creators some way that we know exactly the specific kinds of actions that exist. And the specific kind of actions are going to be some kind of action object, of course. But inside of our category action, there's only three specific types of actions possible. And they are these three defined actions. There is an action with the type categories start, but no payload. And then there is a action where the type is fetch category success with a categories array as the actual payload, and then categories failed with that fetch categories failed as the type, and then an error as the payload. But the thing is that they are essentially unique actions because these actions have very specific types, as we just defined with our action types. We need our reducers to respond in kind, but they also need to be smart enough to know that when you fetch a specific kind of action, that there is exactly the correct payload on it. So if this seems a little confusing, don't worry. As we type it out, it will make more sense. But I'm definitely going to tell you that what we're going to learn is very hard. So if it takes time to absorb, don't worry. It's expected. It's how it should be. So now that I've gone over the high level of what we're going to do, let's go back to our reducer utils and let's start working through what I mentioned. So we'll do that in the next video. I'll see you there. Welcome back, everyone. In this video, we are going to start modifying our create action type so that we can set up the remainder of our Redux with the appropriate TypeScript bindings. Now, the first step we need to do is we need to turn this reducer utils from a JS file to a TS file. And what we need to do is actually quite a large amount of work. But as we're typing this out and figuring this out, I'm going to touch upon why we need it. So it's going to be quite extensive. You just need to follow along with me as we go, and it will make more sense as we add in and type out some of what we're going to do. So the first step is we need to import in this any action type from Redux. The any action type is essentially an interface that extends upon this action type. The action type is just an action interface that has this generic T. This T can be anything. But the idea here is that this T is going to go to some type value. Now, when we go back to that any action also extends upon extra props. So any additional properties that you want, some people use actions inside of their project where they actually add their own values. So it's not just tied to type and payload. Sometimes there are some additional ones. But the reason why they use this action as the base is because not all actions have payloads. We run actions that have no payloads as well. So what we need to do is we need to take this any action and we have to figure out a way so that we can extend it into our system so that we can utilize all of our surrounding libraries. And this is a very important thing to note. There are many, many ways that you can approach typing Redux. Many different projects do it differently. There are trade-offs in this process. And as people say, TypeScript is an art, not necessarily a science. There is some degree of it where there's definitely best practices and patterns. But in this process, there is also a very high degree of what is correct and what is kind of correct but relevant in the use case. Honestly, all I'm trying to say is that this process is not going to be the most straightforward, but this one that we're going to do, we're going to justify every step that we go. So what we're going to do is I'm going to create two types. I'm going to create an action type that defines our action with payload. So here I'm going to say action with payload. This is going to be our type that takes some generic T and some generic P. Now T, of course, is going to be our type value. And then our payload is going to be P. So what I'm doing here is I'm saying whenever we call this action with payload, this T value is going to be one of those enum values that we're going to pass in. Because as I mentioned, when we did our category types right here, we know that the type is a very specific string. It's not just going to be string, but a very specific string. So I want to be able to pass that enumerable member value and then set that as the type. And then for the payload, well, we can pass in any payload that we want. So that's the first thing. The next thing that I need is the type of action. And action is also going to receive a generic T. And this T, of course, goes to the type. But because we have no payload here, we are just going to remove the need for the payload. Now you might be wondering, well, Yihua, why is it that with this action, we've created two types? Could we not just make this payload optional? And then now we have just one type instead of two? So the reason why this would be incorrect is because if you hover over this payload, you see that this property of payload points either to P or undefined. The problem with doing this is that it essentially says that you have a chance of getting an action where payload is always present. It's just going to point to undefined. While that's true in JavaScript, we actually don't want that to be true in TypeScript. We don't even want there to be a payload in the first place. Essentially, if you get this action where it's just a type, no payload, if you try to call payload, we want to throw actually that there is nothing there. It's an error. You can't even access payload because payload isn't even a property on this action type. By doing this, we narrow the scope. Because if we generate an action where it just has type no payload, then in no way, shape, or form should the code that's using that action ever even try to reference a payload. Because if you do, it's going to be undefined. There's no point of that. And there might be some functionality in the JavaScript world where you use that undefined payload to determine if you should move forward or not because it's indicative of something. But with TypeScript, it actually is the opposite. You don't want that because you get now that type safety. And this is where you kind of have to change your thinking a little bit. The patterns that you're used to before, where it's okay to have something as undefined, does not really run inside of TypeScript. You want to be very explicit. If you have some action that has a payload and another action that doesn't have a payload, those should actually be two different types. So we'll discuss more of this and the reason why we have to set it up this way once we move on to our reducers. But for now, we have to actually do all of this setup. So the thing that we know now is that we have two different action types. We have an action with a payload and we have an action without a payload. Based on this create action, depending on if we receive a payload or not, we want to return the appropriate action. We want to either return an action with payload type if there is a payload, but if there is no payload, then the type that we get back from calling create action should just be a regular action. So in order for us to achieve this, we need to do something known as function overloading. So function overloading actually comes from TypeScript, not JavaScript. Function overloading provides us this ability to make multiple function type definitions of the same name. So we can have multiple type definitions for create action. And what it allows us to do is allow this function to receive different parameter types. It should be the same number, meaning that we should receive 2 if our create action always receives 2. But what it does is that it can now return different types depending on the parameter types that we receive. So let's write it out and it will make more sense. In order for us to do it, we actually need to use the classic function declaration style rather than the arrow functions. So we're going to convert it over. So to do that, we're going to say first function create action. This create action, as we know, is going to get a type and a payload. So depending on the action that we're creating, again, we're passing those constant values. If you remember from our action type right here. These are these fixed values in our enum. So we need to pass that as the t value. But we know this is a string. So we're going to say that this create action extends string. We're also going to get the type for the payload. It might be anything we want to pass as the payload. And then what we're going to say is that, okay, once this happens, we're going to get some type value, which is t, and we're going to get some payload parameter, which is p. And then all we're doing is we are returning back an object with type payload. So if you think about it, really, this is just the type version of this using the function declaration style rather than the arrow function declaration style. If you were to do this not in TypeScript, you would just get rid of this and get rid of the types. These two are now equivalent, this function and this function, but with the types, it looks like this. So now we have a regular function definition that is typed. But now we need to type define this so that it returns the appropriate type from this. Because right now our function is not actually returning anything. This is more so what the actual code implementation of this function will do. So now we need to do the overloading. So to overload, if you're going to export, you always want to export all of your overload definitions. So again, we're going to type the same function create action. And here we're going to receive some t that extends string. And we're also going to receive p. So now what we're doing is we're just typing the function the same way, except we're going to make sure we return action with payload. Now we've already defined the implementation part in this last function. We don't need to define the implementation again. We're just going to define the type. So here we know that we extend these values, but we also need to now pass these types into the parameters. So here we're saying, okay, this create action function will get some t of type string and then some payload of p. And then what it'll do is that it just returns back action with payload t and p. So here we're just saying, okay, if create action gets called with a type and a payload, the return type from this function will be action with payload, t and p being passed in like so. So that's the action type you can expect to get back from this action when it's called with type and payload as parameters. Now what we want to do is we want to type the function if it gets called with just a type. Because when it just gets called with type, we want to pass back an action, not with payload. So here we're going to say t extends string. But what we need to know is that, okay, when this create action gets called with just type t, there's no p value here. So here we know that we are getting type t. But the thing is that create action is technically expecting a payload value because it's not optional. So this means that we want to make this essentially equal to void, which means that you are not expecting anything. And then we can just say action type t. Now, if you did not include this, let's say you just did this, you will see that create action throws you an error because again, it says the overload signature is not compatible because as I mentioned earlier, in order for you to overload functions, you must have the same number of parameters. So the way that you avoid this is you just say, okay, payload then gets nothing, void, no value. And with this now, you'll be able to create this additional create action typing on our function. Now, if you hover over create action, we can receive a payload. We might not receive a payload, but essentially what this create action will now do, it's hidden behind the +1 overload. It can now spit out either an action with payload if payload is provided, or an action if just the type is provided. This is essentially how you type these functions so that they can return you back different types depending on the parameters and the types that get passed as the parameter. If the payload matches void, so undefined, meaning you did not pass it, then you get back an action. If create action gets both type T and payload of whatever the P generic gets passed, then we get back action with payload instead. This is now our new create action type. So we didn't use the any action yet. Again, this will become more important a little later, but for now, this is what we've done for our create action. So with this now, let's move on to our next video where we will try and use this create action inside of our application. I'll see you in the next video. Welcome back, everyone. In our last video, we typed out this new overloaded create action. What we want to do now is use it so that we can see this in action, but no pun intended. We need to be able to understand how these overloads work, and it'll make more sense once we actually utilize them inside of our category action creators. So inside here, I am going to now continue using create action, but what I'm also going to do is I am going to update this action file so that it works with Typescript. And here is where we're going to modify the idea of this code a little bit. So first things first, what we need to do is first modify this file so it's a TS file. So let's go into our folder and rename this so that it's .ts. And now what we're going to do is utilize these errors and these underlines so that we know what new types that we have to create. The first thing we are going to do is we know that we need a categories array. Categories array, as we know, is inside of our database, and it has a specific shape. So we need to type this. So here inside, when you think about your category item is a specific type that has specific properties on it. So here I'm going to create that type category. And what it is equal to is an object that has a title, which is a string. It has an image URL, which is also a string. And then it has an items array. This items array contains our category items. So we actually need to make that. So I'm going to say export type category item. This is equal to an object that has number. It has image URL, which is a string. It has the name, which is a string. And then it has the price, which is also a number. So this category item is going to be the type of our items inside of the category. So now that we have these types, let's import them into our category action file. So first we'll import category and category item, and we'll use them in order to type out these action creators. The first thing that we need to do is we need to actually create action types for each of these. And we already have those action types created. We have the action and we have action with payload. Because this one produces an action, but this one produces an action with payload. Now again, remember, these actions are unique in the sense that their types are tied to whatever this type is, and then the payload is tied to whatever the payload of this return is going to be. So here, in order for us to type these actions, we'll say export type, and let's type fetch category start first. So we're saying we have a type of action called fetch categories start. This is equal to action, and this action gets passed category actions type dot fetch categories start. So now this action type, we need to say from this function, that's what you're returning. So whenever this function gets called, this action creator, notice that what you're guaranteed to get back is the action of fetch category start. So we're going to repeat this for the other two. We're going to say export type fetch categories success. This is equal to action with payload because again, we are getting a categories array and then we're setting that as the payload. So here I'm going to say categories action types dot fetch category success. And what we receive is a category array. Now, similarly, I'm going to need to type this parameter and also tell this fetch category success action creator that you're going to create, of course, the fetch category success action type. So now fetch category success receives a categories array of type category array fetch category success. The thing is, if you hover over this create action, what you will see is that create action here is inferring those types. You'll notice that what it produces is indeed that action with payload type. Notice how the top definition is create action, but that third line, action with payload of type categories action types dot fetch category success and category array, that is what it gives us back. Similarly, this top one, create action, notice how it instead gives us back the action of categories action types dot fetch category start. So this is how that overload is working. The last one we need to create is the fetch categories failed. And this is equal to an action with payload, categories action type dot fetch categories failed, and then an error. And now we know that we receive an error. And here we'll just say fetch categories failed. And there we go. We've now typed our action creators. Actually, we didn't even need the category item. So let's not import that because we don't need it. So now that we have these three action types, these are going to be the three action types that our reducer can only accept. So in order for us to do that, we want to actually create a union. So here I'm going to say export type category action. And here this is equal to fetch category start union fetch category success union fetch categories failed. So if we save this now, this category action is what we are going to bring into our category reducer. So first, we need to convert this over to a Typescript file. And now what we're going to do is we are going to import in category action from our category action file. And what we need to do now is we need to figure out how to utilize this category action and pass it as the action type here. This is where you're actually going to use that as keyword. So here we're saying, hey, this action that you receive is only going to be one of these three action types. Now, this pattern is called a discriminating union. Essentially, this union type that we've created for category action is discriminatory because it says that I only want to accept actions of these three types. This reducer only responds to those actions. If you try and call any other type inside of this definition, I'm going to throw you an error because I know this action should only be one of these three types. This is actually a very common pattern you'll see inside of TypeScript-enabled Redux projects. But this alone is slightly problematic, and we will discuss that after we've typed out the rest of this reducer. So there's a long way to go, but at least so far, we are now seeing the fruit of our labor in typing out our action creators and our actions. In the next video, we will continue typing out this reducer file. And we're going to start by typing out this category's initial state. So our state value here. So that's what we're going to do in the next video. I'll see you there. Welcome back, everyone. So let's continue styling this reducer. Here, what you'll notice is that our action cannot destructure payload. When we hover over it, it says property payload does not exist on category action. The reason for this is because inside of our union type, we have actions that do not have a payload property. So as I mentioned before, even though we are passing in a payload right here that points to void, this action does not have a payload value. So as a result, you cannot destructure something that does not exist. So even though on some of our action types inside of category action, they are actions with payloads, but the moment you have one that does not have that property, this will not work. And this is fine. We can just get rid of this call right here where we destructure. Instead, we'll switch right on action.type. And what we'll say is that categories, action.payload, and error, action.payload. So no destructuring. And instead what happens, you'll notice, is that because we're switching on the type, Typescript is smart enough to know that if your case hits this fetch category start, then what you're going to get here in the action is a regular action. Similarly, if you're inside and you pass this fetch category success, then this action type must be of fetch category success, and therefore the payload must be the correct payload. So that's one of those benefits that we get by creating this union type, and Typescript is smart enough to know that based on what checks and what passes, it will narrow the type down to what must be the case of this action by the time you get here. Now what we need to do is also we need to type this initial state. So here I'm going to say export type category state is equal to this object where we know this is read-only because we cannot ever modify these values. So read-only is an additional property you can add so that you force it that this state object can never be modified. It can only be read. And again, with the reducers, you never modify the state. You always spread over and create a new state. Now the values, of course, are categories, which is a category array. So let's ensure that we bring that in. And then read only, we also need is loading, which is a Boolean. And finally, we have error, which can initialize as an error or as null. So now we save that and you'll look at this and you'll notice that this is pretty much what our initial state value will be. And because this initial state value is being cast here, this is going to inherit that and state will always be of type category state. And now we have typed out this reducer as well as this initial state, as well as the state value as well. So there we go. We have typed out our reducer. The key thing here is that now we're using this discriminatory union in order for us to state that this is what must be the types of actions that our reducer responds to. The last thing we need to type out is our selector. So here inside of the selector, I'm also going to rename this to .ts. The moment we start actually converting our selectors over, until you convert all of them, Typescript is actually not going to compile for all of this code. And the reason why is because we do not have a root state type for our top level selector yet. So what you'll notice is whenever you check your application, unfortunately, it will always throw an error until we get to the section where we type out the root state. So in this conversion, we can't check that everything is continuing to work unless we type the selectors last. But again, I'm trying to show you this process of typing out these files. So just follow along, and once we're finished everything, it will all work anyways. And as far as typing our selector goes, we just need to think about what it is that the selector needs to actually return back. So inside, again, at this top level, here we know that we're turning back the category slice, which we just defined as the categories state. So this is what we want to return back right here. And now, if you actually look inside of this selector, it's actually smart enough to know what the types are now. Because again, this category state is what gets returned by this selector. So then this value that it receives, this parameter, must be the category state. So if we pluck off the categories value, then select categories returns a memoized selector. So that's what all of that stuff near the end is showing you. But notice how what it returns back is the category array, which is what this categories value points to. Now for this next selector, we see that we are indeed typing already, and the TypeScript compiler knows that we're getting the category array. However, it doesn't know what to do with this categories reduce because it doesn't actually know what this accumulator value is, since it's of any type right now. It's just an empty object. So what we need to do is we need to type explicitly what we expect the category map to be. So inside of our category type, I am going to now create a category map type. So here, we're going to need to export this out as we have been doing. So export type category map. So what is the category map? Essentially, it's going to be a bunch of different key value pairs. And the pair value is going to be category items arrays, because we're essentially converting this category object, which is an array of these categories, over to a map. Now, in order for us to say that this key is just going to be any string, you're going to use these square brackets and you're going to say the key is just some string value. It can be any value. It doesn't matter. It's just a string. Because we don't know actually what the key is going to be. It's based off of the title. So this allows us to just say, hey, all I know is that this key is a string. But the value is definitely going to be a category item array. And that is our category map. Next, all we need to do is just import this in to our selector file. And now what we can say is that from this selector, we're going to return a category map. And this object right here, we can type as category map, like so. So right now, essentially, you generally don't want to cast anything because essentially you're overwriting the type. You're telling TypeScript that this type is going to be something. But here with reduce, we know that what we're building out is going to be this category map object. So this is a place where it's relatively type safe to do this. But now we at least have typed out all of our action creators. Again, I'm going to mention that until we build out all of these reducers, we can't technically type out this root state. So that's what we're going to do next. But at the very least now, we have typed out everything except our sagas. The sagas we're going to type last because they're a little bit more complicated, so I want to explain what we're going to do with sagas. But at the very least, we have pretty much struck a general pattern for typing out the actions, the reducers, as well as the selectors. Now let's take what we've learned and continue typing out the rest of these Redux files. I'll see you in the next video. Welcome back, everyone. In this video, I want to talk about this pattern that we implemented for our reducer, using this discriminating union type in order to type this action that this reducer receives. Just to go over, this discriminating union type is a union type of all of the different action types that can come in as the action argument that this reducer will respond to. The problem with doing this pattern, and it's a very common pattern, you will see this throughout many different TypeScript-enabled Redux applications. The problem is that even though we as developers are saying, okay, this reducer only responds to these action types, Redux doesn't only pass these action types to the reducer. Redux, as we know, passes every single action type to the reducer. Whenever an action dispatches, they go to every single reducer. So even though for us in our code, we know that for this reducer, we only want to respond to these three different actions, In reality, when all of this compiles down to JavaScript in the end, Redux is still going to dispatch all the actions, and there's no type guards that's preventing any of the actions that don't match this discriminating union from coming in. So we have an interesting path down this. Here, we know that there is value that we get from typing out this action, because now we know that based on what code we're implementing inside, this payload, for example, must be category, because by the time that our code can pass this case statement of fetch category success, the action must be fetch category success. We get that benefit through using our TypeScript types. But in order to retain that, we do lose some of the actual reality of our code. For example, if I were to comment out this default return state, first of all, you'll notice that this is not throwing an error. In fact, even if we explicitly tell this reducer to return category state, notice how this is not an issue. We don't get this type error that we're not returning when any action does not pass these types. Now you might be wondering, well, Yihua, why is that happening? The reason for this is that TypeScript is inferring that this reducer will only receive these three action types. And inside of your code, you have created a case for all three of these action types, and they're all returning a state object, and they're still returning category state type out of this reducer. So TypeScript thinks that you've actually covered every possible case that this reducer can receive. But we know that's not true. There are a bunch of actions that fire, whether it be the ones that are not within category action, or maybe it's the init action that Redux actually fires on initialization. Maybe it's these different actions such as Redux persist rehydrate that we've seen before from our middleware. All of these actions pass through these reducers. And again, the way that Redux determines that this does not need to be re-rendered is through this default return. But now our code no longer is protected from it. In fact, if we come here, what we see is that we do not have categories because it returned undefined. Ignore this for now, this is a type error. But here you'll notice that the error itself says the slice reducer for key categories returned undefined during initialization. And the reason for that is that init action got fired when Redux first mounted. That init action passes in as an action. It sees that inside the switch statement, there is no default fall through, so nothing happens. Undefined gets returned, that becomes the state slice for this categories reducer. So this is where this code is problematic. So what we need to do is we actually need to modify our reducer utils with something that allows us to be more diligent in the actual matching. And this is known as type guards. So the way that we can do this is inside of our reducer utils. We need to create some way for us to actually match these actions directly on the type itself. So the type value needs to be something that we can leverage in order to check in our reducer rather than passing this discriminating union. So we know we can get any action. The thing though is that despite getting any action, we only want our code to respond to specific actions. So how do we do that? Well, this is where we're going to create something known as a matchable. A matchable type is a type that we ourselves implement. And what this allows us to do is it allows us to extend all of these different action creator functions with an ability to match the received action by the type that this action creator is associated to. This action creator we know returns back this specific type, with this category's action type fetch category start as the type that this action creator represents. So when we receive an action, we want to leverage this function to do a check. And the way we do that is we're actually going to attach a method on this action creator. So what we're going to do first is let me show you what I mean. Any function, regardless of what it is, let's say myfunc, and this is equal to some function that runs console.log hit. Here, you can run myfunc, and what you'll see is a console logs hit. In JavaScript, though, almost everything is an object, especially a function. That means that we can actually attach additional methods on here. I can say my function.match is equal to a function that runs console.log hat. And now I can still run my func as a function by itself. You'll see that we log hit. But what I can also do is I can run my func.match and it'll log hat. So it does not stop my func from being a function. It just extends the ability for us to add different methods on top of it. And this is what we're going to do. We are going to leverage the fact that in JavaScript, everything is an object to attach additional properties on our action creators so that they can behave also as action type guards. So I'm going to talk about how we do that in the next video. But the main idea I want you to understand is why we need it. And again, the reason why is because this reducer is assuming that all the actions coming through are going to be one of these three types. But in reality, it's actually not that case. As we saw, Redux initialization, middleware passes all these different actions. There's lots of different actions that might fire. And even though we might have this default return state, we still want Typescript to be accurate. Meaning that if this gets removed, we want there to be an actual error of some kind, meaning that we haven't handled anything. So that's what we need to do. And let's do that in the next video. Hello everyone and welcome back. In this video, we are going to discuss how we can extend our action creators so that they will be able to perform type checking for us, where they receive an additional action through a .match method that we're going to attach onto them. And what this will do is it will check the action that it receives against the action that it's meant to create. And essentially, these action creators are now performing double duty. They generate actions out of them, specific actions, but they also type check actions against the action that they hold. In order to do this, we need to leverage something known as a type predicate. And a type predicate is kind of like a function that verifies whether a specific argument that it receives is going to be a narrower type or not. And I mean narrow as in more specific. So let's say, for example, we had two different types. Let's say we had one type which was alien, and this had something where it was, I don't know, fly, for example, which is of type string. Just as an example. Doesn't really matter what that is. Now, let's say there is also a type human, and what it has is speak, which is a function. Actually, let's make both of these functions so it's much more clear. Now, if we had some function that checks whether or not this is a human, what should happen is that based on this function, it will receive some entity or some argument, and this can be either a human or an alien. What should happen is that after this verifies that the entity is human, then the type that comes out of it should be something that is narrow to the scope of human. So that means that inside, what our logic needs to do is that our logic needs to assume that this entity is a human. And here what we'll do is we'll say, okay, the speak method here should not be equal to undefined. If this is true, then what we'll get back is that the entity should be, in theory, more narrowed once we've run it. So what happens here is that we need to add this additional type definition that the entity is human, like so. So that's what this function aims to prove. This function receives some argument value, which can only be either human or alien. The logic itself essentially casts the entity as human. The reason why we do this is if you try and call entity.speak like this, you'll get a type error. You'll get a type error because alien does not have the speak ability, because this is a union type. So you can't call, again, a method that doesn't exist on it. So we have to say, hey, assume entity is going to be human and check the .speak method. Because if you call .speak in JavaScript on something that doesn't have it, this is just going to be undefined. But if you call it on something that has it, then it won't be undefined. So in the JavaScript world, this works, but in TypeScript, it won't, because unless you cast it, TypeScript is going to say, hey, if I get an alien, I don't have the speak method. We know that, but we want to leverage that. We want to call it if it doesn't exist so that we can check if the method on it is equal to undefined. If it is, then we know it's not a human. Now, if speak is on it and it's not undefined, then we know for sure this must be human. So if it's human, then the output of this function is this type predicate. It's narrowed that the entity that I received must be human. That's what this logic is aiming to do. And essentially what it allows us to say is that, let's say I get some value. We for some reason have some value called Josh. And let's imagine that when we called it, we don't know what he is. We don't know if it's a human or we don't know if it's an alien. If we say, is human on Josh, like this, then inside, if I were to say josh.speak, then this should work. Because essentially, as long as this passes, notice how even inside of a hover over Josh, automatically TypeScript knows, oh, this must be human because it passed this if condition statement. And this type predicate function narrowed this down so that it must be human. This little check right here, this is keyword that we wrote. This is narrowing this type so that anything that passes this function means that whatever you gave to it, if it's used later on, the type has been narrowed significantly smaller. So that is the whole idea around type predicate functions. And we need to leverage this in order for us to verify that an action we're receiving is a specific kind of action. Because that's what we're going to say. We're essentially going to modify our code so that we leverage these to match those actions that it receives. If it is of this action, then we know it's of this action. We can now leverage it inside of our reducer and respond accordingly. So this is the whole idea around using these matchers, these type predicate functions. And that's what we're going to do. We're going to do that in the next video. Welcome back, everyone. So I know we're learning so many new concepts in TypeScript, and it's very overwhelming. We learned about discriminating unions and their flaws in being used inside of the reducer pattern despite their popularity. We're learning about these type predicate functions that help us narrow down the type of variables inside of JavaScript world if they pass this type predicate function. In this video, we actually still have to learn 2 more types before we can start figuring out how to create that action creator extension. And what we need to learn is we need to learn intersection types, and we need to learn about the return type. So let's start with the intersection type. Let's say we had some type human. And this is just some type that has a name property that's equal to string. Let's say we also had some type alien. And on alien, it had the ability to fly, and it's a function, just a random function, doesn't really matter. What is a intersection type? An intersection is essentially the joining of 2 different types. So let's say we had some third type, hybrid, for example. And this is equal to human ampersand alien. The ampersand is going to be the intersection keyword. It's the type literal here. Hybrid, as you check, is now both a human and an alien. What this allows us to do is set some variable, let's say Josh, and it can be of that type hybrid. And now what you'll notice is that the value of Josh can have both the name as well as the fly method. This is possible because this hybrid type will have all of the properties and their respective types of both human and alien. If Josh was just a human, then you cannot have the fly method because fly cannot exist and assign on type human. Similarly, if Josh was an alien, then you can correspondingly guess that the name does not exist on type alien. But if he is both a human and an alien, then he can have both name and fly. That is essentially an intersection type. Very simple. It's kind of like merging two types together. Now, the other type that I was mentioning is return type. Let's say, for example, you had some function definition type. Let's call it myfunc, for example. Myfunc is just a function that returns you back a string. If I wanted the return type of myfunc, I actually currently don't know how to get it. The way I get it is I use a return type literal. So it's a very special keyword inside of Typescript that lets me get the return type from a function and then set it to something. So let me call it myReturn. And this is equal to calling return type and then passing it some function type. Now it will reach into this type and then get the return and give that back to me and then set it to this type. If I hover over my return, I see it's a string. If myfunc, instead the return type of it is a number, then myReturn is a number. If we go back and we assumed that type human that we had earlier. If this is what myfunc returns, then the return type, well, again, will get it and give me that type. So this is what return type does for us. And we're going to now use both the intersection as well as this return type to create our matchable type. Now, the matchable type is essentially an extension on this action creator. Remember how I said every function in JavaScript is a object? We're going to attach on every action creator this match property. And what it does is it's going to reach into this function, get this return type action. And it's going to get on this action the type value. Now the type value is going to be equal to this specific value. And it's going to use that and compare it against any action we compare it against. So to do this, what we need to create is first this type. So I'm going to call this type matchable. Now, if you're confused, once I write it, just really look at it and really study it and understand what's happening. Because right now, I understand we're learning so many concepts, it's definitely overwhelming. But I guarantee you, once you understand it, it will all click and you'll be so much better equipped as a TypeScript developer. So again, we have some type matchable. It's going to take a generic AC. AC here stands for action creator. We know that this action creator is going to be some function that returns back any action. So as you can see here, we imported any action from Redux. It's literally just any action. It has some type that can be equivalent to a string or anything else. And it has a bunch of other properties, could be payload, could be additional meta tags. We know with Saga, it adds some additional stuff to these action objects. The key thing here is that any action literally says that it can have any number of fields. As you can see, any extra props, they're string values that point to anything. That's the any action. And it extends some action, which receives some type, which of anything, of course. For us, we use strings, or we can use enum values, doesn't really matter. But here, this is the definition. We are saying that we are getting some matchable, receives a generic action creator, which is an object that returns back any type. And what we want this matchable to be is, of course, the action creator's type. And we also want to intersect it against another type. And this type is going to have that type value, where we're going to get the return type from the action creator. So we want to get the action itself. And off of this value, we want to get the type from the type property, which we can access using these square brackets. This will reach into the action, get the type value, and then take the type off of that value and set it to this type. So I know that seems very confusing, but this will make sense once we start using it. Once we start using it, all of it will be clear. Next, we have some match method, and this match method receives an action because, as I mentioned, we're going to be comparing our type now against this action. And what the match does, we haven't implemented yet. But essentially, what it will do is it will narrow the type down. So this is where I mentioned before that we were using those type predicate functions where we narrow the scope of the type down. So as long as whatever match receives that action, once it passes that check, we want to say that this action is definitely of the return type of our action creator. So if our action creator is our fetch category start and it passes calling match on the action, if it passes, then we know for sure it's going to be of the fetch category start action. That's what this matchable is trying to define. So if that's confusing, don't worry. We're going to now write out the actual modification function that will give us back a matchable from an action creator. But for now, I want you to absorb the usage of the intersection, the usage of the return types, and what I talked about that this matchable does. I want you to sit with this, read this, and really understand what's happening here. As long as you understand enough of it, we'll move on to the next video where we will write the actual function overload that will use this matchable type and the passed-in action creator to create this new object that I'm talking about. So again, this is very challenging. This is rather advanced TypeScript. But as I mentioned with Redux, Redux and TypeScript is challenging by nature. So we're really flexing our knowledge on TypeScript. So let's keep learning, and in the next video, let's use our new matchable type. I'll see you in the next video. Welcome back, everyone. In our last video, we created our matchable type. Now we need to create the actual withMatcher utility function that receives some action creator in order to create a new matchable type out of that action creator. So first we need to define this function withMatcher. So this withMatcher is going to be exactly that function definition. So we're going to overload this function with what kinds of action creators we'll receive. We might receive an action creator that has no parameters, and it returns back an action, any action. And for us, we know that this any actions type value is always going to be a string. As far as we're concerned, we're using strings. So we're just going to say, hey, what you're going to give me is going to have type string. Then what we're going to say is that we are going to receive the action creator function as the literal parameter for this withMatcher function. So essentially, if we had this fetch category start, we would be saying withMatcher receives fetch category start, and we want to return back this modified version of fetch category start function, but it has the match method and it has the type on it. So that's really what we're saying. So of course, that means that withMatcher must receive action creator, and this action creator is going to be of that AC generic that we pass into it. And what we're going to give back is a matchable object of that type AC. So here, of course, that AC that we pass is also the AC that we're giving to the matchable type. And matchable, of course, will reach in, get the type off of the return type of AC, and then similarly, we will create a new match function for it with this withMatcher. But for now, we're just overloading this function. We're defining all the different types of action creators we might receive. We know we can receive one with no parameters, and we also know we can receive one with parameters. If you think about our action creator, we have this one that receives a categories array as the parameter. We have this one that receives an error. In fact, all of our action creators can receive any plethora of arguments. That's not the purpose of what we care about. All we care is that we return back an action from each of these action creators. That's their purpose. So here we need to account for these action creators that could receive any number of arguments. And the way that you type that is you accumulate all of the arguments, like so, and you say that they are anything. When you accumulate them with the triple ellipses, essentially we're saying, hey, this is going to be arrayed. I'm going to concatenate them all into an array. So they can be anything. I don't really know what they are. So this is the one place where casting it as any is actually saying it could be anything, because it's true. It can be anything. We don't know what it might be. And what we're going to do is we're going to say, okay, this function still gives us back any action. And at the same time, we also know that the type is going to be a string. So really, that's all we're doing. We're just essentially saying, hey, I might receive an action creator that gets no parameters. I might receive an action creator that has parameters. And here, again, what we're going to do is that we are going to receive some action creator of type AC, and we return back matchable of that same AC type. And that's it. That's all we're really typing here. And now what we need to do is write the actual function itself of withMatcher and what it does. Now withMatcher receives some action creator. This action creator is a function. And we're using a generic function here because we know that our action creator can be any type of function, any kind of arguments, return any kind of action. So we're going to use a generic function because we've already got some of our safeguards up here extending what this function will be. Remember, this typing is just the implementation of the function in JavaScript. These others are our type overloading for the function that we've already done. So we don't need to go that intense with this one. So here I'm going to say, okay, what this withMatcher function does is it receives this action creator. And what it does is it gets the type value off of action creator being invoked. So we get the action and then we get the type value. The reason why we know there must be a type value is because these action creator functions return back actions. That's exactly what they do. They always return back some action, and every action must have a type value. So we're invoking the creator, we're getting the action object, and then we're getting the type value on it, and we're setting it to this variable. And then what we're going to do now is we are going to create the actual mappable object. So we're going to say object.assign on the action creator. And what we're going to do is we are going to give it the type value as well as the match function. So the match function receives an action that can be of any action. And what it does is it does the check. It checks that action type of this passed in action is equal or not to the type itself. Now remember, this match definition we've already defined up here. It receives some action, and what it does is it type narrows down this argument. If this passes, meaning that this is true, then this action we received narrows itself from any action to the return type of our action creator, which of course is our action creator function. It's type value that we just got here. So it's a lot of steps, but what we're doing is we're essentially now creating this generic function that is overloaded and allows us to receive any kind of action creator, but essentially be able to check the type against it, which is very powerful. Now we've done a lot. This withMatcher is not easy to understand. The main idea though is that we are just trying to extract the type off of the action that comes out of this action creator. And we're using these to do double duty so that these action creator functions can also match actions inside of our reducer. So I want you to look at this, really understand what's happening before we move on to actually use this withMatcher utility function. Just really absorb what it is that we wrote and all of this TypeScript definition. Once we move on to the next video, we're going to use them and hopefully it'll all clear up. And that's what we're going to do in the next video. But before moving on, I just want you to understand the typing here. Maybe not necessarily the full purpose, but at the very least understand what the TypeScript code is doing. So once you feel like you have a good handle on it, move on to the next video where we'll utilize this withMatcher function. I'll see you in the next video. Welcome back, everyone. In the last video, we finished updating our withMatcher function that takes some action creator function and adds an additional functionality of them so that they can determine if a past action has the same type as the corresponding action that they create. We're now going to use them so that we can understand what this is doing. So inside of category action, let's import it in. And then what we're going to do is use withMatcher and wrap around each and every one of these different action creators. So these action creators we've made so far are going to be the argument that gets passed to withMatcher. And now what happens is that each of these are matchable action creators. They now have that extended .match method. So here, if I show you, fetch category start, dot type. What do you think this will be? This will be that category's action type, fetch category start. Because remember, type inside of our matchable reaches into the return type of that action creator and gets the actual type. So here, this is an action of the type categories fetch action start. So we're reaching into this function, getting this action type, and then getting the actual type from the enum and setting that to some type value at the top level of the actual function itself. Similarly, if you check the match function, it is also a function that receives some action of any action. And what it does is it types that predicate to fetch category start if it passes the match. So that's really all we're doing here. Now we're going to use these inside of the reducer. So now fetch category start, fetch categories success, fetch categories failed. So remember, the original problem we're aiming to solve is that we want to make it so that this reducer is way more accurate to what's going to actually happen. Essentially, each of these actions that come in can be any action at all. So let's import in any action from Redux. So instead of setting this to this discriminating union of category action, we know it can be any action. So now what we're going to do, instead of using this switch statement, is we're going to say, okay, if the action that you give me matches fetch category start. So I'm going to say fetch category start, match the action. If it matches, if you hover over this action now, what do you see? You see that the action has been narrowed. It must be of fetch category start. That's what we're doing here. If it matches, it must be of this type. So now what we're going to do is return back this category state, except isLoading is true. So instead of using switch and cases, we're literally saying them with if statements. Alternatively, if fetch categories success on this action, then what we're going to return is this, where the categories goes to the payload, isLoading goes to false. Again, if you check the action, you'll notice that for it to match, it must be type narrowed down to fetch category success in order for that to work. Similarly, if fetch categories failed, matches on the action, then we're going to return back this corresponding state block. There we go. Now what you'll see though is that we still have an error inside of category state. The reason why, when you hover over it, it says function lacks ending return statement and return type does not include undefined. So here we've explicitly stated that this function always returns you back some category state. But clearly that is not what's happening. So in order for this to work, we must explicitly return if none of these actions match any of our corresponding action creators. Then what we do is we return the default state. And now our categories reducer is fully type safe. So this is the whole thing that we were gunning to do in the end. We wanted to create all of these different action creator matchables so that they can correspondingly match the actions against the actions that they create. If they create an action that matches and it actually derives the correct action, then we'll update the state accordingly. So instead of using a switch statement, we now use this matchable pattern. And here now, this is very clear. We know as Redux developers, reducers can receive any action at all. How we respond to them now is much clearer. And now our code is expecting us to always return back category state. So this is a much more accurate and much more reflective of reality version of the categories reducer, but it's entirely type safe. So that was the whole idea around why we were trying to create this matchable type. So we can get rid of these variables that we're now no longer using, and we can even get rid of this discriminating union type. And now, again, I want you to really think about what we did here. Look at these functions, look at this matchable type, think about the flow and the justification around why we did it all. Because this is probably one of the most complicated parts of TypeScript, which was typing Redux, as I mentioned. Because essentially, Redux is a very flexible service. It receives any kind of action. But in order for our code to actually be type safe and for us to expectedly do what we need to do, we had to extend out some type of functionality that will do this type of type narrowing for us so that we know for sure if we get the correct action, then we respond accordingly in kind. Now, there are some arguments by some in the TypeScript Redux world that this is a little overkill, but honestly, it's just the way that TypeScript works. If you want all the benefits of TypeScript and you want that type narrowing and that static type analysis, then you have to commit, and you gotta commit fully. And in order to commit fully, you gotta learn about all of these different techniques: function overloading, intersection types, union types, discriminating unions, and the advantages and disadvantages that come with them inside of this context of Redux. We had to learn about this return type. We also had to learn about these type predicate functions and type narrowing. We've learned so many new things about TypeScript, and I'm hoping that through this you're starting to see that TypeScript itself, while complex, is really learnable. It takes a long time and a lot of practice. But much of TypeScript's advantages is that when you learn this, a lot of languages actually have these functionalities. They just come with a statically typed language. And TypeScript is trying to make JavaScript into as type safe and statically typed as possible. It's not all the way there, but it does really try to. And in order for it to do so, you gotta break the way that you think about JavaScript, because a lot of our JavaScript best practices come from thinking about the fact that JavaScript is not typed like that. Whereas with TypeScript, it's really trying to get that benefit. And the main advantage that comes with utilizing TypeScript in this context is that you really, really absorb and get the type safety that comes with it. You're really making your code a lot more predictable because you're narrowing down as much of the types as possible, and you're narrowing down the actual functionality of the code that you've written. So with this, we've probably learned, honestly, 90 to 95% of what we need to do in order to type the rest of our application. The only thing that we haven't done is we have not typed the sagas. But what I want you to try is I want you to type all the remaining files inside of these store folders. So try and type the cart and try and type the user. In the next video, we'll do it together, but I just want you to practice first. And then we'll continue typing out the rest of our middleware. We'll type our store, our root reducer, and from there, we'll finally type our sagas, and we'll see all of our code run with our Redux now fully typed. So try that for me, and then join me in the next video where we'll do it together. Welcome back, everyone. In the last video, we migrated our category store over to using TypeScript. In this video, we're going to do it for our cart because it is the next simplest set of data to work with. To begin with, we're going to start with our cart types. And as always, we are going to migrate this file over to a TS file. What we now need to do is we need to first convert this over to an enum. So we're going to replace const with enum, get rid of the equal sign, and then every one of these colons is going to be an equal sign. Now that we have our cart action types, we want to think about if there are any other specific cart types that we need to define. We can get a good idea of this inside of the cart reducer. As we can see, we are storing cart items in an array. Cart items is a specific set of data in an array. But what is that data? Well, if we remember inside of cart actions, add cart item is the first time where we actually create this actual cart item. And what it is all of the properties of the product that we're adding in, plus a quantity value, which is a number. So what is product to add? Well, product to add is a category item. So what we know is that our cart item is just a category item with an additional quantity. And what we can do in order to make our lives easier is we can actually bring in the category item from our categories. So let's go up to categories, category types. Now, if you think about the category item, it has all these properties we want, but it's just missing the quantity. So here we can make a intersection type of cart item, which is equal to category item plus this additional quantity field that we're looking for, which is a number. And now it's very simple. If category item ever changes, our cart item will similarly change, as long as quantity is the only field we want to append to our cart items. The great thing about this is because the way our code is set up as well, we are spreading through these fields anyways. So as long as all of these values stay the same, essentially our Typescript code type is also inferring the same pattern of spreading through the category item to create the actual cart item. So now that we have this cart item type, what we want to do is we want to start typing the appropriate actions. So first we are going to change our cart action from a JS file to a TS file. And inside, what we need to do is we need to bring in the appropriate with matcher. Similarly, we know we need a few types. We know we need our cart item, but we also need that category item. Because as you remember, right here, product to add, well, this is a category item. As for cart items, this is an array of cart items. And what does add cart item give you back? Well, if you remember, it is going to give us back an array of cart items, regardless of which of these returns it is. So here we can just say, give us back a cart item array. This is our helper function that we've typed. This doesn't need the with matcher because it doesn't actually generate an action, but we do use it inside of our actual action creators. So let's type these first. Now, similarly, this remove cart item is very similar as well. It's an array of cart items as well as a cart item. Unlike before, remove cart item gets called on only cart items. And now, this existing cart item, here we see check if quantity is equal to 1. But if you hover over it, it could possibly be undefined. There is a high chance that when we do this .find, we don't find a matching cart item, which is what our code checks to do. Of course, in this particular case, when you check on this quantity value inside of JavaScript, JavaScript will give you back undefined if there's no existing cart item. But for us, this is not good. We need to actually modify this code so that it works. And all we can do is just say, if there is an existing cart item, then check the quantity. Otherwise, don't run this part. And now we've resolved our actual type issue. And in this particular case, it actually helped us because now our code is less prone to error. So what we can do now is we can just make sure that we also type the return value for this function as the cart item array. Finally, we have our clear cart item. Again, we have an array of cart items, and we have a cart item that is trying to be removed. Once again, we return back an array of cart items. So there we go. We have now typed out all of our utility functions. What we want to do next is we want to define each of our actions as a type. So here first, I'm going to say export type set is cart open. And this is going to be equal to some action with payload. So actually first, let's bring that in. We need to bring in the appropriate action types as well, which we did not bring in. We need our action as well as action with payload. So first, set is cart open. It is an action with payload that receives cart action type dot set is cart open with some Boolean value as the payload. Next, we need to think about these three actions: add item to cart, remove item from cart, and clear item from cart. Each of these, while being a different action creator, actually does in the end create the exact same set cart items action. So technically, these three are different functions that manufacture the same type of action. And here we're just defining the type of action, and this type of action is our set cart items action. And this is also an action with payload. The cart action types is set cart items, but the actual payload value is going to be an array of cart items. So this is what's really useful about typing. You can actually see some of the optimizations you can make. So of course, set is cart open. This we can turn into a matcher first. We receive a Boolean value, and we output a set is cart open action object. As for these other three, we need to first create this set cart items action creator. Export const set cart items is equal to with matcher. We receive cart items, which is an array of cart items as the type. We output our set cart items action. And the definition is that we create an action with cart action types dot set cart items, passing cart items as the actual payload. As for these other three now, instead, we can simply replace this with set cart items, passing in new cart items like so. Then we just need to type these cart items as cart item, like so. And product to add, of course, is a category item, but then cart item to remove is also a cart item, just like cart item to clear. And there we go. That is our new updated code. So now all we need to import into our reducer is these two matchers in order to determine what the new order is. So I want you to try that. I want you to take what we just made, go into the reducer, and update it to the new pattern that we use with our matchers. So once you've tried that, we'll do it together in the next video. I'll see you there. Welcome back, everyone. In the last video, I challenged you to utilize our new matcher action creators inside of your cart reducer. So there's a little bit of difference in how we do it inside of this code than how we do it inside of our category reducer. To begin with, we need to import in all of the appropriate files. So first, we need to import in any action from Redux, because that is going to be the type that we receive for our action. And we also need to import in the respective action creators. So here, let's just go into cart action, and let's bring in our set cart items as well as set is cart open. The first thing we want to do is we want to type the actual cart state. So here we'll say export type cart state, which is equal to is cart open, which is a Boolean value. And then cart items is an array of cart items. So we need to bring in our cart item type, like so. And now we can set this initial value over to our cart state. And what we want to do next is we want to also update this action. So one thing that we were doing before is that we were setting this action equal to an empty object, because sometimes we might get these reducers called and they may not receive the full action. So we assume that this might be an empty object by default so that we can destructure something or attempt to, so that we don't get errors. But in our new patterns, we don't actually use this destructuring anymore. So we actually don't even need this equals. We can just go directly, action is equal to any action. And now we know that we will also always return a cart state from our reducer. And then we just need to update our switch cases. So first we just say if our set cart items, or actually let's start with set is cart open. If this matches the action, then we know that we can simply update the is cart open. Actually, I copied over the wrong one. Let's update this like so. and then just fix up like so. Of course, we don't have a payload destructured, but again, because of our type predicate function, we'll notice that our action is definitely going to be set is cart open, and our payload is definitely going to be a Boolean. The next one that we need is our set cart items dot match on the action. And similarly, we will return the appropriate state updates. Cart items points to action payload. And then by default, we return the state. And that's it. That's all we need here. We can just remove our cart action types. And now our cart reducer is also typed. It's much simpler now because, again, we've already done this before. The first time we did this with our categories, it took significantly longer because we had to go through all of the learning of how to make these matchers and setting this up for the first time. But once you get those repetitions in, it just gets much easier. And here as well, as I mentioned, we no longer need this equals. We can just set this equal to any action. Now, one more thing to type for our cart is our selector. So let's update this to TS. And as I mentioned before, we can't type this state yet because, again, we don't have all of our reducers typed. And unless we have them all typed, we actually can't type the root reducer, which will give us the value for this state type. Instead, we just need to type what we can. So here inside of our select cart, we know that what we're going to get back from select cart reducer is the cart state. So all we do is import in cart state and set it to the outputted value from here. And now automatically what we notice is that everything else gives us what we want it to give. So select cart count, of course, returns a number. Select is cart open returns a Boolean. Select cart total returns a number. All of these are now intuitive enough to know based on the inference of the actual top level cart state, what all of the subsequent values are. So this is a very, very powerful thing that comes with our selectors as well as TypeScript due to the natural inference. Because we've typed what this initial entry reducer gives back, which is the cart state, all of the subsequent derivations are going to be automatically inferred. If you reduce over cart items and we know that this is a number, then automatically cart item, we're using the quantity, which is a number, you can only get back from this reduce a number. That's the power of this technology with TypeScript and these inference engines that come with VS Code. So easy. It makes our lives so much easier. If you want, you can type them so that it's more explicit and you can see it. But a lot of times I like referring simply to use the actual inference engine so that it makes my life easier and I don't have to type as much, but I still get all the benefits of TypeScript. Now, one thing I do want to mention is that when you switched over from .js to .ts or even .jsx to .tsx, if you were using a import where you were referencing the path of a value for one of these files where you explicitly had said .js, what will happen is that now you'll notice that this import will fail because we no longer have cartaction.js. This is now a cartaction.ts. This is why it's important for you not to include the actual end of the file, the extension, when doing these conversions. We rely essentially on Webpack and Babel to transpile our code down and know the correct endings and infer the type of file from that. Again, we'll discuss that later in the Webpack Babel section. But for now, if you're noticing that you're not actually able to finish any of your imports as you go through this process of migrating your files over to TypeScript, this is an important thing to keep in mind. So now that we've finished up with our cart store, let's move on to our user store. So try that yourself. You'll probably have to also type the Firebase utils, but just give it a try. And in the next video, we'll do it together. I'll see you in the next video. Welcome back, everyone. In this video, we are going to type out our Firebase utils. We want to type them out so that we can end up finally typing our user store files. But starting with the utils will teach us a couple concepts that are new because we're working with async await and an external library. As well, it'll help us set up for the final typing of the user because so much of it depends on these Firebase files. To begin with, let's think about what we need to do. So first of all, let's first look at the different errors that we see all along the side here, because these are all of our type errors. And with that, we can begin actually typing out our file. So here, what we start with is this add collection and documents. So what is it that we are receiving? Collection key, if you remember, this was our method that allowed us to add a bunch of things into Firebase. We were batching them, we were committing them, and that's how we finished it. Collection key is the string representing the collection we want to add this to. Objects to add. What is objects to add? Objects to add is going to be an array of some specific type of object that we are trying to add into our DB. So here, because it could be some random type that we don't know in the future, we want to make it so that we can pass it in as a generic. The only thing we know that for sure exists on this object is a type title. So here I can even make a new type called object to add. We can export this out because in the future, maybe we might need it. And again, the only thing it has is some title, which is a string, because using that title is oftentimes how we're going to determine what it's going to be. So here we can just add that as the type T as an array. And then this field, I actually think it's not even being used. So this might actually be an extra field that was unused that we can just get rid of. Now, let's continue. The next thing we need to type is our get categories and documents method. So here, this is an async function. Actually, earlier here, with the same async function, we want to return something. This function doesn't return anything. With async functions, you always return a promise. And within the promise, you have a value. So for us, we're not actually resolving or returning any values. So we can just make sure that this returns a promise of void. Whereas for get categories and documents, does this return something? Yes, it does. What does it return though? In this particular case, it returns some category data. The category for us has to do with our category reducer. So here we actually already have this category data as a type. We also have the corresponding category items. So let's first just bring in the category. So we're going to go up here and we're going to import category from our category types. And again, it has the title, the image URL, as well as the items. So that's what we need. We can come down here to our get categories and documents. And what we know that we get back from this function is going to be the data of this category. So it's a promise, because it's an async function, of our category as an array. If we look at our return though, here we see that this is actually not working because what we get is a bunch of query snapshots. The reason for this is because we know what it is that Firebase gives us back, but Typescript doesn't know that. We've looked inside of our Firebase DB, we know what the object will be. So this is where we actually need to cast the value. So what we can say is that doc_snapshot.data like this is going to be as category. And essentially what we're saying is that we know that document snapshot.data is going to come back as a category type. So just cast this value of what you get back from the data call as a category type. And this is all we need. Typically, you don't want to do too much casting because you're essentially telling Typescript that this is what you're getting back. But oftentimes when you interface with a third-party API, this is going to be one of the things that you are going to have to keep track of. But casting here is not a bad thing to do. And with that, we now have this function typed out. The next thing that we need to do is type out our create user document from auth. So here we need to type out our user auth. Now, The user auth is actually something that we call user auth. What it really is this user object that we get from, luckily, Firebase. So this is already something that's typed. Firebase auth gives it to us. And here, if you hover over this, oh, sorry, not Firestore, Firebase auth right up here. If you hover over this, you see that it is actually an existing interface for a user account. So that is really handy because now we can just type it like so. Similarly, let's think about what else we need inside of this function type definition. We know that with this, we also get some additional information. Now, for now, all we're adding for this additional information is just the display name. And this is even optional. So here we can put it like this and cast it like so. And the reason why we only have a display name, of course, is because according to our signup form, that's the only values we add. If we were to add more, we can, of course, add to this additional information here. If you want to keep the types for this file inside of a separate Firebase file, you can do that as well. That's a pattern. For now, I'm keeping it all inside of Firebase utils because this is really the only place I'm using it so far. Moving on. We also need to type out the actual user data. So here I'm going to type out user data because user is already claimed by Firebase auth. This is a type that is equal to something that gives us a created at date, which is a date. We also have display name, which is a string. And we also have email, which is a string. So this user data, what is the actual user data? Well, user data is something that we get back from this final setDoc call where we return back this user snapshot. So here, this is where we need to tell the actual function and utilize our user data. So let's think about the flow of this document. What can we get back? We can primarily get back user snapshot, and inside of this user snapshot can either be the user data or it can be nothing. Because if we log out, remember, we also run this through our listener. Our onAuth listener calls create user doc auth. Regardless of what happens, if you sign in, if you sign up, and if you sign out, all three values of user auth get passed in, which is why we have this check. So here we might actually resolve to undefined. So that means that this function can return back a promise value of both this void value, or it can return back this user snapshot. Now, user snapshot is not the data. We're not returning back the data. We're returning back a snapshot. So this snapshot, though, is actually already typed for us. And this is something that Firebase gives us. So here up inside of Firestore, we can get a query document snapshot type. And this snapshot type is going to hold the value inside of the snapshot. So here we can just say, okay, it's a snapshot type, and inside of it is the data, user data. And there we go. The last thing we need to do, of course, is tell this user snapshot what it's going to be. And for us, as mentioned before, with Firebase, we can cast this as well. We can say that this is going to be a query document snapshot of a user data type. One thing you'll notice here is inside of catch, error will not have a message type. This is because inside of every catch, by default, it is going to be of an unknown type. So for us, instead of trying to just call directly error.message, we can just console log the whole error. Again, with unknown is very similar to any. The only difference is that unknown is not resettable. You can't set the value of any unknown to something else. But just like any, TypeScript has no idea what it's going to be. There's no type associated to it. And the reason for this is because you can catch numerous types of errors. TypeScript, or JavaScript, sorry, not even TypeScript. JavaScript's catch does not know what's going to get thrown. For this reason, there can't be an associated type to it. So for us, that's fine. We're just going to say catch We're just logging it anyways. That's fine for us. Moving on, as far as these email and password goes, we know that these are going to be a string, and we know that password is also a string. Now, what is it that create user email and password give us back? Well, if you hover over it, it tells us, it gives us back a promise of user credential. So here, if we hover over this, we already say that we're going to get that back. Promise of either user credential or undefined. The reason it's undefined is because we might exit early. So we don't need to type this. Similarly with this one, sign in with email password, it's a promise of user credential. So again, we don't need to type this. We just need to type our parameters to ensure that they go in as strings. Because again, we see that we get a promise, user credential, or undefined. Our sign out user, promise of void, because once you sign out itself returns you void as a promise. Now for our on-auth state change listener. What is the callback that we're passing in? The callback is a function, but it's a very specific function. It is a next or observer type. So this again is a very special function that gets called with the .next as a callback whenever the observer changes. Now, luckily for us, we actually can import this type as well from Firebase. So here we just go up to Firebase auth and we just import in next or observer. And what this gives us is the user, because on-auth state change is always passing us this user that we already saw earlier. Again, this is a user account. So whenever the auth state changes, Firebase is trying to give us that user account. So luckily for us, that's all we need as well. As for our last one, get current user, this was that type that we had created to return us back a promise. And that promise is going to be either a user or null. Because again, when we call this, what we are looking for as on-auth state changed, we might get back the currently signed in user or authenticated user. Or if there's no user, Firebase gives us null. So as a result, the promise can only resolve with user or null. And that's it. We learned a lot about typing out these async functions, mainly wrapping them in promises. And we learned a lot about all of these different additional casting opportunities we have to do working with an external API, but also these types that Firebase gives us. But now we have fully typed out our Firebase file. So that's it. Now we can start using this inside of our user reducer files. And that's what I want you to do. I want you to take these type files, try it out yourself inside of the user reducer files, and then join me in the next video where we'll do it together. Welcome back, everyone. In this video, we are typing out our user Redux files. As usual, to begin, we will start in the types file and we will convert it over to a TS file. We will switch this const over to an enum. And again, we get rid of the equal sign and we convert all these colons to equals. The thing that we've done before was that every time we were storing some kind of data structure inside of our state, particularly for current user, we would put the user type or the object type, the data type, inside of our user types file or the corresponding types file. In this particular case, our user data actually lives inside of our Firebase utils. If you remember, earlier we had defined this user data property. So here what we can do is we can either keep it related to Firebase or move it to user types. Personally, I'd rather keep it in the user data inside of Firebase because this data actually matches the data inside of Firebase that we get back. So to me, it's more correspondent that it's related to Firebase than it is related to some type that we have defined specifically for Redux. So here, what we're going to do then is we'll leverage it inside of the actual Firebase file. And now what we're going to do is we are going to begin the process of migrating our user action into our matcher pattern. So first off, let's bring in our with matcher. And what we need to do is essentially also bring in that user data. So user data, like so. And now that we have our imports, what we can do is convert this action over to a .ts file. And then we can start defining the actual action types. So we have all of our action creators, but we need to create a bunch of different action types. Because essentially, when you think about each of these, which ones create new actions, which one create old actions? Well, looking at them, they seem to all create new actions. So that means that we have to define a new action type for each of them. So let's start. First, we want to make our check user session, which is going to be this one. So let's move this up here. And here, this is equal to action and action payload, which we also forgot to import. So we also need our action with payload. Now, check user section just takes action and then this user action types of check user session, like so. So here we can do that and make sure that this action returns the appropriate action type that we've just defined, and also wrap this with a with matcher. Now, similarly, we need to do this for every next one of these actions. So I want you to try this out. What I'm going to do is quickly speed through it so that you can see, because a lot of this is just doing the same thing we've done over and over again. And I don't really want to bore you too much with me typing all of these different methods. So I'll do a few. I want you to then pause the video, do a few, and then we can accelerate through this quickly and get to the final state. So let's continue. We did check user session. Let's do set current user so that we can do one with a payload, which is to action with payload. And this one will take this user action types with set current user. And of course, it's going to be of the type user data. Continuing on, we want to actually pass this like so and wrap this inside of a with matcher. Then we want to do our Google sign in start, which is equal to an action of the type user action types Google sign in start, which we will then, of course, similarly assign and also wrap in a with matcher. And there we go. We've done 3 actions. So now all the subsequent ones, very simple. Here, the only one that might be new is that additional details. We need to also bring in additional details, or whatever we called it in our particular case, additional information. We can set that. Not even here, we can just set that inside of the actual action type. So here you can see that we actually wrap this inside of an object, just like this one. So you know what? I'm going to do these 3 unique ones: email sign in start, sign up start, and sign up success, where our payload is unique. So here we don't even have to be too explicit about it. We can make one, let's call it email sign in start, which is equal to a action with payload. And here we can do user action types dot email sign in start. And we can literally just pass a brand new type here, where email goes to string, password goes to string. We don't even have to make a new type for it necessarily. We can, if we plan to reuse this actual email sign in start payload, but in our particular case, we don't need it more than just being here. So I'm just going to hard code it, as we saw, right inside of the type definition. We can do the exact same thing here for sign up start, which I'm going to do before everything else. Actually, for set current user, I did not set this to a user data type. So let's just quickly do that. But now for the sign up start, let's say export type sign up start is equal to an action with payload. And here it is a user action type sign up start, We take an email, which is a string. We take a password, which is a string. And we take a display name, which is a string. And now here, we'll just say string, 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 sign up start. Similarly, wrap this in a with matcher, like so. And here we see we actually have a type error. What's our type error? Email string, password string, display name string is not assignable to sign up start. Properties are incompatible. User action type sign up start is not assignable to user action type sign out start. So here, this is sign up start. We see that what we had was sign out start. So that is a typo. And again, you see how Typescript will tell you when you make this mistake. So really great. So now these remaining ones all should be quite simple. You've seen me do pretty much all of them. I want you to do it. I'm just going to speed through this section. I'm just going to accelerate the video so you can just reach the end and watch me doing all of these ones. Welcome back. So there we go. I have just coded out all of these different action types and attached them to the corresponding action creator, as well as wrapping them in the corresponding with matcher. So all very straightforward, just very tedious and very numerous. But now that we have them, try and use them inside of the reducer. Really think about what it is that our user reducer is going to need in order for us to actually switch it over to utilize these action creator match patterns. Because you see there's a couple fall throughs here. So try it out yourself. Join me in the next video where we'll do it together. I'll see you in the next video. Welcome back, everyone. So now that we've typed out all of the appropriate actions, let's import them in so that we can utilize them inside of our reducer. Now, we don't necessarily need all of them because our reducer only responds to sign in failed, sign up failed, as well as sign out failed. And then we have sign out success. And we also have sign in success. So these are the 5 actions that our reducer responds to. We know that our action needs to be of the any action type. So we'll import in any action from Redux. And here we can just cast it like so. We also want to type out our initial state, so our user state, which is going to be current user, which is some user data. And user data, of course, comes from our Firebase utils. But it's going to be user data or it's going to be null, because both are valid states that we can receive, as well as our initialization state as well. Is loading is going to be a Boolean, and error is going to be of type error or null. Now, as mentioned, these are read-only. So let's make sure to make these also read-only. I may have missed this actually inside of our previous reducer for the cart. So if I did, we'll go back, we'll update them later. But here, inside of this reducer, we're going to get rid of this destructure. And then we're also going to cast the initial state to be one of the user state. And then it's just a matter of doing the correct switches. So first, we're going to say sign in success dot match our action. Then we are going to return the current state with action.payload like so. Similarly, if sign out success dot match with the action, we will return with current user set to null. And now for these 3, sign out failed, sign in failed, and sign up failed. How are we going to write this? Well, this we're going to match with just a bunch of or statements. So we'll say if sign in failed dot match on this action, or sign up failed dot match on this action, or sign out failed dot match on this action. If any of these match, then we are going to just spread this through past the payload because it's going to be an error. And then it's just a matter of keeping the return state as the default fallback. And that's it. This is now our user reducer. So the last thing to type is the user selector. So of course, as we can see from our selector, here, this is just pulling off the user.currentUser. We can actually even improve upon this by importing the create selector from reselect. We can import in user state from our new definition, and we'll export const select user reducer, which is equal to something that gets us the root state, and we're going to return back user state, and we're just going to pluck off that state value, and select current user here is just going to be a new selector that is going to not receive that object. Instead, we're going to say select user reducer, and what we'll get back is the user state, upon which we will pluck off the current user like so. Create selector, I spelled it wrong. There we go. And now here, this is not in a TypeScript file, so let me quickly remedy that. But there we go. Again, we know that we have not typed state, but at the very least, we have now modified our user selector so that essentially we have this entry point into the user slice, and then we create a selector to pluck off the current user. So earlier we didn't have that, but now we do. And there we go. We have typed out the majority of this user store file. So very quickly, let me remedy that issue that I mentioned where inside of our cart reducer type definition, I did not make these read-only as I should have. So that is also done now. And we make them read-only, of course, because we just want to say, hey, these values will never update. This state value should not be mutable. It should only update if you return a new object. So this just prevents anybody from coming in here and modifying it like so, saying state dot, for example, state dot is cart open, like this, is equal to false. You'll notice that it throws an error. This assignment cannot be done because it is read-only. So that's why we do this, because it really enforces that pattern that we want these state to be completely immutable. So now that we have typed out all of these reducers, we can finally now address this type issue where this state is not typed out. And that's what we're going to do in the next video, where we will finally start typing out the last touches inside of Redux. So we're going to type out our stores, and then we're going to type out some of our middlewares. And even after that, we'll type out our sagas. So join me in the next video where we'll tackle those topics together. I'll see you in the next video. Welcome back, everyone. In this video, we are going to finish typing out our store. So here we are inside of our root reducer. Our root reducer, if you hover over it, is already typed for us. It's of the type reducer. It has a combined state as the return of our type, where we have all of our different states that come from our respective reducers. User state, category state, and cart state are all states that we have defined as the returned state of each reducer. So we don't need to type this. What we do need to type, though, is the store.js file. So here, I'm going to convert this over to store.ts. And what we want to do is we want to type out the root state itself, which is the actual values that are contained inside of the actual root reducer. So here I'm going to say export type root state is equal to the return type, because remember, each one of these reducers is just a function. Now, if I just put root reducer here, if I were to get the return type of root reducer, here you'll notice that this is going to give us an issue. It says that root reducer reduces to a value, but is being used as a type here. Did you mean type of root reducer? So root reducer is a function or something that lives in JavaScript. It doesn't live in TypeScript world. It doesn't live in the type world of TypeScript at the very least. We can get the type of it though by using type of like this. Type of gives you the type of whatever you are calling it on. So for us now, when we call type of root reducer, we are getting back that reducer combined state and then of all of our states. So when we get the return type of it, root state will now give us that object that contains all of those values. Now it's an empty object as well because on initialization, nothing is going to be contained. And then it populates once all of our reducers return back with corresponding values, then the root state actually gets built. But the key thing you'll notice is that it is indeed an intersection, but primarily of all of our different states to their corresponding slice keys. Now that we have our root state, we can now start fixing all of the different type issues that we had earlier inside of each of our selector files. So let's go into each selector and let's import in our state value because this state can now be cast. So I'm going to import in root state from the store file. And now I just say that state points to root state, and there we go. I'm going to copy this over because in each selector file, I'm going to need to do the same thing. And all of these are all in the same relative path of each other. And then the last one is category selector. There we go. Now, honestly, you're watching me go through all these files in this manner because this is pretty much what migrating a project over to TypeScript looks like. Personally, I think migrating a JavaScript project to TypeScript is the best way to learn TypeScript. You don't want to be learning JavaScript and TypeScript at the same time. It's much easier to understand how JavaScript already works inside of your code that you've already written. And then upgrading it to TypeScript is much easier because you can just focus on learning TypeScript. But there we go. We have now fixed those type issues that we were getting from all of our selectors because now we're coding out the state and giving it the state. So once we have that now, what we need to do is we need to address these remaining issues. So here, first, we notice that this says that property Redux DevTools extension compose does not exist on type window and type of global this. So the window is typed as well, the window object, which the browser gives to us. We want to extend on it. And the way you do that in TypeScript is you first need to declare a global. So you're saying, hey, I want to declare this globally. And what we're going to say is that interface window, which is something that already exists, we are going to add this Redux DevTools. Now, this is going to be an optional key. So we can put question mark, colon, and that just means that it does not have to be there. It might be there. It might not be there. The reason it might be there is because sometimes we load it with the DevTools. It might not be there if the user doesn't have the extension. That's all we're saying. So now that we have this on, what is this going to be? Well, as we know, this DevTool extension gives us a special type of compose. So this is really just a type of the compose function that we get back from Redux anyways. And that will now help us clear this issue that we're getting, which is that it was not being registered. So moving on now. Scrolling down here, we notice that we have a type error with our middlewares. We see that argument of type false or middleware is not assignable to the parameter of type middleware. Type boolean is not assignable to type middleware. And the reason for this is because apply middlewares is only expecting middlewares inside. If you look at this middlewares array, the reason this is happening is because here our process env check to see if it's in production mode or not. Because of the double ampersand, we could end up with a false value, meaning that if this evaluates to false, we won't even bother evaluating the rest of the statement. Now, even though this value will be false, we will filter it out with our Boolean check. The problem is that TypeScript does not know that by filtering out whatever is truthy or falsy, this middlewares will narrow its type down to middleware. All it knows is that there's a chance that whatever this filters through, it may just still be some Boolean value. And this is where we essentially need to tell TypeScript exactly what this filter is doing. Listen, if you pass the truthiness of this check inside of the filter, then you are for sure left with a middleware because anything that's falsy is going to get stripped out. This is the perfect time to use what we already know, which is our type predicate functions. So we need to first import in that middleware type so that we can then utilize it in order to actually narrow the type once it passes through our check. So for this Boolean, I'm going to actually write the callback. So we know we're getting some middleware. And now we're going to narrow the type using what we know. We're going to say if middleware passes, then its middleware is going to be of the type middleware. And then we'll pass the actual middleware parameter into this Boolean check. And now if you hover over middleware, it will know. Whatever comes through and passes that filter must be of type middleware through this predicate type. So there we go. We'll notice that our error is gone. Now, one other thing we want to tighten up is this persist config. If you hover over it, you notice that it is of this type object, key of string, storage of web storage, whitelist is a string array. Now, we only want to whitelist values inside of our root state. So what we can do is we can extend upon the existing persist config. Now, from Redux persist, there is a persist config object. This is a type that contains all of the existing values that actually exist inside of a persist config. So whatever values you can actually pass to it. So we just want to extend upon this. So we'll say type extended persist config is equal to persist config of the root state. So this will pass that through. And what we also want for this persist config is we want to now narrow down through an intersection what the whitelist can contain. So we want the whitelist to only contain an array of the keys of the root state. So key of will get you back only those values inside of root state, the key values, which are of course the only values that we want to pass here. And now we can say that persist config is of type extended persist config. And now if you hover over, you'll notice that what does it say inside of persist config? Well, the whitelist value can only contain user, categories, and cart. And that's what we get from using this extended persist config. And just like that, we have now typed out all of our store TS. We have resolved all of those other issues that we saw, and we've also fixed up our middleware. So a lot of this is just practice. Once you look at these errors and these type errors, and you just really think about what it is, through the tools that we've learned, we're probably going to now be able to cover 80-90% of any new additional type errors we come across. And that's the advantage of really using TypeScript to narrow down and understand what it is each of these parts of our JavaScript code is trying to do, particularly Redux. Now that we're done typing out our store, in that next video, we'll learn how to type our own custom middlewares. I'll see you in the next video. Welcome back, everyone. Inside of any TypeScript project, there is a very likely chance that some of your libraries will throw an error where you will see here, it will say, could not find declaration file for module and then the name of your third-party library. What this means is that for that library, you need to most likely install a separate types library, which essentially will add TypeScript and typing to all of the specific required exports or modules or whatever inside of that library. So that's generally very simple. Most libraries have a @types. And in fact, you'll even see that they will tell you to suggest to try and save inside this specific library. So they'll always begin with @types / and then the name of the third-party library, if it's not automatically included in the library as a dev dependency. A lot of projects, due to the popularity of TypeScript, will automatically install those for us. In fact, if we go into our package.json, we will see that we already have a couple of these @types files. And the reason for this is because when we included Create React App, it installed a lot of these TypeScript files for us by default. So all we need to do in order to get rid of this error is yarn add @types / Redux logger. And now, once TypeScript has finished resolving this, we can now just rerun our Netlify dev just to make sure that everything is working. And now that we've saved this and we go back, there we go. We see that the issue has gone away. If we go back into our store TS, we also see that Redux logger has also been resolved. And that's it. If you ever encounter any of these type issues, again, most likely just look inside the docs for that specific third-party library. Chances are there is a correlated TypeScript module for that library that you need to install. So that's just one additional thing about TypeScript migrations that you got to keep in mind. I'll see you in the next video. Welcome back, everyone. In this video, we are going to type out our middleware. So our custom middleware is the logger.js. We want to rename this to logger.ts. And as you can probably guess, since this is a middleware, we're going to need that middleware type that we had seen from before. Middleware, of course, coming from Redux. What we're going to do with this middleware is we need to pass it some arguments, one of which is going to be the root state value that we had created ourselves. This middleware is going to be of the type middleware. Now, when you hover over middleware, what is it that it takes? Well, first, it takes some template dispatch extension. This is an extra dispatch signature added to this middleware, and you add it essentially as a type. So if you want to add more onto your dispatch, you can do so, but ours barely does that. We are never going to really modify the dispatch with this middleware. It means that if you want to add the functionality onto your dispatches, you're able to do so. Some libraries like to do that. We definitely don't need that. So for us, we're just going to pass an empty object or an empty type, saying that we're not extending it at all. The second argument is going to be the state. This is the state of this middleware, and we are receiving the root state. The third argument, we don't need to pass anything for. It's the type of dispatch. That doesn't matter. We're not changing anything. We can just leave that empty. And there we go. We've typed out our custom middleware. We're done typing everything inside of our Redux folder except for our sagas. And we'll learn how to do that in the next video. I'll see you there.